Hey everyone, Snowflake has become one of the most in-demand technologies for data engineers, analytics engineers, and data professionals in last couple of years. Over the a couple of years, I have shared a lot of informations on Snowflake either on LinkedIn or even built a Snowflake Zero to Hero playlist on YouTube. Now, one request which I'm getting consistently received from the other learners that Vishal, can you please create a single video which cover all the important Snowflake concepts end to end? Something that we can complete over a weekend and use it for interview or for a quick revisions. And honestly, I felt the same. While the Zero to Heroes playlist covers everything in detail, so I thought that maybe I should combine all the key videos in this complete 10-hour long videos, which is going to be required to be like to get confident in Snowflake or to help you in clearing the interview. So this is exactly why I'm creating this 10-hour long Snowflake masterclass where I'm going to talk about the traditional big data challenges, Snowflake introduction, what and why Snowflake architecture, account setup and pricing, virtual warehouse, type of table, file formats, stages, copy into command, and integrating with AWS, error notifications, time travel. So, what all you should know as a data engineer or a data analytics, in this video, we are going to cover these core topics. And the goal of this video is simple to help you understand Snowflake end to end, revise the platform efficiently, prepare confidently for interviews, and become productive in your next Snowflake projects. So, whether you are a beginner starting a Snowflake journey or an experienced professional looking for a complete refresher, this video is designed to help you learn everything in one place. So, let's get started. Okay, now imagine your organization has more than 500 terabyte of data, which spread across multiple systems. Every morning, business users complain that dashboards are taking too long to load. Data engineers struggle because ETL jobs are competing for resources with reporting workload. Data science wants to run large scale analytics, but the database team is worried about performance impact. And infrastructure team are constantly managing server, applying patches, planning capacity, and upgrading hardware. As the data grows, the challenges grow even faster. And this was the reality for many organizations which were relying on the traditional on-prem data warehouses. We were having limitation like limited storage capacity, high cost, limited processing capabilities, no scalability, failover applications, and data security. And this is exactly the problem that Snowflake was designed to solve. So, Snowflake is basically a cloud native data platform which built from the ground up for the modern data era. In this, we do not need to worry about anything to install anything like any hardware, any software. We don't have to manage anything. You just need to go to the snowflake.com, create your account, and everything like a storage and compute, everything you will be getting, it will be managed by the Snowflake. So we have zero maintenance, no software installation, configurations, and manual tuning required. Snowflake completely handles this dot. Automatic upgrade and optimizations again managed by Snowflake. Which this is a cloud native architecture, which means operate entirely on public cloud infrastructure by leveraging a virtual compute and the cloud storage. So whatever the cloud you are going to choose on, like whatever the cloud you are going to host a Snowflake, underlying Snowflake is going to use their storage and the compute power, and it is going to be always up to date. So Snowflake ensure the seamless software installations, update, and management user focus on data, not infrastructure. Now you can see the diagram that this is a complete Snowflake flow. If anything asks you that Snowflake is just a data warehouse, no. Snowflake is basically a complete Snowflake has evolved in last couple of years being just a traditional data warehouse. Today, Snowflake serves as a complete data platform, which is capable of supporting an organization's entire data life cycles. If you wanted to use for data warehouse, data lake, data engineering, data exchange, data applications, even data science or AI purpose, everything can be taken care by the Snowflake. So this is a single platform for any workload, which is going to provide you secure and a governed access to all data. It give you unlimited performance and scalability, and you can see that you can get the data from these many data sources. Either you can do the ETL or streaming, load into the Snowflake as a data warehouse, data lake, and all that. And then we do have this data exchange, data applications, and you can then, after the data consumers, they can use it for data monetizations, reporting, analytics, and even for the AI and all that. In recent year, Snowflake has expanded even further into areas such as application development, machine learning, and generative AI. We have now the Snowpark. We can even write the Snowflake notebook where like you can perform exploratory analysis and collaborate using a notebook experience similar to Jupyter. We have Streamlit where you can build an interactive web app directly on top of their Snowflake data without managing a different infrastructure. And now, with the Snowflake Cortex AI, organization can leverage LLM for summarization, sentiment analytics, document processing, text generation, and other AI-powered use cases. And all by keeping your data securely within the Snowflake ecosystem. And this is why many organizations today view Snowflake not just a data warehouse, but as a complete data cloud platform, which is going to enable business to ingest, store, process, govern, analyze, share, and even build AI powered applications on their data from a single unified platform. So, whether you are a data engineer, analytics engineer, data scientist, or AI engineer, Snowflake provide the complete tools or capabilities which is needed to support modern data driven organizations at scale. So these are the some advantages. We can see hassle-free setup, high availability and security, pay-as-you-go, cloud native, near zero downtime, elastic scalability, fast data retrieval, zero management, seamless collaboration, time travel, and fail-safe. And we are going to see all these in the detail. Okay, so what makes Snowflake data warehouse unique? So if you have been asked in interview, hey, can you please tell me the couple of Snowflake unique capabilities? You can mention about that it provides the serverless compute, it has a paper uses, the storage and compute are separate. It has intelligent caching features, time travel, zero copy clone, and now we do have workspace. Okay, and these are the some new features, or like I won't be saying it's a new feature because it's been a couple of years now into the Snowflake. But if you have see my YouTube playlist, then in the Snowflake introduction I might not have included that slide. So we have Cortex AI. Now we do have OpenFlow integration, which is built on Apache NiFi. So you can write your, or you can basically create a ETL, ELT pipelines within the Snowflake only. We have DBT project support. So you can do all the transformations within the Snowflake, and you don't need any DBT core or like DBT cloud. And then we have the Snowpark, which is going to enable, going to help you to write your Python, Java, Scala development directly inside the Snowflake. Okay, so basically these are the main capabilities of the Snowflake we do have. So this is what the Snowflake make data warehouse completely unique. Now if I focus on that, we will be having other things also which we are going to cover in the next videos, like what is the Snowflake architectures, how it works, and what are the pricing and all that. Okay, in the next video, that means like in the next part. Okay, before learning any new technologies, what I believe, like you and me and everyone should take a deep dive of the architecture, because it is very crucial. It is very crucial to understanding the architecture and knowing how it functions. Architecture of any technologies provide a framework for understanding how different components interact. This is going to give you a bigger picture that how each piece fit together. Understanding how the architecture work enable you to leverage features and capabilities effectively and maximize the tool's potential. If I would be having a good understanding of the architecture, and if my team is saying that hey, I'm getting some kind of a problem, or if we got basically some issue, I can basically pinpoint that where the problem may be occurring, and I can quickly diagnose it and resolve it. So, in summary, delving into the architecture of a tool not only going to enhance your immediate understanding, but also going to equip you with the knowledge that will benefit you in the future product and the technologies. Okay. As you can see in the diagram, or you can see over the screen, the Snowflake architecture, where these are there are the three main layers. But before understanding or before getting a deep dive of these three layers, let's understand one or two line. The Snowflake is basically a combination of both shared disk and shared nothing system. Like shared disk, it has a central data repository where all of your data will get stored and that all compute node can access. On the other hand, it also use shared nothing principle by processing queries with MPP, which means massively parallel processing. So each node hold part of the data locally. That this design simplifies data management while providing the performance and scalability benefit of shared nothing. Okay, so in simple word, we can say the Snowflake architecture is basically a hybrid architecture which is combination of shared disk and shared nothing. Now come to this diagram. We can clearly see that Snowflake architecture is comprised of three main layers. The first one is the cloud service layer, which is also known as the brain layer. The second one, we have a virtual warehouse layer that we can say compute layer. And the last one, we have a data storage layer where all our data will get stored. Now, what are the main responsibility of each layer? So far, because we haven't created a Snowflake account, so I won't be directly showing over there. But in our next videos, I'll definitely take you to the Snowflake account, and then I'll show you which layer is coming in the picture. So far, like in second or third video, and probably in couple of next video, we will be talking about theory parts. So bear with that. But after this, everything will be on live and the practically, and that will give you a good confidence. So let's discuss about the cloud service layer. As I mentioned, this is going to be the brain layer. And we can see the responsibility of the cloud service layer. The first one is the authentication and access control, or I can say authentication and authorization. Now, let me give you one simple example. If I'm going to join a new company today, I'm going to just wake up this morning. I'm going to dress up beautifully. I booked the Ola and reached over there. As soon as I'll try to enter into the premises of that new company, the guard will immediately stop. Guard is going to immediately stop me because I don't have an ID card. So either he will be asking, sir, do you have the ID card? Or if not, then please do let me know why you are visiting this. Just tell me the purpose to visit. In this case, I'm just going to say, hey, this is going to be my very first day, and I have a joining, something blah blah blah. The security guard is going to check it whether he got any intimation from this HR or any admin team that yeah, this guy is going to join the office or not. So that is basically authentication. Now he is going to check. So in terms of the clouds, in terms of Snowflake, whenever I'm going to provide my user ID and credentials, like whenever I'm going to provide my username and password, the cloud service layer is going to validate whether I am putting my username and password correct or not. If any of the like a name or password is incorrect, cloud service layer will immediately stop me outside of the premises. Now, once my password is good, password and username is validated, I'll come into the Snowflake premises, I'll come to the Snowflake UI. But now what? Account admin or the admin, like let's go back to the same the previous example. Admin of that company has not given me any right. That means he hasn't given me any access card so far, so I'm just standing or I'm sitting at the reception area. Now the receptionist just called me, hey Vishal, just come here, and this is going to be your temporary ID card, and take it and go to the reception or go to the induction room. So they are giving me just authority to go to the induction room only. And that's how the access control work. So account admin in my Snowflake will provide me the access of some databases, some warehouses, some tables, and those would be the different type of access depending on my roles, depending on my responsibility. So if I'm going to try select star from customer, or if I'm going to try to enter into a different room into that premises, my security, my access card will not allow me to go inside any other meeting room. So similar thing happen into the Snowflake. If I'm going to write select star from customer of any database which I don't have authority or I don't have the access, cloud service layer is going to give me an error. Either the object doesn't exist or you don't have the authority to access this table. So the first and the major responsibility of the cloud service layer is authentication and access. Next, it manages the infrastructure. It manages the metadata. So whenever we are going to store the data, all the metadata like a table name, table count, the micropartition count, the main max, everything is managed by the cloud service layer. Other than this, data sharing, security, query optimization, infrastructure management, so all these things will be managed by the cloud service layer. So let's see this into the details. Okay, so it also include the management function for handling infrastructure, metadata, as well as performing query parsing and optimization, among other features. And that is why we call it as a brain layer. Okay, so cloud service layer manages data security for data sharing and everything. Like, okay, you can just consider whatever an admin guy will be doing, or a CEO of any company would be like giving you the access and all. Just consider this cloud service layer is going to perform all these things. Next thing is, in my architecture, I can see there is a virtual warehouse. So do not get confused with the term virtual warehouse. If I am going to say it, like I definitely will be saying it hundreds of time in my entire this Snowflake series virtual warehouse. So this virtual warehouse is basically a compute machine. Do not get confused with the data warehouse. Data warehouse is a place where we store the data. Virtual warehouse, which is going to help you to load the data, query the data. It's basically a compute machine. Okay, now in the Snowflake, we have this compute machine, this virtual warehouse. We can have multiple warehouse from the different sizes. What does it mean? The smallest size we have is extra small, and the largest we have 6XL. So in Snowflake, I can create my warehouse extra small to 6XL depending on my load. I will be creating a separate video on this virtual warehouse. So let's focus only few things which you need to know at this stage. Now, any one of you may have this query that Vishal, if I am having the Snowflake hosted on AWS, then is it Snowflake who is going to responsible for creating this virtual warehouse, or I have to do and I need to go to the some like a AWS or to the cloud provider? No, this is all the responsibility or all activities will be taken care by the Snowflake. But yes, if you have hosted your Snowflake on AWS, then it is going to be your EC2 machine. But can we check that EC2 machine? What are the under the hood configuration and all? No, we cannot check it because this has not been disclosed by the Snowflake. If we have hosted a Snowflake on Azure, then it is going to be Azure VM or Google VM, depend like in the Google Cloud. So we can have a multiple warehouses, and one of the good feature is that every warehouse is independent of each other. So we can say we can scale independently each other without impacting the other or the adjacent virtual warehouse in the Snowflake. Okay, now if I have some data into my Snowflake storage layer and I need to retrieve it, I need to analyze it. For that, I would be requiring a compute machine, and that compute machine will be provided by this compute layer that called as virtual warehouse. And trust me, it is very easy to create a virtual warehouse here. This is definitely going to be just a child job, but understanding how we are going to create, what are the parameters value we need to set it, what would be the ideal size of the warehouse, that is very, very important. Some of you will not be able get a chance to create a warehouse in next couple of years, but those who are going to have 8 or 10 plus years of experience, you might be working as a sysadmin or security admin in your new role. There you have to take care of it, because ultimately if you haven't choose a right size of the warehouse, then it is going to give you a problem, not only just into the performance but at the cost also. So we have to maintain a perfect balance between the cost and performance. And as I mentioned, I will be creating a story, separate video on this virtual warehouse. Okay. So Snowflake unique architecture, which allows us the separation of stories and compute. That means any virtual warehouse can access the same data as another without impacting on performance of other warehouses. Okay, got it? I'm sure you would. And if you would be having any queries, feel free to drop your queries into the comment box, or I will be dropping my email address into the description. There you can reach out to me. Next thing is the data storage layer. As it by the names, you will be getting it that this is the layer where my entire data will be getting stored. But under the hood, where exactly the data will be stored. So as I mentioned, that in case of AWS, if my compute layer was EC2, so again, my storage will also be on the AWS data lake, which is S3. But one important thing, if anyone asks, can I see that? No. Can I access that? No. You can only and only access by running SQL queries on Snowflake. It is not visible to any customer. Okay, and also if you think that I do have an AWS account, can I host the Snowflake on the same account? No, Snowflake under the hood will be creating its own workspace, and you will not be knowing it where it is created. Okay, so data storage layer where my entire data will get stored, and I would not only be like able to ingest the structured data, but also can structure semi can also can store the semi-structured data like CSV, JSON, XML, Parquet, ORC. Okay, in this, and my data will be stored into the compressed format, and it is optimally going to be organized into the small chunks that call as a micro partitions. Snowflake take care of it every by own. So here, if I'm going to store 1 GB of file, that will automatically be converted in small chunks or portions that will be known as micro partitions. Micro partition size is 50 to 500 MB, and those are immutable. That means if one micro partition has been created, now if you try to update one value or one column value of that micro partition, it is going to create a separate partition. Okay, so again, this micro partitions we will be understanding in the detail in the later sections. Okay, so consider about the data storage layer. This, it is going to be centralized hybrid columnar format. Data will be optimally reorganized. Data will be stored into the columnar format, and it will be compressed. So 1 GB of file may become 500 MB, 700 MB, or 600 MB depending on the Snowflake mood. Sorry, not the Snowflake mood, depending on how your data is. Okay. So the Snowflake can also handle structure as well as the semi-structured data. Here, your data is going to be encrypted using AES 256 encryption, and that will totally handled by the Snowflake. Your data is going to be on AWS S3, which me, you, Katrina Kaif, Salman Khan, George Bush, no one can see that. Only the Snowflake, only you can query that data by writing the SQL on the Snowflake. Okay, now one of the two main feature of the data storage layer is time travel and the zero copy clone. Again, we will be discussing these two topics into the later section. Okay, so if I give you a small concise way of the Snowflake architecture, so we can say the Snowflake is basically combination of shared disk and shared nothing architecture. It separates the storage and compute activity, which result we can scale up them independently without impacting the other warehouses performance. It is a multi-cluster shared data architecture, and that is elastic in nature. Now, if you will quickly recap whatever we have learned about these three layers, you see the storage layer, it's going to be your underlying cloud storage like a S3, GCP or Azure Blob. The processing is going to be on EC2, Azure VM or GCP VM, and cloud service layer, which is basically main or brain layer, but this will also be on the same cloud. Okay, storage, one of the good thing is you can store infinite data, structure or semi structure of both type. You will not be running out of storage. Okay, then the stored data will always be compressed and encrypted. You just at this stage you just go through with this line that okay, that storage bill will be $23 per terabyte, but we will be understanding that into the new video, like where I will be talking about the Snowflake pricing in the details. Next thing, let's store data into the hybrid column format. Similarly, you can see that the processing layer, which is a query execution, it's going to be give you a virtual warehouse. It's also known as virtual warehouse layer. Each warehouse has no impact on the other performance, and the compute bill will be generated depending on the warehouse size. Basically, here we have a unit called credits. So Snowflake generates some credit. If I am running my warehouses for 1 hour, it will be generate some credit, but depend on the warehouse size. If it is extra small, it will generate one credit. If it is 2xl, 3xl, like if it is small, then it will be 2. Similarly, for medium it is going to 4, large 8. For xl it is going to be 16 credit for 1 hour. So that is why it is very important to understand what is going to be the ideal size for this requirement for this load, because it is going to be very, very problematic for you, and you will be ending up paying a dollars of bills. Understand? Okay, sounds good. I hope you have got a good understanding of the Snowflake architecture. But if you still have some queries or some questions, you are free to drop your queries into the comment box, and you can even reach out to me on my email address, which I will be giving in this description. Now, in the next video, we will be talking about the Snowflake pricing, and we will be setting up our Snowflake account. Thank you for watching. Please subscribe if you haven't. Possibilities of each layer. Now, to set up a Snowflake account, we just need to go to the snowflake.com, just like you can see on my screen. And here on the right hand side, you see the start for free. Click on this and you need to fill this form. This, just like we're going to create account for any other let's say portal or any other website like a Gmail or Facebook, we just need to give the basic information. We need to provide a name, we need to provide an email address, company name. So you are just going to fill all these details. So let me just give these details. So my first name, I'm just going to use my favorite. This is Megan, and folks, and her email probably would be megan.fox@gmail.com. Make sure your email address should be correct, because Snowflake will be sending everything on this email address. So like all your account address, your notification and any releases, everything will be communicated by Snowflake to this email address. Next, the company name, you can say XYZ. This like doesn't matter whether you're going to give your right email, right company name or not, and any role, and then your country. So Megan is in India or US. I'm just going to choose India. That's it. And then we'll just press to continue. So in the next, we're going to see that, hey, it is going to be my 30 days free trial. So, and or it's just going to give you $400, which I'm sure we are not going to spend this much, but make sure that you are not going to keep your warehouse active. And that's why we will be understanding the pricing, how it works. Now we are going to choose our enterprise edition. Why? Because it is good for our like for this training. It's not going to be standard. Otherwise, we won't be able to practice multi-clustering, Materialized View, and time travel and some other things. And also not going for business critical, because we don't have some sensitive data, so that we will be applying some kind of a security and some failover, and these some like replication failover. We are not going to implement all these things. Okay, so I'm just going to choose my enterprise edition. Then I'll go to the AWS, and then I'll go to the US region. Why US region? Because whenever any of the new features comes into the Snowflake always and always rule out on the AWS and US region. Now you're just going to click on check and get started. Once you're going to click on get started, it will be asking for some of the questions, some of the survey related questions. Let me just go to this, get started. And you see here, this is going to be all the questions. So you just need to click on skip and you will be getting an email. I'm not going to continue it because I already have created an account. So, you all will be getting an account. You all will be getting an email from the Snowflake. So I'm just going to close it. But what kind of an email you will be getting? I'm just going to show you in my Gmail. So this is going to be the email which you will be receiving from the Snowflake site. So that would be like a subject, activate your Snowflake account from Snowflake Computing. And there you see click to activate. Now in this one, click to activate, you're going to click on it. And this is going to open your account URL. Once you click on this, click on it, and it's going to open a new window for you. There you need to give the account name, username, and the password. So I have already created my username and password. So I'm just going to sign in. So once you're going to sign in, I'll show you that how your window is going to be look like. So it is getting refreshed, and this is going to be okay. So it's already one. Okay, I'm not going to show over here. So this is going to be the home page. Okay, so whenever you are going to set up this account, every one of you will be getting it, but not like this, because these the worksheet. This is basically recently used. That means that I've been actively working on it. So here you won't be seeing some worksheet. You will be seeing only and only some shared worksheet, which is provided by the Snowflake. So some of the sample worksheet you will be like getting over here, but this home will be there, the snowflake icon would be there, and in the left bottom you will be seeing your name and your role and some of your account information you will be getting over here. And then we have this home button, search, project, data, AI and ML, monitoring, admin. All of these options are there. We will be covering it. Okay, so I will be covering in the next video. I just wanted to make it very short. So in that we will be taking entire snow site UI tour, and what is important for you, and where we will be we will be focusing more. Okay, once you are done, and then that's it. So basically here, if I just go to click on SQL worksheet, and there you can write your queries. So it is going to be as simple. I do have some of the databases, but you would be only and only seeing Snowflake and Snowflake sample data. Okay, so these comes with by default. You would be having an account admin role. We'll be talking about the roles as well. And here you can simply do run simple queries just like a plain normal SQL. So I'm just writing create database, and this database is going to be my YouTube database, YouTube training. That's it. And I'm just going to hit the enter. To run this query, to run any statement, you just simply press Ctrl or Enter, or you can go to this here in the right top. You see this blue icon, you just need to click on that, and that is going to run your query. Now, as soon as I'm going to create my database, it will give me two schemas. So here, one is the public schema. So I'm going to refresh it one more time so that you can see that the database will be there. And along with that, there will be two schema. One is the public and second is the information schema. So these are the by default which get created whenever you are going to create your database. But if I wanted to create any separate schema, so here I'm going to write create schema, and that schema I can say this is my raw data. And that's it. My schemas raw data successfully created. So just consider this is going to be your result pane. This is going to be your query your task history, or basically query history pane, where you can see how much time it took, whether it was successful or it was failure. And this is your query ID, which will take you to the query profile where you will be seeing everything. And on this, it is going to be your query editor. This is basically your context. Again, we're going to talk about that in details. But now, as I mentioned in the starting of the video, we're not just going to set up a Snowflake workspace, but we will be talking about the Snowflake pricing also. Okay. So in the Snowflake pricing, there were two major parts. One is the storage, and second is the compute. One of the good thing about the Snowflake is that the pricing the storage and the compute both price calculated separately. What does it mean? Okay, and how it is going to be beneficial for you. What if I am just going to use for my like to storing my data, and I'm not like analyzing this, I'm not writing too many of queries, I'm not like even creating any reports, just doing some proper like just doing some small analysis, and I'm just going to store it, then I will not be paying anything related to the compute. Or if I'm just going to run some solve statement, then it will be like a bare minimum. Then I will be paying for the storage. But what is the storage cost? If I'm going to store 1 terabyte, how much I need to pay to the Snowflake? And if I am going to run my queries continuously for 1 hour, 2 hour, 3 hour, how much I would be paying to the Snowflake? So how would I know it that if I'm going to store 5 terabytes in a month, and there are 5 users who are actively working on the Snowflake account, then can I know that, okay, there would be some kind of estimation that these many dollars I would be paying to the Snowflake. Okay, so let's get started. For this, to get the more clarity on it, you'll simply go to the new URL, which is snowflake.com/pricing. So here we will be getting a complete clarity about the Snowflake pricing. One of the good thing is that here you can compare the price to the cloud and the reason wise. Now, if you will look at it, just scroll down and here you see the platform and the reason. You need to basically choose either any platform or reason. So if I come here and just scroll down a little bit, I'm choosing my AWS reason, and that is US East or US West. Suppose I'm going for this US East only, and there you see standard, I need to pay only $2 per credit. In enterprise, we need to pay $3 per credit. In business critical, we need to pay $4 per credit. And for the fourth one, which is a virtual private Snowflake, and this edition was not coming when we were setting up the account. Why? Because for this, you need to reach out to the Snowflake sales team, and then they will be helping you to create this setup environment for you. However, we will be focusing on this credit part for these three additions. You see here, the standard is $2 per credit. What does it this credit mean? I mean, how I'm going to know, how I will be knowing it that these many credit I have consumed? It's a $3 per credit. So this is basically depend on for how long you are going to run your queries, or for how long your this data warehouse is active. Sorry, virtual warehouse. I'm not this virtual warehouse you see here. So if I'm going to run my virtual warehouse for 1 hour, then I will be generating some credits. But how many credits? What would be the minimum billing if I'm just going to run a one query which is completed in 1 minute or 2 minutes? Would still Snowflake take some credit from me? If I'm running these credits like just a DDL statement, will I be generating some cost? Okay, let's understand this. So first thing we see here, it is $3 per credit, but that is only and only for AWS this reason. If I'm going to change this reason, you look at it, if I come to here and make it to EU, and then you see the price got updated. Earlier, it was 2, which become 2.6. It was 3, which become 3.9, and it is 5.2. Similarly, if I go for any other reason, let's say for Azure, and here if you will look at it, this is a central India, and I will be having a separate cost. So make sure if someone asks that what is the pricing of the Snowflake, what is the compute pricing of the Snowflake, it varies from region to region and cloud to cloud. In case of Azure, like mostly you can say in enterprise edition, it is going to be close to $3 per credit. Okay, and then the next thing is the storage. For the storage price, if you will scroll down and you see here it is a on-demand storage, which is $25 per terabyte per month. If I'm going to store 1 terabyte for a month, I need to pay $25 to the Snowflake. And if I scroll up, then if I'm going to change it to the AWS, then you will be finding it at $23. So in general, you can say like it is a $23, $24 per terabyte per month, depending on the cloud and the region.
Even if in the AWS, if I'm going to make it to another region, let's say this EU again, EU Frankfurt, and you will be seeing this has been updated. It's 24.50. So this compute and the storage price varies from region to region and cloud to cloud. But we can say in general, the storage cost will be somewhere around 23 $24 per terabyte per month. That's how much I need to pay to the Snowflake for storing the data. Now, let's understand this compute part in the details. This compute, there you see here, this credits, this is basically your compute cost. So compute cost basically, like whenever we run a warehouse, compute cost will be completely based on when I'm going to run my virtual warehouse in nothing but a cluster, basically we can say. So this virtual warehouse will be generating credits. But how much credit it will generate in 1 hour, how much credit it is going to generate in 30 minutes. And if I'm going to choose, let's say this is the smallest size. If I'm going to make from small to 5XL, 6XL or 2XL, how much I will be having, like how much I will be paying to the Snowflake. So this basically depend from the size to size. Now, to give you this, I would love to mention it. Okay, it's not a table. Otherwise, I would be creating it. So basically, this warehouse size and this is the credits. So your credits is totally depend on the size of the warehouse which you are using to execute your statements. What does it mean? That here you see it's a compute warehouse. I'm running this small size, or I can go for compute machine, which is extra small. So extra this Snowflake virtual warehouse sizes varies from extra small to 6XL. Just like we have a t-shirt size, so it comes in the t-shirt size which is extra small to 6XL. So if I'm going to use my extra small warehouse, let me see if I can write some online Excel sheets. Can I create it something? Or let me see this blank Excel. Okay, let me just look at it. If I can create it something. Or okay, Google Sheets. Let's just go to the Google Sheets here. It should be sign. I do have this Google Sheet, right? Okay, never mind. I'll just come back to here. So this warehouse size, first we have extra small, then we have a small, then next is medium. After that we have a large, we have large size of warehouse, then extra large, then 2XL, then 3XL, similarly 4XL and 5XL. So if I'm using extra small warehouse size and I'm running it for 1 hour, then it is going to generate 1 credit. So I can simply say that it is going to generate 1 credit per hour. Then small 2 credit per hour, and medium is going to generate 4 credit per hour. Okay, similarly large would be 8, 16, 32, 64, 128, 256, and 6XL is nothing but is going to generate 500 credit per hour. But how would you verify this? How you are going to trust my words? Let me just show you. So I just come into this admin section, and here we see the warehouses. This warehouse is nothing but a virtual warehouse. So I'm going to click on plus warehouse, where I'm going to create a new warehouse. Now look at this. This is going to be my test warehouse. And there, the next thing is I'm going to choose the size. Now look at it. If I click on this arrow, and here you see extra small 1 credit per hour, small 2 credit, medium 4 credit, large 8 credit, extra large 16, 2XL, like 32, 128, and 5XL 256. Although, I don't know why the 6XL is not coming in my account. I will be reaching out to the Snowflake team, Snowflake sales team, the support team, sorry. But yeah, you will be seeing a 6XL. Okay. So what does it mean if I am going to continue my, if I keep using my Snowflake for 1 hour by using extra small, then I just need to pay one credit that is equal to what? That is equal to these many dollars. Okay, so similarly, like in simple words, I can say I'll just go to my home button. We'll go to this worksheet. So extra small is going to generate for me because it's an enterprise edition and it's a US region. So $3 per hour will be my compute billing if I keep running the queries, if I keep active my warehouse. Small is going to generate $6 per hour. Similarly, for like a medium is going to generate how many? $12 per hour. Like this, you can do your mathematics. Okay, so you just need to multiply by 3. So 6XL is going to be almost 1536, which is huge. So that is why it is not recommended by Snowflake that, okay, if you have some kind of a complex load, then directly jump to the larger load. No, you need to start with the smallest. Either you go for extra small, small, or medium, and then analyze your load. So this is going to be a detailed session on the Snowflake virtual warehouses. In this video, we are going to understand how the Snowflake virtual warehouse sizes, like basically the admin is going to give you this, decide the size of a virtual warehouse, how the pricing will be calculated, what are the other parameters which is going to help you in your longer way or in your basically like in your day-to-day activities. What are the like how the Snowflake virtual warehouse handle the large load, how it provide you the scalability, everything we will be understanding here. Before that, let me just take you to this document. What all you understand about the warehouse? In a normal term, this warehouse is basically a central repository where we are keeping our data, right? You all have been coming from a data warehouse background, you know it, it's a central repository, it's kind of my Teradata, it's Oracle, and I'm keeping my data over there, and it is like I'm extracting from heterogeneous sources, and then further it is being used by the reporting people or data mining and all other purposes. But here into the Snowflake, whenever we are going to speak about the warehouse, we are not speaking about like a central repository. We are talking about the machine. We are talking about the compute power, which is going to help you to load the data, unload the data, and query the data. Understand these three main purposes: query the data, load the data, and unload the data. Load the data where? Into the Snowflake storage layer. Unload the data outside of the Snowflake to the cloud storage like a GCP, AWS S3, or Azure ADLS. Okay, so this here we get the different size of the virtual warehouses. If I come to my Snowflake window here, if you go to the home page here, in the home page section, you need to come to the admin. In the admin, you see the warehouse sections. Okay, this warehouse section, get it over here, and you will be seeing all your warehouses. Okay, before going that, let me just repeat whatever we have just going to give you one liner. So this warehouse provide you the required resources such as CPU, memory, and temporary storage. So if you wanted to perform any of the operations, if I wanted to load the data from outside into the Snowflake, I would be requiring this virtual warehouse. If I wanted to perform DML operations such as delete, insert, update, or merge, I would be requiring a virtual warehouse. If I wanted to load the data, copy into location, copy into table, for that also I would be requiring a virtual warehouse. But one thing which I did not mention here, I mentioned the DML copy into location, but what about the DDL statements, right? If I'm going to write a create table, the customer, and then if I run it, Would it be requiring active warehouse? No. So all the detail statement does not require an active warehouse. However, this is great. This error is showing because we don't have any active sessions. So for that, I'm going to select my YouTube learning, and here I can simply select the raw data. Now, if I'm going to run it, let's just see it quickly. Right now, how you will be checking your virtual warehouse is active or not? You can see that if this is green, and even when you're going to hover on top of this color, you will be seeing this is the started. But I can just quickly suspend this warehouse. So from status to suspended. Okay. Now you see it turned gray and it is suspended. So if it would be requiring an active warehouse, it should automatically turn green. And how it automatically turn green, we will be understanding in next couple of minutes. So now look at it. If I'm going to create table, this is sleeping, right? There is no change in the position. So for the detail statements, there is no need of an active warehouse. Next thing, if I'm going to write some select clause, select statement, I mentioned here executing select statement that required compute resources. What does it mean? I even mentioned not all select statement require an active warehouses. So just focus on this part where I'm writing select count star from, I'm selecting from a sample data. Look at this. When I executed this one, it took only 55 seconds to give me the count, and my warehouse is still not active. It is sleeping. Okay, so it is not mandatory that for all the select statement you would be requiring an active warehouse. Okay, so have this clarity in your mind. The detail statement does not require the warehouse, and also not the select statement where we are selecting a metadata. Those also not require an active warehouse. But what definitely will be requiring a warehouse when we are performing the delete, insert, update, merge, copy into table, copy into location, select those complex query. There you will be requiring this warehouse. Okay, we'll see that. You will be like getting clarity in the future, like in next couple of minutes. Now, the next thing is how I'm going to decide the size of the warehouse. What are the other parameters we have it? If I'm going to write any query, let's suppose there is a requirement that I need to select my data. Okay. If I need to select from any random table, I'm selecting from here only. This time I'm writing the line item, but I'm writing select star and I'm writing limit 100. Now you see, when I just executed a select statement and you see this warehouse turned green and it is started. In fact, if you will look into the query details, there is a three colors. One is the compilation, which basically cloud service layer checked everything, that the code is working fine, whether we have access, means the particular role has access of this table or not. Second, it checked for the query result cache, the result into in its own memory. If the data could not find, then it came to the cloud service layer, came to this compute warehouse and asked him, "Bhai, wake up because I have something for you." And then he woke up and then executed the query. He got the data from the storage layer. This is how the query execution flow. Okay, now we can see that. But if I'm going to write the same statement one more time, then how much time it's going to take? Took only 67 milliseconds because that is basically the result cache came into the picture. And for this query, I did not require an active warehouses. Okay, so the select statement also, if I'm writing some complex query for those select statement also, I may not be requiring 100% of the time active warehouse. Although it is like a spin up, it is already there, but it will take some time to go back into the sleeping position. Okay, now what is this result cache? We will be discussing in the next video. Okay, why it took only 67 milliseconds? Don't worry about that. Okay, now let's come to the admin portal here into the home page. I'm sure you will be having your trial account, so that is why you can see this. You can see all the options here. If you are going to use any custom defined role, you won't be seeing some options here depending on your permissions. Okay, now let's come to the warehouse section. In this, I see the three warehouses, but I will be creating a a new warehouse from the scratch. So if I click on this plus warehouse, and there, the first thing I need to give a warehouse name. Let's say this is going to be my YouTube learning warehouse. Now what? This is just a name. It's very simple. Anyone can do that. Next is the head comment. This is just for your purpose, like for your audit purpose or for your tracking purpose. Why I have created this warehouse? If let's suppose I'm coming back to my account after 5 months and there are 20 or 30 warehouses where I have given the permission to multiple users to create it, and I wanted to know why this person has created this warehouse. So at least I'm just getting uh, adding one comment. I'm creating this warehouse to use for my YouTube videos. That's fine. I'll get to know. So this is just a comment, right? But now let's head to the next settings. First one is the type. So I do have a two type of warehouses here. One is standard and second is the Snowpark optimized. For our training, we're gonna use the standard only, and in fact 70 to 80% of the time, because this like Snowflake majorly gonna use for your data warehousing purpose, for your data engineering purpose, the standard will be perfectly fine for you. However, if you want to perform some machine learning like activities and some machine learning work, then the Snowpark optimized is best for you, because it gives you a larger memory and the larger cache, which is like definitely going to help you in the performance. But this is completely fine. We are just not going to not going to perform any machine learning or something like in this particular learning. We will be focusing on majorly into the data engineering and data warehousing side. So I'm going to use the standard one. Now next one we have is the size. So in this size, like you see, it varies from extra small to 6XL. Like here 6XL is not showing up, but my warehouses, Snowflake virtual warehouses sizes varies from extra small to 6XL. You will see here in the documentation, the warehouses is basically varies from extra small to 6XL. This document is also like older, so that's why you're not seeing over here. Okay, now this extra small is taking 1 credit per hour, and then 5XL is taking 256 credit per hour, and 6XL will be taking a 512 credit per hour. That means I need to know the perfect size. I need to choose a right size of the warehouse for my load. Otherwise, I will be paying a huge bill to the Snowflake. It's simple. We cannot directly go to the any hotel, or we just order anything without checking the menu, right? First, we take a look at the menu, and then only we order something. So this 1 credit per hour means if I'm continuously going to use this warehouse for next 1 hour, I will be paying 1 credit. That means I will be paying $3 to the Snowflake. We have discussed about the Snowflake pricing in my previous videos. So please watch this out. And if you have any confusion, feel free to drop any comment. I will be happy to answer you. Okay, similarly, if I go for small, medium, large, you just need to multiply by 3. But what exactly it is happening under the background? So this, if I'm saying extra small 1 credit or small 2 credit, that is basically a cluster. And inside that, we have number of servers. So my extra small holds only 1 server, small holds 2 server, medium 4 server, and similarly 5XL is going to have 256 servers. Now just consider, replace the server term with the person and this warehouse term with the team. So extra small is basically one team which is having only 1 people. Then there is a medium team which is having 4 people, and next a large which is having 16 people, and those are of same configuration. Under the hood, although you will not be finding any white paper, but under the hood, it is going to have a same configuration like a 4-core processor and 8 thread. So if there is an extra large team where we have a 16 folks, then definitely that team is going to deliver one work very quickly comparatively the extra smaller small team. Yep, no doubt in this. So in this, just take a look of it. This is my extra small warehouse, extra small, which is having one credit. This medium, one cluster of four server. Look at it. This, consider this is as a team. There are four people standing. In large, we have eight people. In extra large, we have 16 people. Similarly, you will be seeing that, okay, it is a cluster, but the four server, eight server, 16 server. And if I'm using a large, because extra small is having only one people, and I told you that it is going to have a same configuration, consider that you are hiring five people from the T, like five people from a college, and you only and only give to, like going to pay them a 3.2. Like everyone will be getting a same package. You cannot just give someone as 5 or someone 10, right? So similarly here, every server is of the same configuration, so they are just going to consume the same amount of credit, because in extra small there is only one server. So if you're going to keep running for 1 hour, it will be 1 credit. Similarly, for the 2XL, there will be 32 servers, so it is going to generate 32 credits per hour. And then the final bill will come into like 32 into 3 or 16 into 3, like that. Clear? So the very first thing you need to keep in your mind that you will always and always choose this your warehouse size. You will be starting with the smallest as possible, and then you will be performing the query depending on the load, depending on the query performance. You will be increasing the size of the warehouse. Next, we have that advanced option. So what does it mean of auto resume and auto suspend? So auto resume, it's automatically resume the warehouse whenever I'm going to execute any statement. And auto suspend, it's going to suspend the warehouse just after 5 minutes of inactivity. Now let's understand into a very simple word. Okay, just suppose I am actually living in a normal house which is not a IoT enabled. I entered in my house at 9 a.m. in the morning. I got the call from my friend that bhai aja, let's go and have some party and all. Okay, but because I entered into my house, I'm living in Delhi, it's totally it's a very hot, so I turn the fan, I turn on the television, I turn on the AC, and then I'm enjoying it. It been around 5 to 10 minutes, and then I got the call from my friend, bhai aja, come to the CP and then we'll go for a party and all. Okay, I went there, but one thing, I forgot to turn off all these electronics appliances. I came back to my home at 9 p.m. in the night. From 9 a.m. to 9 p.m., everything was on. So it is going to generate some units. Ultimately, what? Not only I'm just going to pay the bill into the bar, but I will be paying the bill of those electronics appliances for 12 hours, where there was no users. No one was there. No one was actually like using those services, but ultimately I had to pay. Okay, so this is a disadvantage of not having an IoT enabled houses, or you can say like not a sensor enabled, or you can say this is the basically consequences of my being a careless. Now, consider after 1 year, I shifted in another house, which is completely a sensor based. Now, as soon as I entered in my house, my senses that, okay, there is a person in the room, and it automatically turn on the fan, AC, and television. Now, again, I got the call from the same friend, let's come for a party. And I again forgot to switch it. I switch off it, and I immediately go away. But there is a sensor. It senses that after the 5 minute of inactivity, if there is a no person into the room, immediately after 5 minutes, it is going to turn off all the electronics appliances. And in this case, I will be only and only paying for 5 minutes. So that is the same way here. If I'm going to choose the auto suspend and I'm not going to write any query, then just after 5 minutes, it is going to suspend the warehouse, and which is going to save a bill from my pocket. Sounds good? If you still have any doubt, you can just drop your comments. Okay. Now, next we have is the multi-cluster warehouse. This multi-cluster warehouse is required when we are dealing with a large number of queries, or we have an extra number of users. And that time we will be going for multi-cluster warehouse. But how? We cannot simply go, okay, no, my max cluster count should be 1, 2, 3, 4. No, I will be taking I will be understanding the load, I will be checking my query history, will be understanding the warehouse load, and then I will be deciding it. But what exactly this multi-cluster warehouse? Okay, consider one example. Okay, like if I am writing some queries and I executed like a 4 or 5 queries, my one cluster, that one person, because I took an extra small, that guy is actually busy in solving those queries. Now there is a one reporting guy who also triggered some queries from Tableau or Power BI. Then they will be going to the queue. Why? Because this warehouse, that person is actually solving those initial queries, and that is going to take some time. So till that point, though Tableau and Power BI guy has to wait for their queries needs to be performed until this gets some resources. What will happen? Those query will go into the queued mode, and then ultimately it is going to impact the performance, right? So in this case, what if as soon as there are some queries are waiting, we want the Snowflake need to take care it by own by adding some other compute machines. So here, this is going to be like kind of a multi-cluster. So if it is there, like if any queries are waiting into the queued mode, it will automatically add a new cluster, and you can set a maximum value up to 10. This is totally up to you. Now, one of the good thing about it is that if I'm going to select this as a 4 or 5, but there are very less queries that being executed, then I will not be paying for all 5 cluster. I will be only and only paying for that cluster which is in active mode. Got it? Now, coming to the next question, what is the meaning of the scaling policies? If I took a 1, this next is the 5 cluster, but what is a standard and economy? That means if my queries are being executed on the first cluster and the next query is coming to it, initially it will wait for, if my policy is set to standard, initially it is going to wait for 20 seconds. So the next cluster will wait for 20 seconds to check whether this can actually handle that load or not. If it not, then the second cluster will come in the picture and will be solving those query. So in standard, which is basically best for the performance, and it only wait for 20 seconds before spin up the new cluster. But the economy, it waited for 6 minutes and then spin up the new cluster. So economy is when we wanted to save credits. Okay, so multi-cluster warehouse is nothing but a horizontal scaling which is going to add the new cluster. And also in the Snowflake, we know this process as a scale out. But the changing the size of the warehouse from extra small to medium or medium to large, that known as scale up, which we call it as a vertical scaling. Okay, so this is how we're going to create our warehouse, and then there is a one property which is query acceleration. I will be discussing into the later when we will be talking about the performance optimization. Okay, now I'll just simply click on create warehouse. Now you see, okay, there is a 5 cluster is one of 5 cluster is active. Total 5 cluster are there, but only one cluster is active. So for this time being, I will be only and only paying for one cluster. Now, one major thing you need to understand, always and always choose the size of the warehouse by keeping one thing in your mind, that you need not only just the performance, but you also need to save the cost. So always make sure to choose this virtual warehouse size where you find a perfect balance between the cost and the performance. What does it mean? Okay, so that I mean by this, what's wrong with this? Okay, so let's suppose there is I'm taking a small warehouse, and I executed one query, this complex query. This is my complex query, okay, which is taking the data, which is reading the data from a big table which is having 100 or 500 GB of data, and in fact terabyte of data, and then you are performing some aggregation. So this one complex query took 2 hours, let's suppose. This is terabyte of data, and this again, it's a hypothetical situation. So don't just get like, oh, why this Snowflake is then taking 2 hours. Okay, again, a hypothetical situation. The terabyte of data, you're performing like a aggregation, and the join got exploded. So that's why it is taking too much time. Okay, so it is taking 2 hours. Now, for the 2 hour of the query, for this complete query, the rough calculation, you will be paying how many? Like for this one, come back to here for 2 credit per hour. So that means for 2 into 2, 4 credits, and we are using our enterprise edition. So ultimately, we will be paying $12 for this particular query, right? But you are paying $12, but it is taking 2 hours. While the business owner is saying, no, 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 I cannot wait for this 2 hours. You were using that complex query in your Tableau or in Click or a Power BI, you definitely cannot wait for the 2 hours. So then you will be trying to go like, okay, why should I not go for small to large? Let's suppose like if I'm going for this large warehouse and for the same query, I go for this one complex query because in small we were having 2 people that took a 2 hour, but in large we have 8 people, right? We have 8 people, which is almost going to 1/4 of it, means almost 30 minutes. Let's suppose it is gonna take 30 minutes. But in this 30 minutes, large how much it took? Large takes 68 credit per hour. Okay, large take 8 credit per hour. So it is going to take 4 credits because it took 30 minutes, and that also going to take $12 for that query. Now, which one we are going to choose? We need a perfect balance between the cost and the time. If I'm going to use this small warehouse, I need to pay $12, but I will be waiting for 2 hours. While if I'm going for large warehouse, I'm also paying $12 for the large warehouse, but it is only and only computing that process or completing that query just in 30 minutes. So that's how this is one thing we're gonna consider in our mind to choose the size of the warehouse. Okay, sounds good. I hope yes, you will be getting it. So this is we're gonna learn about it. However, the sum of the terms which you need to go through, I will be pasting my link of the block: scale up, scale out, warehouse size, recommendations, and some parameters. Okay, this is now if you're going to run and show warehouses, you will be finding some other parameters also. Okay, this is the going to be like, okay, we have created this YouTube learning warehouses. You can see which is the state, size, minimum cluster count, max cluster count, started clusters, their running, quit, auto suspend time, auto resume time, available, created on, resumed on, and you will be seeing some other things also, like it's an enable query exclamation. That is definitely not. And then this is a failed, suspended, how many queries is when you have suspended it, scaling policies, which is standard or economy. You will be seeing all these things over here. However, there are few other properties which you need to explore and tell me in the comments. What if my query, what if I'm going to execute some queries, but there are I wanted to give a certain limit of the statement which can be queued only. Then which properties I will be writing, or if I am going to execute one of my query and I do not want that should wait for 1 hour or 2 hour, then which property I will be setting up. So you just need to check it out for these two property which is related to the virtual warehouse, and you need to answer it into the comment section, and I will be discussing if there will be anything in my next video. So now when I'm going to log into the very first time into my Snowflake, my UI is going to be look like that. Okay, so when we have into the data pane, so we have an option to create a database either by the UI or by the simple command. I have already created a YouTube learning database for my particular information, but let me just do it from the scratch. Okay, so I'm going to right click on this plus database, and there you can create your database. Any name you can just practice DB. You can add the comment so that you can later get to know why you have created this database. I'm creating this as an account admin, but in general, This account, like you will be giving either security admin or sysadmin, they like the rights will be given to you, and only those person who has the access would be able to create it. We will be talking about the roles in future videos, but at this stage just think that I'm going to create my database, and the comment is this is for my practice purpose. I'm going to hit the create. Now, when I'm going to refresh this one, I see the practice DB. By default, I'm going to see two schemas over here. One is the information schema, and second is the public schema. This information schema is where it is going to capture all the database level objects information, like how many tables I have, how many views I have, how many columns I do have, some fields, some file formats, stages, hybrid tables, procedures, all the database related objects will be over here. Okay, so it is going to keep the metadata information, although we don't have any kind of a write permission on it. So anything which you wanted to create for your purpose, for your work, or for your exercises, they have given you this public schema. So by default, if I'm going to open a new worksheet and going to select this practice DB, it will be going to the public schema. Now, if I need to create a separate schema, I do not want it to use this public schema. So I'll click on plus schema, and then I can just simply write raw underscore layer. Any schema you name, like it's totally up to you. And I'm going to hit the create. I'm not adding any comment because I know it. This is just going to be my practice purpose, and I will be uploading a right raw data here. If I'm going to refresh it, and here I see the raw layer is there. And this privilege is because I created using account admin, so account admin is the owner and any other role cannot access it. That's completely fine. Now I'll go to the home and I will be opening a new worksheet. So in that, click on the project and click on the plus new icon, and there you can create a SQL worksheet. I have already explained about it, how we're going to create it, how you can rename that. So simply like a DDL commands. In my previous videos, I showed you how this virtual warehouse will get activated. So if I'm going to run any DDL command, then this virtual warehouse will not be like spin up. Anyways, now I need to set up the context. To set the context, I will be setting up my database. So where I'm going to create, I'm going to use my YouTube learning only. Although I just showed it to you practice TV for for you guys, so that you will get an idea. Now I'm selecting this raw data. You see the by default when I'm just selecting it, let me just do it from this, like if I'm selecting any database by default, let's say this practice DB, by default it will go to the public. Okay, so let me just go back to it, YouTube learning, raw data here. Now I need to create a table. So to create a table, I'll simply write the same command, whatever we used to write into the on-premises. Create table, table name. Okay, so my table name here, I'm going to write employee. And then I will be giving a column name. So this I'm going to give EID, and here I have an int. Now employee name, and I'm going to give the varchar. Here, if I'm not specifying the length, one interesting thing, if I'm not specifying any length here, generally you might have seen it that, okay, it's going to be 100, and then you're going to give an address, which is going to be like varchar 2000 and all. But suppose if I'm not going to give any length here, then what will happen? Okay, other than this, I'm going to say other than that, like a phone number. This is going to be my, let's say this int only. I'm going to take only these 4 columns. Okay, my table is created now. Okay, and you see this warehouse is still sleeping because this action performed by the cloud service layer. Anyway, now moving ahead, I wanted to know all the tables and this one, so I will run the command show tables, and this command is going to list down all the table whichever is in my schema. So this employee I created today, and this customer was already there. Now we can see it. This is going to be kind of a table. This table means, kind table means it is a permanent table. So by default, any table if I'm going to create, that will be a permanent table. I'll scroll to the right, and here we have a retention time one, which is again a default one, like a 24 days, 24 hours of retention time. We will be talking about that also. We, other than this permanent, temporary, transient, we have some external table, we have hybrid table, we have event table, we have iceberg table, which we will be like talking about into the next lectures. So at this stage, just focus on it. So I created a table. Now I was saying that if I'm not specifying a length, then how much length it can take. So for that, you need to run a command describe table that is going to be employee. If I do that, you see in this ename it is taking 100, but in the address it is going to take varchar. And this is 1677216 means it is going to take varchar max of your SQL server. Here we do not have this varchar max. You do not just need to specify the length. Then by default, it is going to take the maximum length of that particular column. Okay, now let me just create any table with that or with the some primary column. So I'm going to take the same one. So I can run this create or replace table employee. In this here, I'm going to write ID in primary key. That is one. I created a primary key here. This employee name, I'm going to create not null. The phone number, I'm going to write default 1 like a 999. And I did that. Now you see the table got created. So if I do this describe table one more time, I will be getting all the kind of whether it is a primary key or not. This is a default. This is not null. Yep, no label allowed. So yes, it's saying null, not allowed. It's null, yes, allowed. We have a primary key. We have not a unique key. We did not declare the check. We did not declare anything. Okay, so in this, if in a nutshell, if you will see that we do have the constraints same as the primary key we have unique key, we have not null, and we have unique key, primary key, and we have default also. And similarly, if you will look at this check constraints and the foreign key also, you can create it. But the problem is here, if you will you can declare the constraints here, but if I'm going to insert any data in this is my primary key. Now let me just perform a single insert statement. I'm sure you all are coming from a SQL background, so you know like how to write this insert statement. I'm writing insert into statement values, and here the employee ID is going to be 100 and the name is going to be Vishal, and then address is going to be Bangalore, or let me just like write NCR, and the phone number is going to be like it's already phone number is in number, so no need to specify in that, and here I'm going to write that. Now it's pretty simple because it's very easy. You're not specifying the column here, so you're just passing all the values here. But if you look at it, select star from employee. Now, when I'm going to write it, you see only the insert statement executed it. Insert statement triggered the warehouse. Now, the select statement is also going to be taken by the active warehouse. Select star from employee, the value is there. What will happen if I'm going to insert this value one more time? Because I have declared the primary key on the employee in the on-premises, it should break. But let me just do it right. But when I do it over here, it did not break. So that means Snowflake allow you to create a constraint, but it does not enforce the primary key. It does not enforce the foreign key check and default. It only and only enforce the not null constraints. Now look at it. I do have the select star from employee. I can see the value can be duplicated here because Snowflake does not enforce it. Now, if I do one thing, that insert into employee, and sorry, and then I'm passing this EID, and the name I declared as a not null. So I'm going to give this address, and then here it's just only these two. Okay, so if I'm going to give only for the values of these two columns, in the ID I'm going to pass 101 and the address I'm going to pass Delhi. If I do that, now it will throw an error. Now it is throwing an error. And why? Because I'm trying to allow null into a non-nullable column. So let's go back to here. If you will look at it, this employee name I said not null. But here in this line number 33 into the insert, I did not selected the e name. So that means I'm trying to insert the null values where, like in which column I have already declared as a not null. So Snowflake only and only enforce not null constraints, rest all not supported, like not enforced by the Snowflake. However, okay, some of you who are already aware of some hybrid table concepts, then you may be finding my statement contradictory because Snowflake has one concept of hybrid table which is used for your OLTP purpose, and there we do have a primary key enforcement. However, I'm not going to talk about it. We will talk about later. But if you are going to take any permanent table, your normal Snowflake table, there we do not have a concept of there we do not have this primary key enforcement. Sounds good. So this is how like you can create a table. You can create the data type is there. You can declare like primary key, foreign key, and you can just see that. So there you can do all your normal SQL like this select the DDL and DML commands. So there is some other DDL commands we have is the drop table employee. You can run it. Okay, we have truncate command also. You can write truncate table, and there we already have one. Let me just run it. Show tables. Okay, now one more thing. If you will check it, that I'm just highlighting the one statement, but after every statement, I'm writing semicolon because Snowflake is just going to highlight that statement and going to run that particular line. So it's a truncate table customer, so I can write that also. So this is like all the DDL and DML commands. You can perform the basic command like insert, delete, update, and all. Okay, I'm sure you all are you all would be perfectly fine with that. Although I will be like planning to take one end-to-end SQL session on this Snowflake only. Now this is fine that I created a tables, I created a database, I created a schema. But now I'm going to use Snowflake as a data warehouse. So I need to insert some data here. The data insertion in the Snowflake can happen through multiple ways, insertion ways. Now the first one is the UI. Means I will be going on here, this plus icon, and here you see the add data. So this UI option, the Snow Site UI, allow me to insert the data here. The second we have is the Snow SQL. And third we have Snow Pipe, or basically I'm writing the copy into command using external stays. And the fourth way, the how you can insert the data is using the third party tools. It can be Matillion, it can be Informatica, you can use Python and all those scripts and all. So these are the main common four ways where you will be inserting your data here. So in our next videos, we will be covering the SnowSQL, SnowPipe and all. But in this video, we will be covering this UI part. Okay, so let's look at it. Let's perform the very simple exercise. Either you go and click on plus add data, or you can go in like you wanted to insert into the YouTube training raw data. You click on this three dots, and there you will be having an option of load data into a new or an existing table. So let's look at it. I'm going to click on plus icon, and here I'm clicking on this add data. Then I have this so many options here. There we do have some options: load data into a tables, load files into a stages, Snowflake stages you wanted to create, and these were some connectors we do have at this stage. But we wanted to load data into a new table. Even I did not even create a table. So does Snowflake support this schema in for a schema? Okay. So I'll click on load data into a table. Now this is going to this is going to ask that where from you wanted to get the file. So you need to browse just like you are going to upload something on some portal. So it connect to that your particular storage. So it is going to take me to your folders like a download folders, document folders on particular folder where you can basically check for that file. You see that there is a file size limit of 250 MB only. Earlier, it was a 50 MB, but Snowflake now extended it, so it has become a 250 MB. And this is when I'm recording this video. It's on 11th of November. Probably by couple after a couple of months, they may increase this limit. I'm going to click on this browse, and here I'll go into the Snowflake input. And in this, I'm going to just select this one. This is one of the movie file I do have, this CSV file I do have. Now, in which database I wanted to create it. So this is one of the data, option how you can select it. I'm going to select into the YouTube Learning, and this is the raw data. I selected a database in schema. Now, do you want to insert into the customer or you want to create a new table? If you wanted to select, if you already have a table, wanted to insert that, you can simply click on customer. But no, this is going to be my new table. So I'm going to click on it, and there I can write movies list. That's it. I'm going to click on next. Now, when I click on next, on the next step, it is going to validate the file format and going to do the schema inference here. It is going to select a column name and the data type as per the file. Now, if you will look at the show SQL here, this is the background SQL generated by the Snowflake. This is the background SQL generated by it. So first it is creating a table. Second, it is creating this object file format. And third, it is running a copy into command, but it is running from this particular stage area. I'm just copying this one and pasting it here. Okay. Pasting it onto a different location. So you just take it. I just copied that here, and I will be showing you how this SQL is going to be executed. What is this file format? What is the stage? Everything we will be learning. Okay, so just have some just stick to the end of the series. I'm going to hide this SQL now here because this is a CSV file. It automatically selected the CSV file in the file format. Now the next, it says the number. We do have a movie ID, title, year, and genre. We have four columns over there. It selected the data type and the column, but it is showing one error. If you will look at it, auto fix column name. So it is saying column invalid character, consider enclosing in double quotes. In Snowflake, if we have a column which is having some space, then either we need to wrap up into the double quotes or just remove the space. Okay, now you see that this, as soon as I added a double quotes in as soon as I wrap the column into the double quotes, the error become disappear. It is automatically going to infer the schema, infer the data, the data type and the column name. And if I click on the load, and the next step, we will be seeing the data will get loaded. You see 9,441 rows were successfully inserted to the data. Then I'm just simply going to click on done, and here you see the data is there. In fact, if I come here into this YouTube Learning, and this is the movie list table we have created, and here I can see that. So I'll come into the column, we'll check it. Yes, these were the four columns. This is the table details. So it got created automatically by it. And this is my, not the copy history, this is a copy history here. It's showing because we did it from it. So I'll talk about that also. If you will look at the lineage, this is also get added by here, and you see this table got added, this table got loaded by this stage, and this is a temporary stage which got created by the Snowflake. If you will look at this, like going to plus, but no, there is no other dependent object on it. Okay, so if I'm going to refresh it now, you see these mundane tables and the data is there. Let me go back to this here and the detail commands. So first one, when we inserted the data through the UI, but it created some objects in the background, which is fine. The first, it got created a table. That is completely fine. You guys understand because we have already created a table. Then what is this this file format? And what is this, every parameter they are using it, what will be the significance of it, why they are using this copy into command, why they are writing $1, $2, $3, $4 and all. We will be covering all this in our next video. So in Snowflake, if I'm going to insert the data through any channel, either it is a UI, SnowSQL, SnowPipe, or from third-party tool like a Matillion, Informatica, Fivetran, we need to create the file format and the stages. If I'm not going to create it, then it will be created at the runtime. But yes, we should have these objects. So in Snowflake, the file format is basically a database level object, which is going to give you information, which is going to help the Snowflake to inform about the data, what kind of the file type you are getting, the compression method, and what other formats you want Snowflake to apply on that particular data while loading and unloading your data. What does it mean? What if I'm getting a CSV file? Then I need to inform Snowflake that, hey, I'm going to get the CSV file. This is going to have some headers, and this is my record delimiter. This is my field delimiter. If I'm not going to do it, then Snowflake is going to assume that there we have some for like some default values it is going to take, and what would be the result? Either you are going to get an error, or you will be inserting some bad records into some. It happened multiple of the time where you are like where I did not use the accurate file format, and I thought it is going to like it worked. It also ingested the data, but when I started validating the data, I found a lot of bad records into some of the columns. So we need to declare this file format, and we are going to pass all the parameters based on my data. So whatever the input file I'm receiving from the client, I'll just take a look of it, and based on it, I'm going to define the parameters of the file format. If I'm getting a JSON file, XML, Avro, ORC, or Parquet, I'm going to create a separate file format for each type of file. So the Snowflake will understand, oh yes, the Vishal is going to insert this type of file. I need to be ready, and I will be taking this data and will be inserting in a JSON way or into a CSV way. Or let me just give you one simple example. If I'm going to, someone gifted me a piece of suit, okay, and I'm going to give it to a tailor, but if I'm not specifying that I need a 3-piece or a 2-piece, or I need a jodhpuri, I need a different style, then he will be giving me a default a suit. He's not even going to give me a 3-piece because I did not mention it. I may not be liking it. I may get frustrated that, hey, what have you done? But that's not the tailor mistake. It's my mistake because I did not tell him what is my requirement exactly. Okay, so similarly, here also I will be creating a file format before ingesting the data. So let's see that I'm going to create every single thing here, every single object. This was the temporary file format created by the Snowflake. Okay, so if I just check it whether we do have any file formats or not, I'm going to run command show file formats. Right now, I don't see any file format in my current database YouTube Learning raw data schema. So to create any file format, I'm going to write create the. It is very simple to create any object into the Snowflake. You need to specify which object you are going to create and the name of it. So today we will be inserting some CSV data. So I'm going to create CSV type, or you can just say CSV1. This is going to be the name of my file format. You are free to name anything. Then next, the mandatory parameter of every file format we have is the type. If I'm going to specify CSV, then yes, we are going to provide some structured data here. That is the mandatory parameter. If I'm just going to create it, my file format is created. I haven't given any other parameters. I have not provided any other parameter. If you will look at here, we have skip header, field delimiter, or like some other parameter also. I'll give you the documentation link where you can go through. But this Snowflake is going to provide some default values for the other parameter. So if I'm going to run the show file formats one more time, I get the entry. If I scroll to the right, these are the format options. Okay, similarly, if I write describe file format and the name of it CSV1, then these are the values I have it for this particular CSV1. I do have 23 properties here. For look at it, the type is the CSV. This is the default property also. Then every values here, this is the property value provided by my side, but because I did not give any parameter, so it is exactly same as the default values here. Now let me add some values here. So I'm going to minimize the result window, and the very first thing I'm going to add here, I will be running create or replace. Otherwise, I can simply run alter command also. The type, the first one I know, my file will be having a one record, like first header. So I'm going to write skip header equal to 1. Then next would be having a field delimiter. What would be my field delimiter? It would be comma. So I'm going to mention that. Then next is going to be my record delimiter. And the record delimiter is going to be my next line. You can just mention like /r. Okay, so this field delimiter is, it can be comma, it can be pipe, it can be tab, or like depending on your data. So it's not like static. Okay, now next, after this, we will be using some other parameters. But before that, I want you to show some errors. So I'm going to create this one. This file format CSV1 successfully created, and I'm going to run this describe command one more time so that you can see what is the value provided by your side and what got updated. You see, this is provided by you and this is with the default parameter, which is fine. So let's get started. This is the file emp load which I wanted to insert into it. But one thing, we do have 9 column, but I'm going to create only 8 column into my table. I do not want this load time column because this is an audit column. This can be like one load time or loaded by, and client clearly say that I do not want these audit column in my table. I say let's fine. So let me just create this table. For that, I'm going to use some Excel. This emp ID is int and the name is varchar. Here only I'm just passing it. This is varchar. Phone number is int. We do have the address. We have varchar, and the company name is also varchar. Experience is int, and then join date is my date parameter. Sorry, the date data type. I'm gonna copy it. In fact, Control X, and I'll come here, and then I'm going to create a table. Create table emp load. Now in this, I'm going to declare all this thing. I'm gonna take this one, this comma. So first, now one more thing. In SQL Server, if you have any space into your column name, you can simply put it into the big bracket. But it doesn't work like that into the Snowflake. For that, you need to wrap up into the double quotes like that. So I give it this data type. This is all my data type here. And then I am going to experience, and this one. Oh, sorry. And my table got created, emp load. Fine. Till this point is fine. And I am going to try to insert the data into the emp load, but this time I'm going to use my file format CSV1, and then I'm going to get some error. This is for sure that I'm going to get some error, but we will be looking at it, and one by one, we are going to rectify that error. Okay, so step 1, we create file format. Step 2, we create table. And then step 3, load file using, although you will be like, either you're going to ingest through the SnowPipe or the SnowSQL, but yeah, step 1 and 2 will definitely be there. And in fact, you will be creating a stage also, but this time we're going to use a table stage, which is going to be like the default state created by the Snowflake. Now, I'm going to refresh it. I do have this raw data. Into the table I'll come, and in this table, this is this emp load. I'll click on 3 dots, click on load data, and I'm going to select this browse. So first let me just save this file, this emp load. I'll come here, I'm going to click on browse, and this is my, okay, so I'm going to click on this date modified. Okay, where it is in the Snowflake training. Yes, this is emp load table we do have here. I'm going to click on open and click on next. So it's pretty easy. We have seen it into the previous day also, but this time when we come into this space here, now you see the error, but no, we are first going to get my file format. So you see here, when you're going to click in this file format in the left hand side, you're going to get this option file format in the current databases. So we have created it already. I'm going to select the CSV1. Now, if you will look at the show SQL, we are going to use the file format, this one. Earlier, it was creating a file format, that it was creating a table, but we are ingesting into the existing table. So no create table, no create file format script we are getting here. And we are getting on error abort statement. That means if any of the error occurred while copying the data from here, this stage to into this table, it should abort the statement. That's completely fine. I'm going to click on hide SQL. Look at these two errors I'm getting. Okay, so first thing, it is saying that auto fix the column name. So it should be the joining date, which is fine. But I'm getting this error, this column name, not in destination, not in destination. So I'm going to uncheck this. I uncheck these one. Okay, but look at this problem. Look at the error here. Some of the data is coming 234. Some of the table, some of the dates I'm getting. If you will look at here, my joining date is all having 17/8/2024. But then why I'm seeing 234 over here? If I'm going to click on this load, it will throw an error. It was expected. The error I'm getting, the first error, number of column in file is 10, does not match the number of corresponding table. In that means, like, I know it's not 10 column, it's 9 column, but why it is saying 10 column? Because if you will look at closely in the address column, I have some values which is already like it needs to be considered as a single value, but it has a comma. So when I gave here, I'm just going to cancel that. When I gave here this one file format, it is comma, field delimiter is comma, so it is considering this one as two separate fields. So that is why this 2 was coming into the joining date, and it was showing that we have a 10 fields. So to resolve this error first, I like this comma, because this needs to be considered into a one column only. Then I will be coming here and then write alter file format CSV1, and here you are going to write set one property. We have field optionally enclosed by, and then you're going to mention double quotes. Okay, now I updated this one. I'm going to refresh also. So I added this field optionally enclosed. This is when we have commas in single column. Fine. Now I'm going to repeat the same process. Going to click on EMP load, click on load data here, click on browse. Going to do that. EMP load, click on open. Now click on next. I will be selecting my file format here from this existing data, CSV1. Earlier I was getting 2 error, but now I'm just getting 1 error. And if you will look at closely here, I'm just going to uncheck it, but all the columns, all the like correct values coming into the joining date, which is fine. So one error we fix it, but again it is going to break, that it will say that we have a 9 column into the file, but does not match the corresponding table 8. So for this error, whenever we are getting a column count mismatch, I need to update my file format one more time, and here I will be writing set error on column count mismatch. See, one more thing. If I'm just going to describe it, look at this. Here we have one property is error on column count mismatch. Look at it. By default, it's true. So if there is any difference in the column from the file and table, it will throw an error. So you need to copy this one, and you need to make it as a false mismatch, and this will be false. Now when I updated it, now I'll get a different error. So let's see that also. I'm going to repeat the same process. Click on load data here. I'm going to do the browse, the same file EMP load. Going to open that. Click on next. I'm going to select my file format. Now, if I'm going to uncheck this one, it should load, but it won't. It will throw an error on this joining date column you see here. Now I get a different error which is saying date 17/8/2024 is not recognized. And why I'm getting this error? So if I click on done, now the next error we got is this error is not recognized. Why? Because Snowflake's default date format is YYMMDD. So if I write select current date, so my file, like what is the default file format? Well, sorry, date format, YYY. But we are getting the file into DDMMYYY. So this is why it is not accepting it. So in this case, I'm going to write this alter one more time. And here I'm going to update now this. And I need to write date for. By default, it's default set, but we will be updating it. Whatever the values you are getting, I am getting under this like in the format of dd slash mm slash yyyy. But if you're getting dd slash mm slash something, like I'm getting -1, sorry. But if you're getting yy slash mm slash dd, that custom values you can type over here. I'm going to update this one, and then I'm going to repeat the same process, load data, do the same steps here, emp load, open, click on next. And then if you will look at these steps CSV1 here, oh, what's wrong? What's wrong? I guess I picked a wrong different file. The 7. Okay, wait a minute. Sorry, wait. I'm actually like I mistakenly have selected a customer. Mistakenly I've selected customer. It should be EMP load. So I'm going to click on next one, and here I'm going to select my CSV1. This is selected one. Yes, it's showing in one error, but I'm not going to select this one. I'm going to click on load, and it will successfully load the data. So we have seen multiple error. First one is when we have a multiple values into a single column. Then for that, we're going to use field option in close by. Then the next, if I'm having some audit column, some extra column, and I need not to ingest that, then I'm going to use error on column count mismatch. The third is the date. Similarly, we have the other file format. So other options also, just describe file format. If I'm going to write it, same thing, you're going to use it for your time. By default, it's auto, but if you're getting into HS24 MISS, you're going now. Either you are working as a Snowflake data engineer, or if you are going to start your data journey, you really need to understand what stages is. Okay, so by the end of this video, you are not just going to get some idea about the Snowflake stages, but you will be having a great understanding the type of stages, how you are going to use them in your different scenarios. So if you're coming from a data warehousing background where you were working on the on-premises, there was a call staging. So in the staging area is kind of a landing zone, which is basically an intermediate storage area, which is used for data processing during the ETL. Now, if I need to extract the data from CSV or from some databases, and before dumping into a final dimension layer, I used to store the data, I used to stage the data. And after that, not only just basically we used to stage the data and then we apply the transformation. Similarly, into the Snowflake, we have a stages, which is basically a location where data files are stored, means staged for loading and unloading the data. All these stages are essential for moving data within Snowflake or to and from external sources. That means if I wanted to put this data from Snowflake to cloud, then also I would be requiring these stages. In Snowflake, we have two type of major Snowflake stages. One is internal, second is external. Now again we have internal of some type and external we will be having some type. How we are going to configure it, then we are just going to understand this one. Okay, so consider a Snowflake stage essentially act as a pointer or basically a location where data files are going to be stored and before loading or unloading. After that, you can even apply some transformation and put that data into the tables. All right, now let's just see that. We have two type of stages. One is internal, second is external. In internal also, we have three types. One is table stage, second is user stage, and third is the named internal stage. But in external, we have just named external stage. However, it will be on three different cloud like a GCP, Amazon, S3, and Azure. So if my data is outside of the Snowflake on any of these cloud storage area, and I wanted to pull that data into the Snowflake, I have to create one external stage. But if I'm going to create my data, which is going to be stored within the Snowflake, then I will be creating an internal stage. So Snowflake internal stages are the stages which actually store data files internally within the Snowflake. Okay, they are perfect for loading data from local files or other internal sources into the Snowflake tables. Or if you wanted to upload some file from your Snowflake to your local machine, then you will be using these internal stages. Okay, now first thing is we have the Snowflake user stage. Where exactly you will be using it, how exactly you are going to check which is my user stage. And second is the table stage. So the very first thing comes in my mind, if I'm going to create a user stage, whether this is going to fulfill all of my requirement for this particular project or particular basically requirement. Okay, is it going to be a good enough to handle all the requirements whatever is coming in my project, or either I'm going to take a table stage. Okay, now these user stage and table stage are these two stages where you do not need to do anything from your side. These are automatically defined. No need to set up by the user. Even the account admin is not going to configure anything to create or to declare user stage or a table stage. Okay, that means if I am going to create a new user, let's say for Katrina Caf, and when she is going to log in for the very first time, all like she will be getting a user stage. Okay, so user stage, each user has a stage allocated by default for all user for storing files, and it comes with no storage limit. Now, if I come back to my Snowflake here, and let's say if I'm going to create this one, this is my particular user space. Okay, so earlier when there was a Snowflake Web UI, at that time, whatever the metadata or the worksheet I have here, these actually store into the user stages. However, in this Snowsite UI, it's not true. And if I wanted to like see my user stages, I haven't created anything. I haven't created anything. And if I wanted to check, I'm going to write list at the rate until the still operator, and it's going to be run this. Now you can see that I'm not getting any file. It's just name, size, MDF5, last modified. So first thing, if you would be running this query into the legacy UI, you might be seeing few files because of your it stored the metadata and the worksheets. Now, where exactly you think this user stage will be required? So first thing, no setup is required. Okay, no file, no storage limit. If you think whether it is going to be good enough only for 1 GB or 2 GB or 3 GB, no, it comes with no storage limit. Okay, so Snowflake is user states are automatically set up or automatically configured, but that is only and only particularly for that user. So in case I am working on a project and I need to insert that data into the multiple table, but that is only and only should be for, like only data should for me only, then I am just going to use a user stage so that any other of my team member cannot access that data. So the stage is a convenient option if your files will only be accessed by a single user but need to be copied into a multiple tables. Right? Now, we cannot drop it or alter these stages. If I'm going to raise like, no, I just wanted to drop it, you cannot do it. It's a non-configurable and automatically comes when you are going to launch your Snowflake instances. When you, if someone asks, how can I check my data inside that user stages, you can simply use that one. Okay, I will be showing you how you can use this put command to upload some files in your user stage. But this we are going to run it in the next slide, in the next class, sorry, where we will be talking about the SnowSQL. Now, the next thing is the table stage. Table stage also, whenever I'm going to create a new table, it's going to be automatically created. If I'm going to create this create table, and let's say this order, this is going to create a new table stage. But these table access are only and only accessible by the table owner. This user stage is only for that particular user, not even an account admin can access. Similarly, the table stages are only and only accessible by the table owner. And how? List at the rate, you see here, I'm getting some name, size, MDF5 last modified. If I'm going to upload some file, and then yes, I am going to check something. Okay. These are table created for all table automatically with no storage limit. Only the table owner can access the stage, and also these stages are not supported or not basically like perfect whenever you need any transformation while loading the data. For that, you have to go for the name stages. Next is user and the table, they do not associated with any particular file format. So if you think, no, I will just be inserting CSV file or a JSON or XML, no, it is not going to store, not going to be associated with any particular file format. Okay, sounds good so far? I believe yes. Now, if I'm going to run this command, show stages, then it is not going to show any of these user or table stages. If I'm going to run show stages command, it is not going to visible the user and table stages. It will only and only visible the named stages. And what are the named stages we have? Named internal and named external. These are the two stages which is going to be visible when you are going to run the show stages command along with the details. But let me just create a name stages. So I'm going to run create stage, and that, let's say I'm going to write stage CSV. That means I'm going to store some CSV related data. However, this can also be executed. Now you see, I did not add any parameter, but this successfully got created. And if you're going to run the show stages command one more time, and you see when it got created, the name of the stage, the database, the schema where you have created, and you see this URL has credentials. This is for your external stage. So when you will be having a cloud account ready, and you are going to refer your cloud location like a S3 URL or ADLS, then you will be seeing that URL over here, the credentials if you are going to provide it. Otherwise, it will be associated with storage indication. This cloud is null. Why? Because the type is internal. In case of external, it will be the respective cloud like S3, Azure, or GCP. That we can see over here. It's a directory enable. It's no. That also we are going to talk about when we will be discussing a directory table. Okay, now we can see when I'm running a show status command, only the state CSV is coming. But how would I check some files over here? So if I like, for that I just need to run list stage command, and then it is also not going to give me any of the information. So to access the table stage, I have to write list at the rate percent table name. To check the user stages file, list at the rate tilde operator. And to check the name stages, I'm going to run list at the rate say CSV. Let me just come back to over here. And I hope all these points which I have mentioned over here, this must be clear. You might get a good clarity. Okay, so first thing, I have a user stage, I have a table stage, I have an internal name stage, and I have an external stage. You need to understand the purpose of each four. So user stage will be best suited whenever you only a single user wanted to work on that particular data, but they just wanted to insert into multiple tables. He wants to analyze that data before loading into a table. Then we can say you should go for user stage. Okay. Okay, next thing. Table stage is suited when we wanted to copy, you only need to copy files into a single table, but want to make these files accessible to the multiple user also. Okay, so you are going to put that file into the tables, or you are going to make some others owner. So you can just simply assign that, and then this table owner can access those files. And also one more thing, just understand, I have a particular file. Okay, let's say there is a customer file which client is putting every day, and that should be limited only and only for that particular table. So rather than going to create a namespaces, I can simply dump into the table stage, which is going to be like of the same structure or same schema, and then I can simply copy that files into that tables. Okay, that means I will be having an options to simply load or perform a copy into command from the table stage to table with minimal adjustment. Why I'm saying minimal adjustment, even if there are like some difference in the schema, then you can change in the file format and all. Okay, that we have already seen into my file format, that okay, if there are some column extra or some different column name is mismatch and all, then you can just use those file format option. Okay, now the name stage is best when we have a multiple files need to load by multiple users or to the multiple tables. Then I will be going for a internal name stages, but all these files either need to be loaded from your local machine or through this from yeah, from the locally you wanted to load, then internal name stages will be the perfect. Sorry. Okay, now if your data is outside like a AWS S3 or ADLS, then I will be going for external stages. Okay, so if you plan to stage data files that would be loaded only by you or will be loaded into a single table, then you may prefer to simply use either your user stage or stage for the table in which you will be loading a data. Name stages are optional but recommended when you plan regular data that load that could involve multiple user or multiple table, which I mentioned. So there we will be going for name stages. I hope that is clear. I repeated few lines, but only just to make you understand. You can skip that if you have already understood. Okay. Now, let me just upload some file into this stage from this UI itself. So what would I do? I'll go over here on the home page, and there I have this option. Earlier this option was not there, but from past couple of months we can see that we can load the data. I'll click on add data, and here I have Snowflake stages or load files into stages. I clicked on that. I'm going to click on browse, and there I have this file. Let's say this is customer data. I open it. Okay, now in which database I have created this YouTube learning in this raw layer, and I can see that stays CSV. Even here, only and only I can see the named stages. I cannot see the table and user stages because those are not visible. Those are not accessible. I mean, you can see that like what information they are storing using this list at the rate tilde operator and all. But if you wanted to alter or drop, then you do not have the options. Now I click on upload, and here you see the one file got uploaded. Let's do the same activity for another file, and then we're going to check it. It's an employee load. I'm going to click on open, and then I will be doing the same thing over here. Okay, so this one file uploaded. Now, if I come into this data and if I wanted to visualize it graphically, I'll be going under that particular stage. Here, this stage CSV, and here I can see the stage files. Okay, stage detail. I can see this one stage file. It's not. I don't wanted to enable it right now. Okay, they can have some like latency. I'll go here into the stages, and then I'm going to run this list command, and you just see here I uploaded these two files, but just wanted to check how many files I do have right now in that particular stage. You will be running this list command like that. Okay, now how would I actually see my data inside that state? This is about the file. There can be 100 files, there can be 200 files, or even like a one big file which is having like a hundreds of column, or like a one column, two column. But I just wanted to just check it, what exactly data we have over here. Okay, now for that I am going to rewrite select star from stage CSV. But will it work? No. So you cannot select a stage just like you select a table. So if I'm going to write select start from stage CSV, this is not going to give me any information. Also, before that list, I'm going to write describe stage. Look at this one. When I just described it, that means what is the file format by default is associated with this particular named stages. And you see here, this is the property, the stage file format. These are the property value, and these are the property default. So default we have a CSV file format for any of the stage, and you see, because we have not associated with any file format, so whatever the tables, the default values we have, same values are showing over here. You can change it into the copy option, into the file format option, but that we will going to explore into a next video. But here where we were just trying to access the data from my table. When I write select star, it is throwing an error. So it will. Now to access it, I have to write $1, $2, $3, $4 means like the number of column, and then you are going to write stage CSV. I'm just going to write limit 10 and just okay, not limit 10 first. I'm just going to run it this one. And here it returned me data. That's perfectly fine. It's giving me 20 records. Okay. In fact, if I'm just going to write limit 10, then also it will be giving me output, which is perfectly fine. But there is one problem. If you will look at it, this is employee ID, name, address, company name is coming. Second, ID, name is, address is coming. Okay. Now, the next thing is, how would I remove these columns? Okay. And second thing, because I do have two files, so I don't know which data is coming from which file. I don't know about it, which data is coming from which file. Okay. For this, first thing, let me show you if I can select only from the selected file. What if there are hundreds of files, but my team would want only from one file? So let me write, can I simply go and give the entire path of that particular file? Then yes, I can. And it gave me an output, which is perfectly fine. I'm just getting 11 record. Earlier I was getting 20 record because it was coming for both files. Now I selected only that particular file and give me an output. But why I'm getting this column name? Okay, why I'm getting this column name? This is actually not a correct data. Now, if you will go back to this describe stage and then focus on this property line number 5, which is skip header is 0. This is a default property of it. The skip header equal to 0. So I have to create one file format, and that file format you can simply run a skip header equal to basically skip header equal to 1, and then you can just run this command, and there you will be seeing that you are not going to get this not going to get these table the column names of it. Okay, So either I create or assign a different file like the file format over there, or you can simply put that other things. So here, let me just create one file format, create or replace file format. This is going to be CSV type, and there type equal to CSV and skip header. I'm just using one property equal to skip header equal to 1. I did that. Now I'm going to write create or replace stays, and there I'm going to write file underscore format equal to CSV type. So I replace this. Now, if you will run a list command, there is not even a single file. Why? Because you have replaced it. You have recreated it. I'm going to repeat the same process very quickly. Load files into stays. I'm just going to browse all these files, select customer and employee. Now I'm going to upload both the file in the same time. Going to select my YouTube learning, upload into the raw layer, and then look at into the state CSV and click on upload. Two files got uploaded. I'll go back to my worksheet stages here. Select start from first list stay CSV. I can see both the files, and now if I am going to run this command list one, sorry, select 1 2 3 and all, and you see I'm not getting the columns here. I was getting the column $1, $3, like in my previous query. And how can you check it? Even by going into the query history. So this is the command you executed. Select $1 at 11:21, and here the column name was coming. But in my last executed query, the column name is not coming. Why? Because of the file format. So this is we have created, and you assign to that particular stage, and that's how you can change the parameters and change the value as per your requirement. Okay, I'm sure it is like basically just give a very good idea about that, like how we can just create the stays. What are the type of stages we have? In case if there is just going to be for myself, I will be going for just table stays or user stays or name stages. Okay, so if you have any questions out of it, feel free to put these questions into the comment box, and I'll take it or I'll reply over there. So in this video, what we are going to do, so we are going to pick the file from the stages and going to dump into the tables. As you can see, this copy into table, so this is going to load the data from stage file to an table. What if I have a multiple files on my stages and then I wanted to upload on a particular tables, or I only and only need a particular file which needs to be loaded into my table? We have seen most of the things in the last session, that how you can upload selected files, how you can upload an entire folder, how you can upload only a CSV file or Pocket file. That is something which you can actually check my previous video. Now in this, what I'm going to do, I'm going to upload some files into my named stages, and from there we are going to copy into our table. What are the some optional parameters we have, like in case you are getting some different requirement, then how you would be able to handle it? What if you there are multiple people who are uploading the files, and in case the file got failed, how would you know that okay which file got failed, or you actually wanted to insert the metadata columns also? So in this scenario, how we are going to handle all this thing? So let's just like go through with this copy into theory part. So this is just going to load the data from stage file to an existing table. And these file must already be placed in any of the stages, like a name stages, name internal stage, or name external stages. Name internal stages, it can like you can also put like table or user stages also. And I'm sure that you have watched this episode also, and if not, then please go and check my part 10 or 11, I guess 11, yeah, 10, sorry, 10. Okay, now let's just jump to my SnowSQL here. So I hope you remember this last time, that how you can launch this command line. Okay, so what I'm going to do is I'm going to select my particular database. This is YouTube Learning. Okay, And I can see that I'm in the YouTube learning. Now I need to change my schema also. So I'll come into this use schema raw layer. Okay. So in this, I'm going to check, do I have any stages or not? Yes, I do have one stage CSV. And do I have any file format? Yes, I do have a CSV type, but there are a few things which I'm changing. So I'll go back to my this window here, and you see here I have selected this file format here, and then stays. So I'm going to create this file format, and you can see that I'm going to create in YouTube raw learning. Okay, but this time I am going to change it and going to name it as the ingest data, something like that. So my file format name is ingest data. I created here. Now, if I run the same command one more time, I will be seeing two rows produced. So I'm going to use this ingest data file format to insert the data into my Snowflake table. I have set it up few properties, like you see the date format is auto, error on column count mismatch equal to false. But because I do have this file, so let me just show you that which file we are going to insert. So this is going to be my dim customer file. I downloaded it from SQL Server database. And this is something which I need to insert. So what is the first thing? The first thing is we need the file. So I do have with me. Second thing, I need the table. So I'm going to create it over here. Although I haven't created, but yeah, I can create this over here. Third thing, I need the file format. Fourth, I need the stages. And then in the end, I will be running the copy into command. If you remember, when we performed this copy into command using the UI, there we were loading like this plus add data, load data into a table. And if I do right in front of you, like, okay, so how we can do this browse, and we do have dim customer. If I'm going to select and going to open this one, I'm going to select any, let's say this practice database, and yeah, in the public schema only. And here I'm going to create a table at the runtime. So everything is being at the runtime. The Snowflake is going to validate, it's going to infer the schema, and then at the next step, it is going to automatically give you the column names. So first it is going to check the files, going to validate the files, and then it is going to give you the column name. But here it is giving you through some error that, okay, header define 29 column with date while data contains more column. So these are the kind of like error you will be getting. Okay, so but if you will look at this SQL here, what they are doing, they are actually creating a table, and then they are creating a file format, and after that they are running a copy into command, but they are using a stage, and this is a basically a table stage. So this is the Snowflake will be automatically doing it, but in this case we are going to do by own. I'm going to cancel that. I'm going to come on this create table in customer, but one thing which I'm going to run it, the file name here. And this is a metadata column name here. So I'm adding this file name varchar metadata column, and I'm creating this table. Oh, it's already there. So let me do one thing, create or replace. Okay, so my table is also there. Now, if I come on this black window and run the show tables command, there I have customer, dim customer, and orders. So the table is there, which is fine, but I mean, if you remember that why we are using it, we are majorly using to put the files from local machine to the to the stages. So I have this file with me. Just a second. I have this file, this dim customer, and that is something which I need to upload onto my stages. And which stage? I have one stage, so I can run this show stages. I have this stage CSV, but again, what I'm going to do, I'm going to create a new stage from the scratch. So I'm going to write create or replace stage, and that is going to be stage CSV. Here I can write file format and which we have ingest data. And if you remember, this is the file format which we created here. So I'm going to write ingest data and then going to run it. Now my file format, this stage has been created, which is going to use this ingest data file format properties. Okay, which is fine. At the next step, what I'm going to do, I have to upload the files here. So in this case, I'm going to upload this dim customer .csv and to which stage? stg.csv. So I executed this put command and this is going to load that file into this stage, and you can see this status is uploaded. How can you check it? You can simply run command list stage at the CSV. We have already seen this in our previous lecture, and how can you query this data, that also have been discussed in the last video. Now, the next step which I do have is how we're going to copy this data into my this dim customer. So look at one thing. Right now, if I'm going to write select star from dim customer, I do have zero record. Okay, now I can perform this copy into command here or here. This is totally up to you. But this black window I'm using only for this put command. Why? Because this put command will not work on this Snowflake UI. I'll come into this. So right now, first I'm going to see the copy into table. So first thing, I have to decide in which table I'm going to load that data. So in this table name, you are going to replace with your desired table. For me, it is dim customer, but for you, it can be XYZ employee, table, product, customer, anything it can be. Okay, now from stage name. So first thing, the basic syntax you're going to write or anyone can write is copy into dim customer from stage CSV. Now, if I'm going to write this and what it is going to do, this is going to load the data, but here there is a problem. The problem is in the customer alternative key, it's a numeric value. I have given a customer alternative key as int while the data is some varchar. So that is some error is coming. Now, what we can do in this scenario? Okay, so I just imagine you are processing one file and there is a 1 million record. You are processing a file which is having 1 million record. Now you get, when you run this copy into command, you get this error. Okay, but then you fixed it. And because that file is having 1 million record and having one, like let's say 100 plus columns, you fix it for one column. What if you're going to run it again and then you will be getting second error, third error, fifth error, right? We can get multiple error. So in this case, do we have any mechanism or do we have any option that I can list all the error and I can find out that out of that 1 million, how many corrupt record I have? Okay, so basically I need to find out all corrupt record. I won't be saying it's a corrupt record because this is my mistake here. I have used a data type, but considering all the error records here. So in this scenario, what I'm going to do is copy into dim customer from stay CSV, and then I will be using a validation mode, and that is going to return all error. So when I'm going to run this validation mode, I'm going to use this parameter. This is going to validate my file against the file format, and then it will return all the failure records here. And you see here, it is giving me 37,000 number, 36969 are the correct record. What does it mean? Then let's see what is the category we have. So this is only one distinct value, which is conversion here, and the error is coming. This numeric value is not recognized. Let's scroll to the right and we'll be checking in which column we are getting. It's only and only for this one is the customer alternative key. Second is related to the phone number. So let me deselect it and we'll find out what error we are getting into this dim customer, and it is saying this dim customer is not recognized. And then we are getting one error related to the date. So this date was, it's perfectly fine. I was expecting it, but yeah, for this customer, I was not expecting because I did not look into the data. And here you look at it, there are few error which we are getting over here. Okay, now let's do one thing. So for that, what I have to do, I need to just change it to the varchar. And similarly for the phone number also, I'm going to do the varchar. Okay, and then let's look at the data here. So we have, this is date first purchase, this is phone number, address line 1, and this is address line 2. Did I include it? Yes, address line 1 is also there, address line 2 is also there. And here few phone numbers I like that, so I'm going to take it as a varchar, and this is also var. So let's do one thing. I'm going to run it again now. I recreated the table and then I'm running this copy into dim customer validation mode, return all error. And this time I got only and only 1.8k record, means 1773 are the correct record. And that is giving me, because this is the error is not recognized. Date 1155 is not recognized. But why I'm getting this error? Let me see line number 243, character 211. So let's just find out the line number 243. So I'm going to come here. So this is, you see here, which is correct, right? So in this, we are getting, ideally this data should be here, but because of some mistake or someone like has mistakenly ingested this data, and we can see this is the date format, but here this definitely cannot be ingested into this, right? We can see here this one is got shifted one record, it like basically shifted to one record here. So there are multiple records, but for me, it is definitely not the correct record. So what I'm going to do in this scenario, I am going to exclude all these records. So the first thing I am able to get it, what are the correct record? Then when you backtrack and when you figured it out that this data is actually incorrect and customers needs to be get notified with this. Okay, so I'm not going to insert it, but is there any point that I'm not going to insert the entire records? Like what if I have 1 million record and I'm getting only 1700 and 1800 records are corrupted? So why don't we just insert all rest of the records except these 1800? So the whole point was I wanted to insert all the clean record or all the correct record. How would I do it? So in this scenario, I'm going to use one more parameter, which is copy into dim customer from state CSV. And here I'm going to write on error. And this is going to be like, so in on error, by default, we have is the abort statement. By default, we have abort statement, but we have continue, skip file, or like we can do the skip file or we can do the continue. So if I'm going to write continue, that means it is going to insert all those correct record, but going to exclude this corrupted record. And you see here, 18,000 record were passed, 16,000 got loaded. There was a limit of it. Error limit was it is always going to be the number of records, and error seen 1773, and the error was this one. So which is fine. I mean, that is something which basically status is partially loaded, but in real time, I'm sure that you are not going to do this one. You would be checking with your client and you are going to report that these are some data which he is or she is going to correct it, and then you will be performing this copy into command. But the whole point was of this exercise to make you educated with this parameter which is on error. So one, we have understood validation mode. Second, we have understood on error. Now the third is, what if I'm going to run this command one more time? What will happen? Now, when I executed this command, same command again, what just happened? It did not load anything. And why? Because Snowflake keeps the metadata history, and this is why it is not going to load the file over here. It is going to be there for next 64 days, and until then, this Snowflake will not be inserting the same file, even if I'm going to upload it, even if I'm going to change this date. Okay, so then now what if your client updated this file, but the file name is same, and then you want to load this data? Then you want to load this data, what you're going to do? For that, we have another parameter, which is basically force equal to true. But this is going to duplicate your data. But the purpose of this parameter is, if someone has updated that file and re-uploaded on the stages, but when you are going to perform this copy into command one more time, the snowflakes will not allow you to insert that data, because it keeps the metadata history for 64 days. So we are going to use the force equal to true command, and that means Snowflake will let you insert that same data again, or the same file again. Okay, so we have seen validation mode, on error mode, force equal to true. Now, what if I wanted to delete the file, because there is no point to keeping this file on the stages as well as into the table. So as soon as this file got processed, I wanted to remove this file from the stages. So right now, if I'm going to run list stage CSV, this file is there. Okay, but I do not want it to, like, there definitely there is a one command which I can write, remove state CSV, but I do not want it to do it manually. I said if the file gets successfully uploaded into my table, it should automatically get deleted. So let's do it for different exercise, and this time I will be selecting that one different file. So what I'm going to do is, let's take this employee data. Okay, or it's going to be a simple one, emp load. Okay, let's take this employee data. Okay, so let's take this employee data, which is a very small file, and in this, what we are going to do, I'm going to take this one, these columns. Okay, and here what we are going to write, empid is going to int, name will be varchar. Okay, so I created this employee data table. Now, as a next step, what I'm going to do, I'm going to run this command, put command, right? But here I will be changing the file name, and in this I will be uploading this stage CSV. I uploaded that. Now, if you're going to run this list command, if you write this list command, and then here I will be checking two files. So two record produce, one is dim customer, second is emp load. Okay, so here then this dim customer, which has already been processed to a different file, and this employee load is going to be, we are going to upload into a different file. Now, if you will run this copy into command, copy into employee data, and then you're going to write from stage CSV, this will throw an error. This will throw an error. Why? Because there is a different file. Although I'm using this parameter, this here error on column count mismatch equal to false, but again this will throw an error because of some data conversion here. If I'm not going to use this error on column count mismatch, then it will throw an error that number of the column in file is 9, but in the table we have 5. Something like something related to this or something like that, you will be getting an error. But now I need to specify the file which I wanted to upload here. But in this case, there is one more thing. Okay, I'll show you this one. So what I'm going to do right now, so copy into employee data from state CSV, but this time I'm going to mention that this is my file which need to be loaded. And then when I'm going to run this copy into command, now I'm getting a different error. And this was expected. This was expected. Now the error is coming. This 2105-2024 is not recognized. And why? Because the date format I am having in my file is ddmmyy. But if you will look at the current date format in your Snowflake, that is YYYMMDD. So in this case, what you have to do, either you write your own expression like a file, and then you are going to write file format, this file format, and you are going to do the properties here, or you just update your properties. So in this scenario, this one, either you write your format name, or you can simply write here type equal to CSV and then your other parameters. But what I'm going to do is I am just going to update my existing file format, and here I'm going to write date. Let me actually show you one more thing before that. So if I show you this one, show file format, look at one thing. In this ingest data, there is one property. If you will look at here, that is the date format. This date format is auto. So here we have to update this one, and nothing, I'm going to make it to similar as my Excel data. So this is already there. I'm gonna simply make it create or replace file format, and now I am going to repeat the same process from here. Now okay, so what I'm gonna do, let me just do it on this black screen only. Create or replace and then when I'm going to run it, now I will be running this put command. So the first command put, I'm running this one, which is fine, dim customer, but just wanted to show you. Then second put command, I will be running to this employee load. So I do have my both files now. I come back to here into this copy into command, and then let me run this. Oh, where is this? Where is this? Oh, where I have uploaded this copy into command. Did I delete it somewhere? Okay, no worries. So copy into employee data from state CSV. But this time I'm gonna run this EMP load. So you're gonna copy this file, target name, going to run it. But I said it, as soon as it get loaded, I wanted to remove from the stage because there is no point to pay extra. So in this case, I'm gonna use one keyword, purge equal to true. Now see that. So it loaded the file, 13 record passed, 13 record loaded, there was no error, and it loaded the data. Now if you will run the command select star from employee data and look at it. You get the data, but one interesting thing here, we have uploaded two files here, right? Now, if you will run list stays CSV, you will be seeing only one file, and that list command we can also perform here. So do not get confused. Only and only put and get command will not work here. Okay, all right. So we have seen these four properties: on error, force, validation, and the purge equal to true. Now the next one is the return field only equal to true. By default, the value of the return field only is false. But if you suppose wanted to whether to return only files that have failed to load into the statement result, then you are going to make it true, and you will be getting all those files into the output. Next we have is the match by column name and the include metadata. We are going to use these two properties together. Now, in case you do not know the file, you do not know the order of the columns in the staging file, but you do not also wanted to specify $1, $3, $5 in this way, then what you're going to do, you're going to use this match by column name property in the copy into command. So the stage is automatically, Snowflake is automatically going to validate the stage columns with the table columns, and then it is going to load the data. Okay, and this include metadata is if you wanted to upload any audit columns in your tables, like a file name and the ETL load time and the row numbers. These are the kind of a stage metadata fields we have. If you want to add in your stage in your Snowflake target table, we're going to use this include metadata property. Now, one thing, to use this include metadata, you have to use this match by column name. But to use this match by column name, make sure in your file format you are using a parse header equal to true. Let's look that into the action. Okay, so I came into here. If you will look at it, for this match by column name, I made a file format which is parse header equal to true. Let's look at everything from the scratch. So what I'm going to do is I'm going to create this employee data table. Okay, I have this one stage. In this stage, I have this emp load file. What I'm going to do is I have added this file name also. This file name means it is going to be my audit column. Now, I'm not specifying anything over here. I'm writing this copy into employee data from CSV. Even if I am going to change the order of the column, but I'm using this match by column name, then the Snowflake will handle by own. Okay, first I'm writing case sensitive. Now see what will happen. If I perform this copy into command, then the status is loaded, which is fine. But what the data is do you think that the data is completely fine or not? We're going to look at into it. Select star from employee data. And when we have seen it, this is an EMP ID, name, address is there. That means the data is not successfully loaded. Why? Because there are few of the columns in which we have completely null. Why? Because we have given this match by column name equal to case sensitive. So in my next copy into command, what I'm doing, I'm truncating this entire table and then copying into this. But one thing which I'm making in line number 99, you can see I made it case insensitive. Okay, I'm going to run this copy into command, and here include metadata. If you will look at it, the file name, this is my table name. Okay, means table name means in the table, whatever the column I have it, which is same as the file name, that I'm passing here. And then this is my metadata column name. What other metadata columns we have here? Metadata file name, row number, content key, last modified, and scan time. Okay, so whatever you want to use, you can use, but most of the time you will be using either file name or the scan time or the last modified. I'm going to pick that and then going to run it. Now, look at this data. Select star from employee data. And you see here, after executing this copy into statement, I can see that the entire data is successfully loaded, including this joining date, country, and the file name. Why we are using it? What if there are 10 files, and so that we can easily get to know out of the 10 staging file which all successfully completed and which is failed to load, so that you can report to the client. Okay, Now, in the next thing, what if I just wanted to know when we have loaded these files? Okay, you just wanted to know when was the last refresh or last load happen into this table. So for that, I'm actually like truncating this table entirely and adding one ETL load time. Okay, so this is ETL load date I'm adding, and then I'm running this copy into command, but one more column I'm changing it. This is ETL load date, this is the column name I have added, and this is the audit, means the metadata column I'm taking here. When I executed this one, now I should see the value in the ETL load also, and let's look at it, which is perfectly fine. Means this is something which we were expecting, right? This is going to give me the ETL load date, and that's it. So like I'm sure that you have understood how we are going to copy the data from stays to the tables, and you will be using most of the time in your like real-time projects. But one more thing, we have only and only covered in this video copying to table. There is one more part which is copying to location. That means what if you wanted to copy the data from table to stays? It can be internal named stages or external named stages that we are going to cover in our next video. Now, in this one, we are going to do the reverse, means I'm going to take the data from the tables and then going to dump into the stages. Okay, so the syntax is going to be similar. You just need to reverse the places like copy into stage from the table name. But one thing which is going to be different is the parameters. Now here you will be seeing few other parameters which is not into the copy into table. So let's just see that into the action. Okay, I'll come to my Snowflake here, and what I'm going to do is I'm going to open a new tab. This is copying to stage. Okay, so I'm quickly going to take my YouTube learning and the raw layered schema. Here, if I look at it, what I do have, so stages, I would be having a couple of stages here. Okay, I can see the three stages. So what I'm going to do is I am going to first remove everything from the stage CSV. Okay, so everything has been removed, and I'll see like, okay, I was just doing something. So now if I'll see there is no file, if I'm going to run the list command, there is no file. Okay, I need to do a copy into stage. So from where I need to take the data from existing table and dump into the stage. Why? So that people can take it, people can dump it into the stages. That is not just going to be the internal name stages, but it can be it can be the external name stages also. Means what if my teammate wants me to send some data to the AWS S3 or Azure or GCS, I can use this copy into command. Okay, for that, I need to write copy into stage CSV from any table. Now, table, I can mention anything, like anything means like from any other schema. So let's say I'm going to take it from the Snowflake sample data. And I know from this one schema, and the table name is customer. Let's see what will happen. So when I executed this command, I got three rows unloaded. How many we got? 150k. These were the input bytes and these were the output bytes. Let's look at the list now. List is CSV. And that means I got three files. Now, first thing, every name is going to start with data and it's going to be like 000120020 because the files are going to be copied into the parallel. The number of threads are available at that stage. These are going to create the number of copies over that, like into the stages. Now, what if I want this name should be something familiar or something different because I'm copying the customer data. So the name should be something like customer. So in that case, what you're going to do, you're going to write copy into stage CSV and then slash customer data. And then from, you're going to take this one. Also, I do not want multiple files. I just need a single file. Then I'm going to use single equal to true. That is one parameter which I'm going to use here, single equal to true. Now, one more thing, because I'm not specifying any data type, so if I'm going to rerun this, I will not be getting any data type for this customer. Look at this list is CSV. So I got this customer data, which is a single file only because I made it a single equal to true. Now, if this external stays, if this is an external stays, means I have created the stays on AWS or in, Azure and something, then the limit is the 5 GB. That is the maximum size of the file. You can load it 5 GB. But what is the maximum file size by default? Let's try that. Okay, so there is single equal to true, and then other property I do have is max file size. This max file size by default I have is 16 MB. So if my table data is less than 16 MB, then I can simply set it single equal to true. But if it is more than 16 MB, then I have to change this max file size, and I'm going to need it to change it from 16 MB to up to 5 GB in case of external stays. So you can mention this max file size is going to be like something. I mean, you can definitely check the Google to find out how many bytes is going to make a 1 GB, 2 GB, 3 GB. Okay, so I'm not going to use that max file size, but what I'm going to do in this case, I'm going to write customer data.csv. And when I'm going to execute this one, now I will be having a separate file which is customer.csv. Okay, this is one parameter. Now, what if your teammate is saying, hey, what have you done? Actually, I just refreshed my customer data. So whatever you are pushing to stays is not up to date. So can you please rerun the command again? Can you please take the same data backup onto the stays again? So what you're gonna do? You will be running the same command again, but this will throw an error that the file already exists. That means now you have to use a different parameter, which is overwrite equal to true. Okay, so we have seen two parameters, single and overwrite. Now, what if I wanted to know that there should be a proper query ID in my file name? Okay, I want a proper query ID in my file name. So for this, I will be taking, but this time I'm not going to use this single equal to true. I will be using this parameter, which is include query ID, and see what this is going to do. When I write include query ID equal to true, in fact, this is not required. Now let's see what will happen. When you are going to do that, list stays CSV and see that. If you will look at it, they have created list is CSV customer data. Now when you are going to do that, then it is going to take data and then the query ID, and after that it is going to take the file name like 000, 010, 020, 030, 030, you see here, because earlier these were the file got created automatically, but when you write include query ID, it is going to add the query ID also. But this will not work when you are going to use single equal to true. Let's see that. If I'm going to write single equal to true, will it work? Now, invalid property combination. Okay, so whenever you want to use include query ID, make sure you are not using single equal to true. Okay, so we have seen three major property. Now, my manager is saying that Vishal, I have one table. That table is having 1 million of record. But when I'm creating the when I'm just copying this data into the stages, what exactly it is doing is that it is creating like 10, 20 copies. But I want to know the number of records available in every single file. That means he wants me to get him the details that how many records we have in this particular file, how many record I do have in this file or in this file. Then The one approach is that I'm going to open this file, going to take it into the Excel, going to find out the count, and then going to give him. But what if there are 200 files? Am I going to do the same thing for the entire day and then second day? No. For that, Snowflake is pretty smart. In this case, you have to use another property called here. This is detailed output. So you're going to take this detailed output equal to true, and this time I'm not going to take customer data. I'm taking Katrina Kaif, and let's see that. Now when I take this one, you see here in my output, I got file's name, file size, and the row count in every single file here. Okay, so this first one means 030 is having 30,000 record. It's M75, it's a 45,000 record. So if anyone is asking you to find out the row count in every single like file created at the stage, then you're going to use detailed output. So we have seen include query ID, detailed output, override, single, and max file size. Now, last one is the validation mode, and that is the common with the copy into table also. What it is going to do before copying the data, before unloading the data at the target means at the stage, it is going to validate or it is going to tell you what exactly or what exact data is going to be unloaded at the stage. Okay, so let me do one thing. I'm going to do remove, or not going to remove actually. Will be you will be able to understand. I'm going to take not detailed output this time. I'm going to take validation mode equal to return rows. So if you are going to write return rows here, then what it is going to do, and this time not Katrina Cat, it's going to be my Megan Fox, my favorite. And when you are going to execute this command, what will happen? It is going to give you, it is going to return all those records whichever is present in this customer table. And you see here, it's a 150K. Okay, now you see here it is C0, C1, C2, C3, C4, C5 is like it's coming as a column name, not just C0, C1. But what if you just wanted to find out the column name? Then for that, you need to use header equal to true, and let's see what I will get. In this case, what will happen that this is going to include the data. This header equal to 2 means this is going to include the column name also into the into this file. Now there will not be any file in my stage named after Megan Fox here. You see here I still have 11 files. There is no, because it just validated and going to give you that how many which all records is going to be copied. So in this case, what you can do, you can simply run these two statement or these two. That's it. Now you will be having one file which is Megan Fox, something like that. You see 14 files are there. This one. So that's how you can copy the data into the stage from table. Now, one thing which is very important from the Snow Pro core certification point of view also, that at the time of unloading the data, supports only JSON, Parquet, and CSV, TSV file formats. That is very important, and I'm sure some of you is going to see that in your Snow Pro core certification exam. Okay, now one last thing, that what if I have one internal named stage and one on AWS S3 stage. I wanted to move all the file from here to here, or I want to do the reverse, or let's say the requirement is AWS to Azure or Azure to AWS. So in this case, I will come to this copy files. This was added in the month like last year only, around couple of months back, that it allow you to copy file from one stage to another stage, but it should be named stage only. So as you can see, the combination internal name stage to internal name stage, external stage to internal name stage, internal name to external or external to external. What would be the syntax? Is simple, copy files into stage 1 from stage 2. After that, you have one more parameter also, like you can take which particular file you wanted to copy. So you can write copy files, but before that, let me create one stage, create stage, and that stage is going to have a stage data. Let's say this one. And now I'm going to take this one only. Oh, my bad. Let's do one thing. Yeah, just going to put semicolon here. So this create stage data, that stage is created. Now if you look at it, there is no files in this stage. Why? Because we just created, right? But if I do that, copy files into from from which stage? From our this is stage underscore csv. And look at one thing. When you executed this command, this is going to copy all the files into this stage data. Okay, now if you will run this list stage data, it is going to have all those files, whatever we do have in the stage CSV. Okay, I hope you understand this copy into command into the details. So we have three things. One is the copy into stage, copy into table, and copy files into the stage from stage. Okay, if in this video, we are going to see step by step, right from the setting up our AWS S3 bucket and then creating an IAM role. After that, all the necessary objects we are going to create into the store, into the Snowflake, and then making a proper connection. Some of you might be wondering that what's the big deal to setting a connection between the S3 to Snowflake? It should be a right click. It should be a click like some clicks away, right? No, it's not that. We have to maintain the configuration in between this S3 to Snowflake. There are a few things which you are going to set up, and you are going to create objects into the Snowflake. Some object you will be creating into the S3, and then you need to make a proper handshake between these two S3 and Snowflake, and after that you would be able to transfer the data. Before this, we have already seen the stages, copy into command, copy into stages, but that everything we have seen onto the internal stages. But today, we will be talking about the external stages. So if you do not remember or if you don't know what stages is, then please watch my previous episode where I have a detailed video of the stages. And so let's get started. In real time, most of the people you would be implementing, or most of you extracting the data from cloud. It can be AWS, it can be GCS, or it can be Azure. I will be creating all three videos to load the data from these three cloud buckets, but this part 14th will be where we are going to focus only on AWS S3. So first thing, what are the primarily steps you need to follow? I know because we need to get the data from AWS. So what is the first thing you would be requiring? Your S3 account. Second, you need to dump into the Snowflake. So you need your Snowflake account details. But then in this S3, now you will be creating one bucket. In this bucket, you would be creating some folders, and then in the folders you would be putting some files. And when you are going to dump into the Snowflake, I have been discussing this from I guess from part 4 or part 15, that whenever we need to copy the data, we need the tables, we need file format, and we need stages. So these objects we will be creating into the Snowflake side, and this is the minimum configuration we would be doing into the AWS S3 side. There would be few other things which we are going to do it, but this is something which is minimum, and it you would be requiring to set up every single time, like either you are doing on AWS S3 or Azure or GCS. Okay, so in my like this document, I will be sharing this document over the drive. So whosoever is needed, and then just please do let me know. So the first step is configure your AWS account. If you're not ready with your AWS account, you can create your free tier account by going to this amazon.com like free tier account. You can simply go and basically I can tell you how to configure that. Or you can just simply go to the AWS Amazon Web Services and then sign into the console. If you are already created your account, then you can just type your IAM username and all. If not, then you can just create a new AWS account. So just click on that. Just go with your email address. You need to provide some basic details you would be entering. It would be something like your name, your phone numbers, and in fact, you would be required to give your debit card or credit card details also. Whatever we are going to do in this exercise, we are just going to write AWS S3 and some IAM. This is not going to generate some bill. So if you do not have all this, like you do not have a AWS account, then make sure you are going to create it. Now, I have already created this AWS account. So let me jump to my AWS. So this is how it is going to be look like. It's my home page. And here you will be like seeing that whatever the recently visited services you have basically practices. And you can just check with your username and the reason. And now the very first thing after creating your account, we will be going into the S3. So I'll search my S3 here. I click on that and then I'm going to create a bucket and folder. So I can click on this create bucket and make sure this is going to be you cannot use your capital letters. So please use a small letters, and also this should be globally unique. So I'm going to create my YouTube learning Snowflake. Let's see that. I'm not going to touch any other things here. And then I'm going to click on create bucket. This is all okay. This character is not allowed here. So let me just do that YouTube learning Snowflake. And then I'm going to click on create bucket. My bucket is created. So I'm going to click on this few details and I can see that there is no folder. So I'm going to create one folder, and that is going to be nothing but a source folder. That means I'm going to put some file from my local, or you can download something. In fact, there can be like few other things you can use, some other automated way, probably like your Python script is uploading the files into the source folder. Okay, which we will be discussing on next videos, like next data engineering projects. Okay, so I'm going to create the folder name as source folder and click on create folder. My folder is created, my bucket is created. Now inside this folder, I need to have some file. So you can simply click on upload, or you can just basically, you very easy to upload these two things. So you can just simply go and put anything like that. This way you can do that. It's a customer data CSV, and then I'm going to upload that. So my one file is already there. Now, the next thing for me is, so I have this free tier account. I have configured my AWS account, and the next I have created a S3 bucket. I have created a folder also. You can create any folder, whatever you want. In the next video, in the next step, I need to create a table. Okay, some of you might be thinking that Vishal, is there a way that if client is uploading some file and we don't know about the schema or the structure, and then can we create a table at the runtime? Answer is yes. We can create a table at the runtime by using an infer schema. Okay, but that we are not seeing in this video. I will be creating a separate video for that. So let's do one thing. I'm going to open this customer data and we'll see that what exact data we do have in this. So it's a very simple dummy data for me, and I can see this is like 6 or 7 columns I do have. So here ID is int and then name is varchar and rest all except this joining date. I'm gonna take date. I'm going to create this table, which is customer data. So I'll come into my Snow, okay? And here I'm going to create my SQL worksheet. And this is AWS S3 load. Now, I'm going to select my YouTube learning database and the raw layer. This is going to be my schema. Now I need to create a table. So create table AWS customer load. Okay, now you can simply do that. So my table is created. Now, as a next step, what I'm going to do is I'm going to create a file format and the stages. So if you will look at it into my slide, after the create table in Snowflake, you need to create a file format. But I'll see whether I do have already the file format or not. Yes, I do, because I have created this one. We have already performed these exercises. So I'm going to use this existing file format and we'll be checking it which exactly can fulfill this situation. So in the state, not for this one. Yep. DDMMYYY. Why I'm going to take this one? Because I do have this date, joining date, which is the format of DDMMYYY. And if I'm going to take this file format, in this date format is auto, so it is going to throw an error. For that, I'm going to consider this file format because we have already given DDMMYYY. Let's look at it. Which is this file format? This ingest data. So I have already this file format which is ingest data. So I'm not going to create one. But now the next third step is to create the stages. So actually there are two steps, two ways to load the data from AWS S3 to the Snowflake. The very first method is The first way is that you can simply load this data into the Snowflake, but for that you need someone who is going to give you the credentials. Means you would be requiring the AWS access key and secret access key, which he would be asking when you are going to perform this command. So this guy means this is a developer who is going to ingest the data from AWS S3 to Snowflake. Then he would be asking that give me the credentials, which is definitely not a general practice in these companies. So what we use, either we can go for credentials, or second approach is we can create a storage integration. Now, what would be the limitations if I will go through this credentials? Let's see that. So first thing, I'm going to create my stage. So this will be create stage. Okay, and you can simply refer this one here. I have all every single thing which you can just simply use that. So just ping me if you need that PPT. So you need to create a stage. This is a simple first line which we have been covered already in a previous video, and then you are going to refer the file format, but in this you need to mention this URL. So where from you will be getting this URL. I'll come into my AWS S3 bucket, and here I can see that this is my URL, this destination. So I'm going to close this one and I'm going to copy this S3 URL. Now I came here and I'm going to create external stays ext stays, and then I'm going to mention the file format, which is going to be ingest data, and then I need to pass the URL. Now, when I created the stage is created. Now look at it. You need to run a command show stages. So you will be checking it, because other than this ext stage, every single stage we have created are internal. But how would you know whether this stage is internal or external? For that, just scroll to the right and look at the property. The first one you have given this URL. Now, if you will go and scroll to the right, there is a reason US East 1. type is external. So this type is going to tell you whether this is internal or external. Now look at the cloud, which is AWS. Why? Because we have given this S3, and this Snowflake is smart enough to understand from which cloud we have been, on which cloud we are creating it. So the stage is external stage. That means it is just going to point the data which is already there in my AWS account. I'm repeating this external stage is not going to copy the data into the Snowflake. So this is why there will not be any storage cost associated to that. So if I'm going to put 100 file here, this external stage is just going to point to that. It is not going to copy the data until you perform a manual copy into command here. Okay, now once this is done, I click on source stages. Okay, so the very first thing, the limitation of it, because if you remember, I wanted to check the file inside my stages. I used to perform a list command, but when I'm doing it, it giving me an error, the access denied. Why? Because we created everything, but this Snowflake and AWS are like, assume that these are the two different person which they wanted to make a deal, but they haven't properly handshaked, or they did not sign their agreements and something. So until and unless they do not meet, they do not make a handshake, and they do not sign the agreement, they cannot transfer, or they cannot import or export anything to the each other's region. In a simple words, like if you remember the Bollywood movies, there one guy who needs to trade the drugs or the like guns. So the one guy has to give him a half 10 rupees note, and that the villain, both the villain are going to combine that, and then they say yes, this is confirmed. Or otherwise they just say, hey, teja kya hai. So they just need to pass some code, and then they are going to give them some money or whatever they needed. So in the simple word, I need to pass now at the time of the copy into command, when I'm writing copy into AWS customer from ext stage. If I'm going to write that, it will break and it will throw an error. The error, I'll get the access denied. Reason? Because we haven't configured that so far. So in this scenario, I do have one concept is credentials. So here you will be creating a copy into command. You need to pass this credentials. So you will be requiring this AWS key ID and secret key ID. Okay, but how would you do that? So in this case, you can simply copy. I'm just simply copying it to save my time. I need this key, AWS key ID and secret key ID. And then I will be able to copy the data. Let's see that. So I'll come over here. Now I can easily get my security credentials, but this is going to be my root user. So I will not suggest anyone to generate your security credentials from here. In this case, what you're going to do, I'll go to the IAM, click on that, open into a new tab here, and here click on the users, and I'm going to create a new user. This username is going to be my YouTube. I click on next, add users to group. I need to give some permission to this user, which is fine. Okay. I'll go to the previous, set permission, and I'll click on attach policies directly, and here I will be giving AWS S3 full access. Okay, so I'm giving this Amazon S3 full access to this user, so he can read and write this, and then I'm going to click on create user. Now my user is created. This is basically my YouTube user is created. Now I'll click on the security credentials, and here this is first access key. You need to scroll down until you see access key. Click on create access key, and you are going to use it to the third party services. And I click on I understand, click on next. You can simply put some random value ABC. This is my tag and click on create access key. So you got these access key and secret access key. So this is something you need to copy. I click copy this access key and paste it over here. Then this is my secret key. Make sure you have downloaded these keys, because if you are going to lost it, you have to regenerate it again. So if you are doing it and you wanted to use it multiple times, you're just going to download the CSV file and you can save these access key. Now, in this copy into command, when we execute it without passing the credentials, it gave me an error, failure using an stays area cause access denied. But if I'm passing these access key, and let's see what happened. Okay, so this is giving me a different error. This is a file format, pass header is only allowed. So in this scenario, we have to just make one change. Okay, now I need to run this one. So I'm going to use create or replace stays one more time. And let's run this command. Okay, so the error was actually because in this ingest data file format, I was using a pass header equal to true, which is actually used whenever you wanted to. I mean, you can just simply check this error message that when we use a match by column name and info schema, which we were not using here. Okay, now look at this last one. So here, this when we perform this copy into command, it loaded the 10 records. So that way we are able to load the data from AWS S3 to table. Let me query the table, select star from. Okay, I can see the data is there. But there is one problem actually. What if there are hundreds of records or hundreds of files, and I wanted to query some data? I wanted to just visualize the stage data before ingesting into this table. Then this list command will not be working, and you can only use these credentials into the copy into command. For that, we will be creating one object which is going to help you to not only just list your stage file or query your stage data, but you can do some much more. Okay, so this storage integration we have to create, and then we will be passing this storage integration to this stage so that we do not have to remember our credentials and we do not need to pass these credentials all the time. Let's see that. So for that, you can simply like follow this one here. In this stage, you are going to copy, but you would be requiring two things. You can see I'm going to create this storage integration S3 int. This type is going to be my extend stage, which is you can consider as a kind of a syntax. I mean, it's not going to be changed. However, the storage provider is also one property, which is S3 in case of AWS S3, but if you have Azure, you're going to change it to Azure or GCS. Enable it is going to true. So for first four line is something which is not going to be changed even if you are going to create it. Only thing which you need to change your name. Okay, but now these two things, look at one thing. Storage AWS role ARN, storage allowed location. So where from you will be getting these 2 points or these two parameters. There is one more property we have in this storage integration, that is storage blocked locations. So consider you have one bucket. Inside that one bucket, you have 10 folders. Okay. But there is a problem with this 10th folder, and you do not want it to export the data from that 10th folder to the Snowflake. So There is a one thing like you going to manually pass 1 2 3 4 5 like up to 9 folder. Otherwise you can simply block that 10th folder and you can pass the location of that, and then this storage integration will not be copying the data from that particular folder. So you need to just copy that path. Now, the whole point is how would I get this AWS role ARN and allow location? Allow location is very simple. Why it's very simple? Because we just need to go to our AWS S3 account one more, like AWS S3 bucket one more time. And here you need to copy this S3 URL and just paste it here. Okay, in this allow location, this is a basically list. That means you can pass more than one value. Okay, now this role ARN. For this role ARN, that means you need to create one role in your AWS side that is going to generate one ARN, and that ARN we are going to pass here. So let's see that. I will jump to this AWS here, IAM over here. I'll go back to this IAM main page, and here I'll click on this roles. Okay, so this you already know. This is an IAM role is an identity you can create that has a specific permission with credentials that are valid for short durations. That means I am going to give some permissions to that particular role which won't be requiring the credentials from your side. I'll click on the create role here, and this I'm going to create AWS account, allow entities in other AWS account belonging to you or a third party. So you need to click on this AWS account third party options here, and then require external ID. Click on that external ID. It's a best practice when you connect to a third party. So it's kind of a two, basically whenever you log in, you get one OTP, kind of that. Okay. I'm not enabling the MFA, but just look at this. So external ID, I'm passing here 1 2 3 4 5 6 7. This is just a random value we are passing, but we will be updating it. I'll click on next. Okay, and I'm giving S3 full access here. Let's see, that's the only thing right now it's required, and click on next. The role name I'm giving AWS data ingestion. Okay, and I click on this create role. My role is created, and when you will view that role, this has ARN. So we need to copy this ARN. Once you have created your role, copy this ARN and then come back to this storage integration definition in the Snowflake window and then just create it. I'm not giving any block location, and you just need to execute this one. Your storage integration is successfully created. Now, at the next step, you are going to write describe integration. Okay, so once you have described it, now you see it, allow location and block location. These are the list, rest of the string and the boolean. Okay, I have given one location, but you can pass as much as you can. In the block location also, you can pass one or two locations. Now, focus on these two things. In line number 43 and 44, this 43 AWS role ARN, it's basically your line number 6. This is the exact value which you have passed already here. Now, this line number 5 and 7 means storage AWS IAM user ARN and AWS external ID. This is something which a person one has provided their terms and conditions, and then they remember it. Now, this Snowflake will also give there some code or some kind of a basically some conditions which AWS will be like storing in their database. So we will be using this line number 5 means AWS IAM user ARN and AWS external ID. I'm going to copy first this external ID. I'm going to copy here and go back to here. Now, in this trust relationship, go to that particular role which you have created, click on trust relationship, click on edit trust policies, and here, if you remember this external ID we have passed 1234567, you just need to update it with this external ID which got generated by the storage integration into the Snowflake. I pasted it. Now, at the next step, you have this AWS IAM user ARN. You need to copy that as well, and you will be passing it into this principal AWS here. And so you basically need to update your both properties external id and im user arn, and this option might not be available if you did not select the external ids while creating roles. So once you have given your value, you need to update it, and now your proper handshake has been completed. So in the next step, you will be creating another stage. Okay, so I'm going to create or replace stays, and that is going to be my S3 stays here. First thing, you need to pass the file format. That will be like ingest data. Next thing, you need to pass the URL, but one more thing, you can just simply check it over here. And that is, you need to pass the storage integration here. So in this what you're gonna do, you will be passing along with the storage integration. You need to pass here this URL. You can copy that one, and then this stays create or replace stays. You have only just added the storage integration which we have added here. Now if you will run a list command, let's see what happens. When you executed list S3 stays, this is going to show you that how many files are there in the source folder customer data. So that is the profit over, like that is the profit using storage integration over the credentials, that you can not only just list the file, but you can even query the data inside your stages, like whatever data we do have this. And you see here, okay? Now, as I mentioned, the data is not being copied in my Snowflake. It is still there into the Snowflake. And how would you verify that? Let's see that. If I run this command, remove S3 stays, then this file is removed. Look at this, list S3 stays. There is no file. So what do you think? This file is removed only from this Snowflake or from the AWS also? Let's see that. If I come to this AWS S3 bucket, and there you see this, the file is already there. No, you just need to refresh it and you will be seeing the file is gone. There is no file. Why? Because to this particular role which we have used to create this integration, we have given AWS S3 full access. So that means if you are going to perform a remove command, that will be deleted from AWS S3 bucket also. Okay, now what I'm gonna do is truncate AWS which table we do have, AWS customer load. I'm going to truncate this one, but then I'm going to copy the same thing whichever we did earlier, like just going to copy this one customer data and upload it, this one. Okay, now I'm going to copy this copy into from as 3 states. When you executed this, now there is no need to pass the credentials and the data got successfully copied. And you can simply select star from AWS customer load. So that's how you can do your batch processing or your batch loading in your Snowflake. Now, if you will look at it, what we have learned so far, how to create external stages, connect AWS to Snowflake, and storage integration. We have created a roles also, we have created buckets, but I'm sure you would be having an idea. If not, then feel free to ping me to get more idea onto this AWS role and the bucket side. Now, consider one scenario where your manager is saying that, hey, I am putting some file into the cloud bucket. It can be S3, it can be Azure, or it can be GCS. But the problem is that I can put 10 files, 20 files, 30 files after 1 hour, 2 hours, 3 hours, and you do not need to perform this manual execution. Or basically, he's saying that as soon as I'm putting the file into this bucket area, those should be ingested into the Snowflake. Now, you cannot do this manually all the time, because every time when your manager is putting the files, he's going to text you, and then you will be like replying, yes sir, I'm on it, I'm working on it, and then you are going to run the copy into command. But this is definitely not a feasible option for you or for anyone. For this, we have Snowpipe. Snowpipe is used for continuous serverless loading of data into the Snowflake target table. So what it does, it enables loading data data files as soon as they are available into the stage. So I'm putting into the stage, and then the Snowpipe is going to get the message from the cloud side. And obviously we are going to configure each step how it is going to notified by the AWS that yes, there is one event or there is one action. So Snowpipe is going to receive that message and then going to ingest the data. But before diving into this, make sure you are going to complete the part 14th, because in this, I'm going to use AWS Cloud. We have already configured the storage integration external stages. So let me take you to my Snowflake window. I hope you remember. So in this case, what we have done, we created a AWS customer load tables, and using this file format ingest data, we have performed this like external stages, and the storage integration was S3 end. So if I check this list S3 stage, there should be one file, and that is a customer data. Now, if I can just perform it, there should be some, the data should, yeah. So we do have some records. It's just having a 10 records over here. So let's do this from this next step, that how we are going to configure it. That means if my manager or if anyone, if client is uploading a file into the into the AWS S3 bucket, so then without running this manual copy into command, how we can insert the data. Okay, so for that, the first thing, you need to create a Snowpipe. Okay, so let's consider one scenario. I'm going to have some files here. Okay, and let's start, let's do that with this from the basic. This is my customer data now, and I'm going to make few changes here. So this run by is Vishal. I'm going to take all the data here, and then we have some, let's say this phone number is fine, address is Noida, let's say it's a Delhi. And let's take some ID. It's going to be started from 999, or let me just take from 990. Okay, so we have, I'm just not going to change the names and the phone number, and the joining date is going to be today's date, which is 7/1. And this phone number is also going to be something like that. Okay, so I'm saving it, and I'm saving this one as a new file. This is save as, then the Snowflake training only, and this customer data file. My file is saved. Now as a next step, I'll go to my AWS, And just to verify whether which bucket it was, you can simply check it in your URL that this was a YouTube Learning Snowflake bucket. So I'll go over here. I have this YouTube Learning Snowflake bucket. With that, let me just close everything. Now in the source folder, I'm going to upload this file. You can simply click on upload, and this, I guess you can do that. And this customer data file, I'm going to open that and I'm going to upload it. Now I have uploaded the files, but until unless I do not run this copy into command, then this file will not be copied. So if I'm going to do this copy into AWS load from S3 stays, and you see here, this file got 10 record got loaded. And if I need to check the data, then I can see this latest data is also available. Yep, but I did a manually. Now I do not want it to run it manually. So I need to create a snowpipe. And again, like if you need this PPT, you can just simply drop a message to me. This is going to have all the same steps, just like we have performed already to connect your AWS with the Snowflake till the storage integration, the file format, stages, everything we're going to create except this one. Here, we need to create a pipe, and in that, we need to wrap that copy into statement. Okay, so I'll come over here. I need to write create pipe, and that is, I'm just considering it a AWS pipe, and here you need to write auto ingest equal to true, then as, and after that you are going to write your copy into statement, and I'm going to use the same copy into statement. I'm going to use the same copy into statement. I need to copy that, and then that's it. Now if I run it, my pipe is successfully created. But now imagine that you want to send the message to your crush. You do not have her email address, her phone number. How would you send? Right? You need mobile number or you need email address. Then only you can convey your feelings or you can convey your message to her. In simple thing, we have created a pipe who is going to load the data into this table from the stays. But how the stays is going to notify Snowflake that, hey, I do have some actions or I do have some messages for you. For that, we need to actually perform this event here. We need to do this event configuration here. So you will come into this YouTube Learning Snowflake bucket. Now you need to come into the properties. Into the properties, when you scroll down, there is one, you have event notification. So I need to do this event notification. That means whenever there is any create event, whenever we are uploading any file, that should immediately send a notification to Snowflake, and Snowflake should come in the action that yes, there is some change into the metadata and I need to perform something. I need to ingest something. Now, before that, I need the describe. Oh, sorry, I will be running the show pipes. When I run the show pipe, this is the AWS pipe we have created. If you go scroll, like if you're going to scroll to the right, we have this notification channel. This notification channel is nothing but your Crest mobile number. Okay, or imagine that if one company want to send you a broadcast message, he will be adding you into the broadcast group, but before that he need your email or your phone number, and he's going to add into the list. So whenever there is any message or they are uploading any document, you will easily get notified. Okay, so I'm gonna copy this notification channel. Now I'll come back to error note, like event notification. I'm going to click on create event notification. Now you can see snow pipe alert. You can name it anything, whatever you want. I'm not going to touch any other properties, and event type should be all object create events. Okay, right now we are focused only when we are any events is created. So I just checked it. Now scroll down, and you need to choose the destination, because any event is occurring at S3, so that is source. But where exactly this needs to send the notification, the destination means your Crest mobile number you need to write, right? So the destination should be lambda function, SNS or SQS. If you will look at this one here, what is this? SQS. So you're gonna click on this SQS queue and choose from your SQS queue whether you have created your SQS queue in the AWS account. No, this is something which we are going to update from, like update manually, because we are going to get it from the Snowflake. So I'm going to copy this one, going to enter this and click on save changes. Now everything has been configured. Okay, we haven't configured the storage integration in external stages. That for that you can watch part 14. Okay, but for this we have configured only the event notification. Now if I'm going to upload any new files, and this will automatically get loaded, let's see that. So I have this customer data file. What I'm going to do is run by Megan Fox. I'm updating this, and here this ID is going to be 1001. All right, and these A's I'm going to start from 35, 37. Okay, and this phone number is going to be 777 for everyone. I hope this is going to give you enough idea whether this data got ingested or not. So I'm going to save it. Okay, gonna save this one. No, sorry. Let me save it as a by different name. So there should not be any confusion. Customer data file 2. I'm gonna save it. And now what I'm gonna do before that, let's see the count. Select count star from AWS customer load. We have 20. Okay. Also, yeah. Also, we wanted to check the status of it. So select system pipe status. Now look at this one. Currently, we have not uploaded any new file, or it did not get any messages. You can see the pending file count is 0. Number of outstanding message on channel is 1. Last received message is this one. Last pulled from channel timestamp is this. So this is, you are getting some basic details, but look at this. There is no pending file count. Execution status is running. Okay. Last received message timestamp is this one. You just focus on that. This one is last message, last received message, right? The timing is 13:31:45. Now I'm going to do this one. I'm going to upload it. So I'll go into the objects. I'm going to upload this file. Files. This is customer data file 2, and open that. My file got uploaded. So come here and let's see the count. Okay. Count is still 20. Why? Because it is going to take some time. It's not just going to do immediately. It will be performing this action within the minute. But before that, let me just check the status of this pipe. Now look at one thing. This pending file count 0. Okay, last received message still. There is no change into the last received messages. Okay. Look at this one now. This last forwarded file path, it has been added customer data file 2. Okay. And if you will look at this one, last received message timestamp, it changed to 13:35:00. Earlier it was 13:31, and it is now 13:35. So that has been updated. And now let me just check the count. and count is 30. So to verify whether the data has been populated or not, you're going to simply write select start from AWS customer load, and then here we just need to check in the run by there should be some Megan Fox. All right, so that's how you can continuously load the data from AWS to the Snowflake. Now,
Okay, so one more thing, like if you really wanted to know about your pipe status, whether it got successfully executed or not, and second, how much credit consumption happened in your this pipe load, or you just wanted to know for your entire pipe, and you can definitely change the parameter. So you have to use these two things. One is the copy history. That is basically you need to wait for a couple of hours because this is an account user schema and we have some latency. So for this, you can run this your Snowflake account users copy history. That is the view. For that, you should have some access as well. For account admin can definitely access all the views inside this account user schema. So if I'm going to run it, I may not be able to get some data. The reason, because it would be having some latency, and this account, all the views under the account user schema, they have a latency from 45 to 180, 45 to 180 minutes. So probably like if I'm going to run it after 2 hours, 1 hour or 2 hours, this should have a data. Okay. In the same, the similarly, you can even check into this, you're going into the UI, run into the copy history. And in this copy history, this is the last 7 days. You can just select some pipe also. Yeah, again, you can see this data up to 45-minute latency. Here you can see this customer file 25 minutes ago that was loaded and the status was loaded. So that means there is no error. But yes, if you have multiple pipes and you wanted to check the history and everything, you can simply go into the copy history view. Now, the next question is that how will I be able to get the credit consumption? For that also, we will be using another view, and that is pipe uses history. So this is not the view, basically it's a table function. So here you can use the information schema, pipe uses history, and there you can perform the state range start or end date if you really wanted to know from that particular time. And this pipe name is going to be, I'm going to give my particular pipe, I'm going to run this enter, and you will see that yeah, for this particular pipe, we have spent these many credits.
consider one scenario that I am going to upload one file which is not exactly not having a same structure as of this table. Or what if there are some data type error or some data issues? What will how we are going to get notified in this scenario? For that, you just need to go and check into your snowpipe history, which is going to take time. You will be checking into the information schema that we have. So you can just check into your pipe history, and in the pipe history, you will be like getting it whether it is a success or a failed, right? But this is something you're going to do manually. So in this case, what we have to do, we have to configure this error indication. So as soon as there would be any error, or like when the snowpipe is going to insert some data into the snowflake, but it failed due to some truncation error, data type error, or maybe some kind of a some column count mismatch or anything it can be, then it is going to drop you an email. But how we are going to configure that, we will be looking into our next video. We know that Snowpipe is going to help you to load data automatically from your cloud storage. But in case you wanted to get notification in case of failure, for example, if there is an issue with the file format or if the data doesn't match with the expected schema, then Snowpipe will fail to load the data. And we need a way to detect these errors automatically. I'm not going to ask my teammate to check the snowpipe status after every 5 minutes, 10 minutes, or after 1 hour, and then just tell me whether it got successfully executed, loaded the files or not. For that, I need automated way, and this is something which we are going to do in this video. For that, you just open your AWS account, and we will be following all these steps one by one. So the first thing is I need to create my SNS topic. But before that, let me take you to this previous. So this is the last video where we have created the snowpipe and we have seen it, that how can we check the credit consumption, how can we check if the system the files is succeeded or the failed. You can just go and check into the account user schema. This account user schema is having some latency, so we'll get to know about it after a couple of hours. Okay. Now you will go back to your AWS account, and here the first thing you will come into the SNS. So I'll come into this Amazon SNS. In here, I will be creating one topic. You can see that in this, the create SNS topic. So I'm gonna go, and this is my snow pipe alert. I'll click on next step. Now, this topic will be the standard. It is going to be the name. And if you need this access data protection policies, nothing delivery policies, or let's do not change anything. I'm going to click on create topic. Once my topic is created, now I will be adding a subscription into it. Okay, so you see this option after creating this AWS topic, you need to note this ARN. We will be requiring it. So I'm going to click on create subscription. And this subscription means where exactly you want to deliver your messages, like Lambda, SQS, email, HTTPS, SMS. So I'm going to click on email, and I am going to write my email engineer data 121. Okay, so this is going to be my topic ARN. You can just even copy this one, and I'm gonna paste it over here. Let's say here. Okay, so I'll come here, and this is, I have created my email address and then create subscription. So my subscription is created. Once you have created the subscription, as the next step, you will be seeing the status which is pending confirmation. Now, if you will look at your Gmail, and here you will get one email from this AWS side, and that is, we need to confirm the email subscription. Snowpipe alert. You see, this is the pending confirmation. I'm going to check this one. I guess I have already added for this particular email. That is the reason why I'm not getting it. Any subscription, it's loading. Oh, sorry, this one. Okay, so I got this, and I can simply click on confirm subscription. Once I did that, you see the subscription confirmed, and here you will look into here. This is, if you're gonna refresh it, this will be like confirmed. The status will be confirmed here. Okay, so this is the first couple of steps you're going to follow. You will go to the AWS account and the SNS. You're going to create topic, and then inside the topic, you're going to create a subscription. Whatever the end, like the email address or the number you're going to give it to it, you just need to confirm that also. Okay, after this, we will be going to the IAM, and then we will be creating one policies. For that policy, we need to copy topic ARN into the resources. So I'll come into this IAM here, and I am going to create one policy. I have already created this SNS message policy, but I'm going to create it from the scratch one more thing. So one more time, I'm going to delete it, and then I will be creating the same policy. I did that, and now I'm going to click on create policies. And this one, you need to choose a service which is going to be SNS. First, either you can simply go and copy into the JSON, and there you need to write action and resource. But if you wanted to do it visually, you can just simply select SNS. Effect is going to be allow. And then you are going to check the action which is publish. You're going to search for the publish. That is fine. Now you are going to add the ARN. And this ARN is nothing but your topic ARN. So you're going to copy this ARN here and paste it to here. And click on add ARN. Now go to the next. And the policy name is going to be my SNS message. I simply click on that, and then After that, my policy is created. Once my policy is created, now the next thing is, if you remember, in my AWS, I was using one role. When I fetched the data, I created one storage integration, and inside that storage integration, we were using that role, which is AWS data ingestion. So for the same I need to apply this permission. So I would be requiring to create this notification integration. Inside that notification integration, I need two things. One is SNS topic ARN, and second is SNS role ARN. So this SNS topic ARN is nothing but the same ARN, topic ARN, but for the role ARN, I will be either I can create a new role, or the existing role which I do have, in that I'm gonna use this role ARN, but I will be assigning the policy which I've created here. So I'll come into the role sections, and I do have this AWS data ingestion. All right. So now I will be clicking on this add permissions, and there attach policies. And here I will click on customer manage. So you will get your policy, this SNS message, and I click on add permissions. Now, when I'm going to click on add permissions, and you just need to say, yeah, it's updated. I'll come into the trust relationship, and here in the edit trust policies, there were actually these external ID you can see. So we need this external policies. We need this external ID to update it. But before this, come to this AWS data ingestion. This is going to be your ARN. I'm going to copy it and paste it here. So first we have created a storage integration. Now we are going to create a notification integration, and that notification integration we would be requiring while configuring the Snow pipe. So if you remember, the last time when we created a pipe, show pipe, they were error integration was showing up, and it was completely empty. Notification integration was there, and that was blank. And that is why if my Snow pipe is getting failed, I will not get any notification. Now, once you complete that, and you are going to, okay, it's already there. So I'm going to write create or replace notification integration, which is email. And we have given this topic here, SNS topic ARN and the SNS role ARN. Now, the next thing, you will be describing it just like you describe your storage integration. And you see here, this SNS topic ARN and role ARN. This is something which you provided. There is an IAM user ARN, which is already there, and this external ID. These two permissions you would be requiring to configure or to update your trust relationship into the AWS side. So what I'm going to do is I am going to check this user ARN. Okay, this is my role. I'll come into the trust relationship. And if you will look at it, this AWS ARN is exactly same. So this is going to be same for every single integration you are going to create here. Okay, but if you will look at this external ID, this is updated. Every time you are going to recreate this notification integration, this will keep updated. So I'm going to copy this external ID, and then if you need to pass more than one, now you might be having a question in your mind that Vishal, we have created the same thing for the storage integration. Okay, and if you have not completed that video, then make sure you're going to watch the previous videos. Okay, so in this external ID, I'm going to pass as a list, and now I'm going to click on edit trust policies, and I will be passing one more value which I copied from there. I will be wrapping up with the double. Okay, once it is fine, and I'm going to update the policy. So just check one step. SNS topic we have created. Then we have created a subscription. After that subscription we created, we confirmed that. Then we created a one policies. That policy we attached to that particular role. After that, we took those ARNs and we created a notification indication. Then notification indication, we described it. If we got it, we got some values, and that external ID we updated into the particular role trust relationship. Now, what will happen? if I am going to write, or if I'm going to create any files or going to upload any files into my Snowflake, into the AWS, and if that is not matching with the schema, it will fail. So, but before that, I will be writing this alter pipe and set integration equal to email. Sorry, it should be notification. Notification. Wait a minute. Already is there, but I'm just going to show you how you will be doing it. It's error integration, my bad. So it's you're gonna write error integration equal to email. Okay, now if you're gonna run the show pipe, it was there because I just tested it a few moments back, and you can see this is an email already there now. So that means now if I'm going to upload any file and which is not matching with the schema, or it's going to have some error related to the file format, I should get notified. Okay, so let's do that. For this, I'm coming into my S3 account. Okay, in my S3, and there I am going to upload some file which should be random file. Okay, so I'm going to click on add files, and I know like which can create some error. Anything, any random file, I'm going to try to pick it. Let's say this Spotify data, or let me just pick the simple one, this IPL one. Okay, so I'm going to pick this IPL. But before that, before I'm just going to upload it, let's take a moment back to understand the system pipe status. In here, if you will look at it, this is the last ingested path. File path is IPL data. The last forwarded file path is IPL data. And if you will look at last ingested file is 13 11 48 16. So I can simply copy this one here. Okay, execution status is running. Last received message. Actually, just check this one. This is last received message. You copy this one. Okay. Why it could not get copied? Okay, yeah, this one. So now I'm just going to click on upload. And I know the structure would be different, the schema would be different. So there should not be any, I should just get the email here. So I'm going to refresh it, but it's going to take time. So let me just check the system pipe status, which is going to ingest into the AWS customer load. Okay. Till this time, we have it. Last ingested file path is IPL 2024-01-11. Okay, but here you look at it, last forwarded file path. So if I'm going to run it again, going to execute one again, then you see it, this got updated. The last ingested file path is ipl.csv, and if you will look at the timestamp is 1326, while it was 1120 1148. So this also got updated. And if I come here in my emails, then I got one email that, hey, YouTube learning raw layer AWS customer load stays location. This is the file, and it is saying file name is ipl.csv. The first error is numeric value Hyderabad AP is not recognized. That means we are trying to insert this varchar value into one column, which is already numeric. So that's how you can configure the step by step your error notifications. And it's not only just for the Snowpipe, you can even use it for your task. We haven't discussed about the task yet, but yes, when we will be discussing it, we're going to see it one more time. I hope you are going to like this video and you have understood all the steps. In case you need of these PPTs and all, please let me know in the comment section. In this video, we will explore the concept of external table. Just imagine you are throwing a huge party for your birthday or anniversary, and you have got a fantastic playlist ready to go, like just for your music and all. But instead of using your phone's music library, you have decided to play with the tunes from a friend's music collection. Now, the catch is you do not wanted to bring all their CDs player into your house, but you just wanted to link to their collection using your own stereo system. In a simple word, you do not need to bring all the data into the Snowflake, but whatever data is into the cloud system, you just can access it. Or in another word, we can say if my manager is trying to access or visualize the data, which is already I do have in my data lake without importing the Snowflake so that there should not be an extra storage cost for me. For that purpose, I will be going for external table. So in simple word, a Snowflake external table provide a unique way of accessing the data from files in external location without actually moving them into the Snowflake. Those files can have on AWS S3, on Azure Data Lake or Google Cloud Studio. Now the metadata will be into the Snowflake. So the Snowflake is going to have the certain file level metadata, including file name, version identifier, and related properties. But the actual data will be copied into the AWS S3 or in the data lake only. When I'm going to create an external table, before that, we should have an external stage. That external stage we have already created in our part 15th or 16 when we try to put the, extract the data from AWS S3 and GCS. Okay, so let's get started how we're gonna create it. Now, one more point. These tables are only the read only. You cannot actually perform any DML operation on it. However, we can create view on top of it, and also you can join against of any tables. I'm coming into my Snowflake. I already have created one stage. Okay, so I'm sure if you have been following me, then you would be already having a couple of external stages. I'm going to use this S3 stage. For that, I can just simply check it how many files I do have. Okay, I do have only one files. Okay, so I can create two external table with the help with the two ways. Now, first is if I do not know about the schema or the structure, then I can simply go for it. And there you do not require to know the knowledge of your particular schema or the files. So in this case, I'm going to write create or replace external table and the external table name with location. And this is going to be your external stage. And then you can specify the file format. Now you can not only just going to going to give the properties of the file format like this, but you can also you can also mention your file format if you do have. So suppose if I'm going to create it now, my external table is created. What I'm going to do is I'm going to write select star from my ext table. I'm going to execute this one and I can see that I do have this value column. This value is going to be a variant column which is going to store all the column from the files into a single one only. Now you may need to extract it using the flatten, or you would be just pointing to this particular column and then will be like storing this data into a different table or different view. So for that, if you need to write select value dot c1, and then you can mention as a data type as id. Now look at this. This is something how you can extract the value. So C1, C2, C3 and 4. Now one more thing, if you're going to see, I'm going to write C1 as a small. If I'm going to write it's a C as a capital, it is not going to give me any result. So make sure when you are trying to extract the data from the variant column, it is going to be case sensitive. So it should be a C in the small only. Okay, and you can bring any data. Now if I'm trying to write c3 c4 or something, make sure it should be the same data type, otherwise it may throw an error. So for me, when I executed this varchar, it's giving me like it should be city something, but it's id. You can even rename it. But one thing, if you're going to notice this one, it's giving you some half value. Why I'm going to why I'm sure about it. This is a half value because except this, you see there is a note there. You will not be seeing like double quotes in other columns. Why? Because we were having a comma separated value within a column. For that, what you can do in this, if I'm going to mention one R property field optionally enclosed by, and that way you can run it. Field optionally, I'm sure the spelling is correct. If not, I can simply just wait a second. I can do right show file formats, and I'll go into this just data, and I can, yep, the spelling is incorrect actually here. So if I'm going to write field option enclosed, and now if I'm going to run the same command select value, it is going to give me Hyderabad AP. So I'm sure you have already gone through with my file format video, so no need to explain this, that why did it happen. Now just imagine if I wanted to create a table with all the columns, or so in this scenario, you were not aware of how many columns you will be having, or you were not aware with the schema or structure. So you went for this way, and it is directly going to create the table at the runtime, and you can specify all the column by columns. However, the second approach is you create your column. Okay, so you have access of the file, and then you can actually run your column, like you can actually create a column like this. So we have ID, season, date, team 1, team 2. So these are the all columns with the data type, and then you just need to extract like as value C1, C2, C3, and like that. Okay, so I'm going to create this one also. Let me query this table, select start from second next table. When I'm going to execute this is going to give me value, and other than value, we do have all these columns whichever is available here. This value is the variant you can see over here. Okay, now in case I do not need this value column, or also I wanted to know the file name, like which file name is coming. What if there are 5 files or 6 files and you have created this file name, then you can actually going to know this by the metadata. Okay, so this is the metadata column which is basically stored within the stays, and then you can fetch it through this external table. This is how you can get it. If you will be having multiple files name, you can extract from here. Okay, so there are two ways to create it. One, without specifying the schema. Second, by specifying the schema. Okay. Now, one important thing is you can even creating partition external table. So that means a Snowflake external table can be partitioned while creating using partition by clause based on the logical path that include, you can even partition based on the date, based on the country, or based on any of the logic which you wanted to specify. Okay, after this partition, we have two more parameters which you should look into it. That one is auto refresh and second is pattern. The auto refresh means if you are going to add any new file or going to update it, Snowflake will trigger auto refresh in this external table. The second is pattern. If I wanted to specify to create an external table on particular pattern or particular files, then I will be giving a pattern, or I will be mentioning the pattern in the external definitions. So that is going to be a short brief about the external table, how you're going to create, and the important parameters. Now, if anyone is going to ask you the advantage and the disadvantage of external table, the first advantage is that the Snowflake external table is allowing you to analyze the data or querying the data without moving data files from the external stays or external location. So you're going to save time as well as the storage space. Okay, second advantage is it support query and join operations, so that you can even join with the other tables, and you can even create views or materialized view on top of it. Okay, but The thing is, you are actually taking the data from the external location. So one thing is for sure, that every time we are querying this data from the outside, then the query time will be higher. So the first disadvantage is, when you are going to query the data from external table, it will be slower than comparatively the internal table or the permanent table. Second is, it is only the read only object, so you cannot perform any DML operations. And the third thing, you have to have the external stage before configuring it, so you can, which can actually add a complexity to your system, and which may require some additional configuration for it. Okay, so that's all it for this video. I hope you have liked it. If you have some questions, feel free to ask. Thank you so much. In this video, we are diving into the world of caching in Snowflake. The caching is, I'm sure you must be aware of it, of this term already. But if not, then caching is basically a crucial technique for optimizing query performance as well as the reducing the cost. But how it works in Snowflake, that is very essential for every Snowflake data engineer. In this video, not only we are going to just understand what is caching, but we will be also covering how it works, what are the different types of caching, how can we enable or disable it, and where exactly we will be seeing that this data is coming from the cache or not. So by the end of this video, you will be having a solid grasp of caching concepts, and you will be able to effectively utilize to improve the performance of your Snowflake queries. So watch this video without skipping, and please share with your friends if you really like it. Now, in Snowflake, we have a three type of caching. First one is the query result cache, second is virtual warehouse cache, and third is the metadata cache. This query result cache and the metadata cache both lies into the cloud service layer. If you guys remember your architecture, then we were having three main layer, right? So if I go and going to create this one, so we were having a three-layer architecture. This is a cloud service layer, this is a virtual warehouse layer, and this is a storage layer. In this cloud service layer, we have query result cache as well as the metadata cache. But this virtual warehouse layer, or we can say compute layer, this holds the virtual warehouse cache. Now, how we are going to see that the data is coming from query result cache or not? This query result cache is very important for you. Okay, so let's jump to this, and I'm going to create a new worksheet, and let's term it as caching. Okay, I'm gonna close everything. Let's see that. I'm going to select this my YouTube learning database. Okay, so in this AWS customer load, we have 30 records. So let's do that. Select start from. Now focus on this part. Here it is completely suspended. I'm using compute warehouse, which is completely suspended. So when I'm going to execute this statement, now what will happen? The Snowflake is going to take this Snowflake engine, or means cloud service layer, is going to take this query. First, it is going to validate the syntax. Second, it is going to check whether you have the permission or not. Then it is going to check the query result cache. But when I'm going to execute it, because I'm running it for the very first time, and you see here, it is taking 697 milliseconds to execute it. Okay, and you can see it, even the warehouse gets started. So the first three was there, you can see three colors in the query compiler: compilation, query provisioning, and execution. The compilation means the time taken care by the cloud service layer to validate the syntax error and all, and the permissions. Then the query provisioning is cloud service layer took this much time to spin up the warehouse. And the execution, this warehouse took this much time to get the data from storage layer and then give it to the cloud service layer so that we can get this output. Now, every statement we are executing in Snowflake will be generating a unique query ID. If I'm going and open into a new tab, you will be finding it some statics over there. Statics means like table scans, and we can see scan progress, scan, partition total, and something like that. Okay, but now if I'm going to rerun the same statement again, then it will be taking couple of milliseconds. As you can see, the second time it took 41 milliseconds. The reason, because it is coming from the query result cache. And how we will be making sure that this is coming from query result cache or not, you just need to again check the query ID. And if you will look at the query profile, you won't find anything other than this query result reuse. So whenever you see this query result reuse, that means your data is coming from query result cache, and it will be very, very, very fast. And one important thing, whenever data is coming from query result cache, for that, you do not need this active warehouse. So let's see that. I'm going to suspend it. You see, this one is sleeping, and I'm going to rerun the same statement again. Now you see, this is still sleeping. So that means for the query result cache, only the cloud service layer will come in the picture, and it is not going to spin up the warehouse. So you do not need to give any compute credits. Now, by when this query result cache will be enabled or will be like valid. So one thing which you always need to remember is, even if I'm going to change this query, and let's say I'm going to write current date. I'm just adding one more column, and if I'm going to rerun this, now this query result cache will become invalid, and you can see it is again going to take 400 milliseconds. The warehouse got turned up. That means the first constraints of the query result cache is it should always be the same query. The second point is the underlying table data should not be changed. If I'm going to make any changes into this table, the query result cache will become invalid at that time only. Okay, now the third point is, by when this query result cache will be valid if I'm not going to change this table or not even changing the query. Then the answer is 24 hours. So if I'm going to run the same statement again and again, then this will be into the query result cache for next 24 hours. But if I rerun it again before this clock expire, then this will be get expanded to another 24 hours. Like that, it can go up to 31 days. Not clear? Let me give you a very simple example. So today I executed this statement as 12:42 p.m. and this is 27th Jan. Now this 24-hour means this query result cache will be there by 12:42 28th Jan. But any of my teammate can utilize this query result cache. So it is not just a user specific, it's account specific. Okay, so it is, if I am sitting in Netherlands and one of my friend is sitting in India, they both are having a same access, same accounts, and they are trying to retrieve the data from this table. Then the second person, whosoever is going to execute the statement, then he will be getting the result from the query result cache. All right, so by this, if you this clock get before clock expire, you're going to rerun the statement, then it is going to be again like 12:40 29th Jan. Like that, you can expand this clock, and this will go max up to 31 days. So we have some limitations of the query result cache. The first one is it should be the same query, and the underlying table data should not be changed. In the rest, you can see result cache is fully managed by cloud service layer, and it is available for all virtual warehouse. It is not even like specific to particular virtual warehouse. Then the query result cache is for different uses also. Now, if any one of you wants that Vishal, I do not want to utilize this query result cache, is there any option to disable it? Answer is yes. So to disable it, you need to run this command alter session, and now if I'm going to rerun the same statement, then this will not come from the query result cache. You want to check it out? You just come here and you see here. But one thing you might have noticed that it only took 95 milliseconds. Why? Because now the next caching come in the picture, which is virtual warehouse or local disk caching. So my warehouse is still active. You executed the same statement again. Now, if you will look at the query profile, here you see percentage gain from the cache is 100%. So that means your data is coming from the warehouse cache. If you will look at the very first statement when you executed, it was a 0%. So if you are seeing this into the query profile, that means it is executed by the query result cache. If you're seeing this is a 0%, that means it is directly coming from the storage layer. None of the cache was there, cache memory was there. But if you see this is 100%, that means your virtual warehouse layer cache comes into the picture and it was having entire data. So it bring it and then it gives you the output. Now, what if the date table get changed or you are going to change some of the query? Then virtual warehouse layer will be like active or not. Let's just try that. So if what I'm gonna do is I'm just going to write ID, comma name, and if I'm going to rerun it, let's see what happened. It took 230 milliseconds, and if I'm going to check this query profile, I will be again finding that the query percentage scan from the cache is 100%. So this is also again coming from the virtual warehouse cache. Now, when this virtual warehouse cache will be invalid? Once you are going to suspend this warehouse. So if I'm going to suspend this warehouse, immediately that virtual warehouse cache will become disabled. So we got the clarity about the two cache. One is the query result cache. Second is the virtual warehouse cache. Now the third one is the metadata cache. Metadata cache basically holds the statics of the entire metadata, like whatever the data you are ingesting into the Snowflake, and that comes into the micro partitions. Those micro partitions have their header informations like count, min, and the max, and that every micro partitions header information store into the cloud service layer. That means if I'm going to run how many tables I do have show tables, then this is going to be a metadata operation. Yes. Now, even if you are going to like so databases, so warehouses, your warehouse will not be active. Other than this, if I'm going to write select count star from, let's say, this employee data. Now, even for this table, I'm writing count star, but this warehouse is still not active. It's suspended. And you can see it took 163 milliseconds. Why? Because this is a metadata based results. So in this metadata cache, this is also again going to store by managed by the cloud service layer. It manages all metadata information like row count, clustering micropartitions, table sizes, and whenever we run a show tables or describe table and select count, that is also you can query even in the suspended warehouse. That means no compute credit will be levied by the Snowflake from you. Means I'm sorry, but it means no compute credits charged by Snowflake from you. Now, the range of values such as min, max are also captured. So if I'm going here and going to execute like select, let me take now a big table. So I'm taking from a different database, something big table which is having 150k. And now if I write minimum cust key and when I execute this statement, this took only 59 milliseconds. And if I'm gonna run it, then let's see how much the data I'm getting. Like what I'm saying, it's a metadata based results. So it's not just going to have a count star, but the main max of the partitions, like it is going to have all the key columns. That is something which you can basically query it. And this entire data gets stored into the cloud service layer, which is basically, you can call it as a metadata cache, or you can say metadata results or metadata management. But in the end, it is all managed by the cloud service layer. Okay, so overall, if I'm going to just highlight, we have three type of caching. One is the query gel cache, which is like mostly used because you will be writing your complex statement. Even if you are running a complex statement, but the query is same, then also the data will be coming from the query gel cache, and there is no limit. Like some of you might be having a question, what if I can only store 200 MB or 500 MB? Answer is no. The data will be retained there for 24 hours, and then it automatically purge. But if you're going to re-execute the query again and again, then it can extend up to 31 days. All right, now one thing, if this you are running this statement and your virtual warehouse has some of the cache memory, but later on you performed one more insert statement or you fired some more like copy into command, then virtual warehouse is going to pick only and only the relevant data from the storage layer. Then you might be seeing here this percentage came from the cache is 100 80%, 90%, 60%, depending on the amount of the data which is scanned by this virtual warehouse from the storage layer. So by utilizing this cache, you are not just going to optimize your performance, but you can also save the cost, because you can see here we are not having an active warehouse and still we are able to perform the select statement and all. Okay, now one last thing. This is very important. SQL. This is very important interview questions. That all like what you think in Snowflake. Does all select statement require an active warehouse? Answer is no. Most of time, yes, but yes, we can have a lot of select statement or a lot of SQL statement which we can run in Snowflake, which does not require an active warehouse.
That means we will be understanding one of the coolest feature of Snowflake, which is time travel. How it works, how you are going to access your historical data, by when we can get up to the historical data, and if I'm going to delete or drop it, where exactly that data will gone, we will be understanding it. Okay, so I'm sure that you would be remembering those days when you were working with the traditional databases and you have mistakenly deleted or updated few records. That created a panic, and you would like immediately rush to the DBAs and seek for help that, hey, please give me the backups so that I can install it, I can attach it, I can basically restore that backup before escalating the before getting escalated. But with the help of the Snowflake time travel, we can easily write some SQL statement and we can go back into the time with before making the changes, or whenever like you have deleted the data, that we can easily access. Now, let's understand every single thing one by one. So what we are going to understand in this video, what is time travel, how it works, how we can configure it, what will be the maximum retention period, how can we disable it, how can we roll back our data, like roll back our database if my database is dropped, and fail safe, how can I check how many bytes is occupied by the Snowflake, and what will be the table where I will be looking at all these information. So stay tuned till the end and you will be having all the answers whatever is going in your mind. So I'm going to create one new worksheet, which is going to be the time travel. Now, if you guys remember, when we were explaining about the architecture, I told you that how the Snowflake store the data. So consider this is my 3-layer architecture. This is cloud service layer, this is virtual warehouse layer, and this is my storage layer. Now I'm magnifying this storage layer. So consider this is my entire storage area, which can be on S3 or ADLS or like GCS. When I'm processing any data, when I'm inserting a big file, that will come into this S3, and Snowflake automatically going to organize that into the small chunks that called the micro partitions. These micro partitions are automatically handled by the Snowflake, and user doesn't have to do anything by own. So if I'm processing a data of like, let's say 200 gigabytes, then it can be automatically divided into the multiple partitions. These micro partitions has the size of 50 to 500 MB, and these varies from 50 to 500 MBs. Now, what happened? One more thing: these micro partitions are immutable. So, suppose you have these 7 micro partitions at this stage, and you made a change into this micro partitions where name is equal to XYZ, but now you wanted to rename it XYZ, and again, then you wanted to take A. So if you want to update this value, Snowflake not just going to update it, Snowflake rather than will be creating a new micro partitions, and he is going to keep it, or the Snowflake engine is going to keep this data with himself for a couple of days. For how many days? It basically depends on the retention period for that particular table. This retention period allow the Snowflake to determine for how many days we are going to keep this copy with himself, so user can come back to us and we need to provide this information to him. So internally, Snowflake, there is a guy who will be just handling the storage layer part. So whenever you are updating anything into the Snowflake table, it is going to create a new micro partitions, and the previous micro partitions will be there for a couple of days till like this retention period get expired. Okay. Then once this retention period get expired, then this may go to the fail-safe zone depending on your tables. If you are using a permanent table, then yes, it will go to the fail-safe zone, which is again there for 7 days. But if it is a temporary or transient, it will be 0. So this is how in the backend it works, and let's see in the action now how we are going to query to retrieve the data back. So if I'm going to use my YouTube learning database and this raw layer. Now consider I'm taking any of this, let's say select star from customers. It is customer. Yeah. Okay. Just having a 0 record. So let me take few tables, which is having some good number of record. Let's say taking this AWS customer. Okay. This is having 30 records right now. Now, what if I'm going to drop it? But before that, we just need to understand for how long Snowflake is going to keep this data. So for this, you simply need to run one command equal to show tables. The show tables, if you will look at it, there is one property which is retention time. So that by default, it is a 1 day or 24 hours. That means if I'm going to delete it today, then I do have only 24 hours to back up, to roll back this data. Otherwise, this data will enter into the fail-safe zone. So understand this diagram here. This continuous data protection. So if now when we insert, it is a current data storage. So where like you are inserting the data for the first time, and you are like, you can write select statement and all. Now, when you are going to make any DML operations, let's say like update or insert or delete, then the data enter into the time travel zone. That can have from 1 to 90 days. In fact, 0 to 90 days, because that is totally up to you if you want to disable it or not. But by default, it's 1 day for permanent objects, for transient, and even for temporary. Now, once this data retention period is over, then this data enter into the fail-safe zone, which is non-configurable of 7 days. So if anyone asks, can we disable the time travel? Answer is yes, by setting a retention period equal to 0. But if someone is going to say, can we disable the failsafe? Nope. But if you really don't want to use the failsafe, you have to choose a transient or temporary objects. So let's go over here. Now I can see this is a 1 day. But what I can do is I can make it up to 90 days. So for this, you need to write one command, which is alter table AWS customer load and set data retention time equal to days equal to 10. Now, if you're going to check it show tables, then except this AWS customer load, all the table is going to have 1 day of retention period. Now, why everyone is having a 1 days of retention period? Because it follows their parent retention period. The parent means the raw layer. So if I'm going to see show schemas, then my every single schema will be having a 1 day of retention period. And why? Because this database is also having a 1 days of retention period. Now if I want to change the retention period of a schema, can I do it? Answer is yes. So if let's say I go alter schema raw layer and then I'm doing the same thing equal to, let's say I'm going to set it 15 now, then if you run it show schema, so for the raw layer it is going to be 15. Now one interesting thing which you will be checking after running the show tables, that all the table which were having earlier 1 day of retention time now will be having a 15 days of retention period. So it follows the parent until you explicitly change that. So we have changed it for AWS customer load extends like explicitly. That's why it is going to have a retention period of 10 days. Now today is 30th of like the time currently is 30th June and it's like 11 p.m. in the night. Okay, so if I'm going to delete few records from this AWS customer load, I have 10 more days to recover that. Okay, now one more thing. What if I'm just going to drop the schema raw layer? What will happen? By mistakenly, I have dropped it, and now you see this schema changed it to the public. And if I'm going to refresh it, I will be seeing there is a no raw layer schema in my database. And that can create a panic situation for us because there might be multiple objects which is being referenced to the Tableau or the Power BI. They are creating some reports on top of it. In this situation, what I can do is I'll simply run a command undropped schema raw layer. To recover this schema, I'll just run this undrop command. When I'm running this undrop schema raw layer, I can see this my successfully restored, and if I'm going to refresh it, I should see this raw layer schema over here. And then if you really wanted to check it whether all the objects are there or not, so for that you can simply run command show tables. Now one more thing, if you are going to run this undrop command after this retention period expired, then it will be throwing an error that either the retention period is over or the state like some error you will be getting it. Now let's do one thing. What I'm going to do, I'm just making some operation on this select star from AWS customer load. So I have 30 records here. What I'm going to do is I'm running some update statement. Now, I'm trying to actually run this statement where id equal to 100, but by mistakenly I forgot to add this. Okay, 1 second. But I actually forgot to add this where clause. Now, if you are going to run it again, this select star, and it actually created a mess and it impacted my entire data. Now I can see it's every id is 1000.
So if everyone is going to check it, they might feel like, okay, what have been done, or like what we have done, and then how we are going to check it. So you can simply recover this data in three ways. In time travel, we allow three ways to recover, to basically retrieve your data, or to access your historical data. Now, it's not about just the update. In fact, even you are going to delete few records or going to insert few records, and you wanted to check the data at particular time, at particular snapshot, you can going to check this. So now the whole point is that I have this ID equal to 1000, but there should be like 100, 1, 2, 3, 4, and like that. So the first way is to get your data by going to at particular specific time or day. Second, you can going back into the clock by writing select start from table at offset minus 6 into 5 means 5-10 minutes ago. Or the third way is you wanted to check before any particular query ID. So we'll see that how you are going to use it and how you will be finding this query ID and all. So for this, I'll come here. Now, the first step is I can simply check it, select start from AWS customer load, and here I can write at offset, and this one, okay. Minus 60 means that we are going back into the time, and 60 means seconds. So in this, either you can write like 200 seconds. So if you want to check what was the data 200 seconds ago, you can check this. Okay, basically, wait a minute. Yeah, now if you will look at it, you see that my data is completely fine. I can see this 100, 1, 2, 3, 4, 5, 6, 7, 8. So that means you can just understand that someone misbehaved with this data less than 200 seconds ago. But this is not going to be happen in the real time. I know that I made the changes here, but what if some guy is like playing with the data on Saturday, like on Friday, and you came back on Monday and you find the data is corrupt? So they cannot be, this definitely cannot be a way to go back into the go back to the right data, right? Then what we going to do in the second place? What if we are not able to find out, like you cannot simply go and change it like minus 200, minus 500, minus 1000, and like that. So the best way is you can find the query ID, and then before this statement, what was the data, you can find it. Now, how will I find this query ID? In simple, you can say that on Friday my data was correct. So that means someone might have updated it, someone might have like deleted and then inserted it. So in this scenario, I'll go into the query history. Into the query history, you will be going, and into the filter, you can find out the SQL text, and you can write your table name, particular table name on which you have performed some statement. I'll click on the apply filter because this is going to be, this is my sample account, or my like basically it's not a real account, so it took like less than a couple of seconds to filter out this result, but in your real time that may take 5 minutes, 10 minutes, depending on the number of query executed by your teammates. Now I can see that here we have select star, select star, so this will not be something. Now I can see this is an update. So that means this is the statement which created a mess. So I'm going to copy this query ID, and I'll go back to my worksheet here, and I will be running select star from table AWS customer load before, and then you can write statement, and here you can perform this, you can paste this query ID. Now you're going to check it that yes, before this statement your data was completely fine. So this is another way. The first way is by going back into your clock, means I can go back and check it. What was the data 5 minutes ago, 10 minutes ago? Second is you figure out that particular query ID when when you made a query changes. And it may happen that whatever the query ID I got it, it's not going to give you the perfect result because some other guy also have updated few things. So you need to find out all the query ID, the first query ID, and then you will be pasting it over here.
Now, the third way is that I remember that on Friday at, let's say, 18 p.m. IST, data was completely fine. So in this way, in this case, I'll go back into the clock and I'll write select start from AWS customer load, and I can write a timestamp. So in this, I can like simply copy it because I have to. So one. So in place of the table, I'm going to write AWS customer load. And now here you can write your timestamp. This timestamp means like you need to give your day particular. So this is, let's say, I'm going, I don't know, let's say yesterday. So yesterday it was Wednesday and the date was 29th, and it should be June. Oh, sorry, Jan. And it is 2025. Now, if you are going to check about this time, it should return few things. It should return your data. Now, make sure this is going to be a local time. So if you think that today is Thursday and I was having a data in my India time around 16:20, let's say it's because it is 23:15 means it is 11:15. If you are going to run it now, you see what message you're going to get. It's a future data is not yet available, although we have 11:15 because we are in IST time zone, but the local default time zone is the US, Los Angeles, and the time would be around in morning something. uh, Sorry, it would be around 12 hours ago and something like that. So you can just simply update that and you can make it like that. And here we can see this is the data which was there. Yep. So this data was there, and then we can see this data is correct or not. Okay, so that's how you can find it out. But let's see that. So the first step, why I can just go back into the 500 seconds ago where the data was correct or not. Yes, data was correct. I can see that. And even this is the query ID. I can see that the data was correct. And if I go back into a particular timestamp, then also I can check it. Now, this is just like allowing you to retrieve the data, but that is not actually solving your problem. Because understand, if this AWS customer load is being used by one guy in Power BI, you cannot ask him to query like that because that can be updated. What if someone again is going to make it to like some DDL operations or some DML operations, some insertion happen? What we gonna do this case? In that case, we will be using a help. We will be taking help of zero copy clone. That we are going to cover in the next session when I will be covering a zero copy clone. But till the point, let's understand other few things about the time travel. Now, the next thing is how we are going to check it that number of bytes are allocated. So for it, everyone, you need to remember you will be going under the Snowflake dot account users dot table storage metrics, and in this we can find out the number of the bytes allocated to the particular time travel. So this active bytes, that means how much data we have in my current stage. The time travel bytes, how much data we have into the time travel. So like I can only see there is a one table, like this is one table, let's say this is employee, and I can have the data is only very little, like we might have inserted only 5-6 records or something, and there is no other table where we have this time travel data. But again, this is my just personal account for my own practice and all, so that's why we don't have it much bytes. But yes, you will be working in a real-time project and you might be seeing a lot of data into the time travel and the fail-safe bytes. Now, once this time period is over, that means for this AWS customer load, my time travel is my retention period is 15 days. Then the data will enter into the failsafe for next 7 days. Okay, so remember this thing The failsafe is basically a non-configurable of 7 days period, and this is only and only for the permanent objects like permanent tables and permanent database, you can say. So uh, if someone is asking, hey, can we disable the failsafe? Answer is no. You can use a transient or temporary tables, and the maximum retention period or maximum historical, you can keep it for your 97 days in case of permanent, but it is for above than enterprise edition. In the standard edition, the timetable retention period is only 1 day for even a permanent table. In this video, we will be discussing about the crucial Snowflake topic, which is zero copy clone. This feature is going to be very important in your real-time project implementations, because this is not just going to save your time, cost, as well as like it's going to save a whole lot of your headaches. Because if you remember, when we were working on premises and your client or basically your team says that, okay, hey, you have to do some lot of testing on your data on this table, then we usually go for the backups. So if my data is if I do have some bad data in my production environment, I need to take the backup of it, and then only I was able to create some kind of a testing, or I was able to create some modifications, some DML operations and all. But that was again creating a problem for you, that if you forgot to delete those unwanted backups, then it is going to create a storage issue. But in Snowflake, we don't need to worry about any of this. So the zero copy clone in Snowflake is basically allow users to clone database, schema, or table quickly, and one important thing, that without any additional storage cost. So if I have 1 terabyte of table in my production environment, and my manager is saying that, hey, can't you just clone it and then do some DML operations and just figure out that why the numbers are not matching, then I can simply clone that into the lower environment or into the same production environment only, and then I can apply some my analysis without worrying of additional storage cost. So what's more of like how we are going to clone it, and how exactly we will be seeing it, that okay, that whether it is going to consume any extra credits or not, and in which scenario if I'm going to clone it, and if like when it will be charging extra from our side, and what if I'm going to delete my parent object, then how it is going to behave to the cloned object or the child objects. So let's understand how exactly it works in the backend. So just imagine that if you are if you have already understood, this is this the architecture, Snowflake architecture. This is cloud service layer, this is virtual warehouse layer, and this is storage layer. Now in the storage layer, we know that if I'm going to insert a one big file, that will be creating micro partitions. Now, if this is one table, let's say T1, this is a one big customer, or like one T1 customer table, or you can simply say order or anything. Let's say now this T1 is having a three micro partitions, which is basically size of 50 to 500 MB of uncompressed data. So usually in Snowflake, it will be less than these, because Snowflake generally compress the data. Now, the Snowflake in the cloud service layer keeps the metadata here. So these are the metadata which basically holds the information about these micro partitions. Now, if I'm going to query anything, let's say select max, select count, or select sum, then this cloud service layer is only going to return the information. Now, if I'm going to clone it, then the Snowflake does not actually clone the micro partitions. Snowflake rather than will be creating a separate metadata copy, but will be referring to the same micro partitions. So Snowflake is intelligent enough to understand that, hey, they are just trying to clone the data which is already there, which is already into my storage layer. That's why they are just going to create a separate metadata copy. And for that, it only and only happen into the cloud service layer. No like virtual warehouse comes in the pictures, and thereby it's not additional storage cost. So no additional storage cost associated with it. Let's see that. Now, if I come here, if I see like sorry, this let me actually show it to you that okay, right now I do have this analytics bootcamp database, and in that database I have a branch layer schema, and in that schema I have tables, stages, file format, and pipes, these many objects. My compute warehouse is right now sleeping, so let me just do that, create or replace database, and then I'm not like analytics bootcamp cloned, and then for this I'll just simply use clone keyword, and then going to use analytics bootcamp because I wanted to clone this particular database. So if I'm going to run it now, this took 3.3 seconds, and you see the warehouse is still suspended. The database analytics bootcamp clone successfully created. If I'm going to refresh it, I can see that there is another database for me. Now, if you will look at it, you will be having the same branch layer, information schema and public, those three schemas we have. Inside the branch layer, we have table, stages, file format, and pipes. So I do have all the objects which I have created in the bootcamp. This is how you can create your database. Now it took only 3 seconds with depending on the size. If your data size, if your table is huge, then it may take like couple of minutes depending on the size of your database or your tables. If you're going to clone your database, it is going to clone the other child object also. However, one important thing if you're going to look into this, that if I'm going to expand the stages, here I have 5 stages. But if you will expand the stages inside your cloned database, then you will be finding only 2 stages. So that means it is not going to clone your internal stages, and second, it also not clone the external tables. Okay, now that's how you can just simply, like if you wanted to clone, let's say the schema or a table, simply you just need to use that word or like that date create or replace table, and then you are going to clone it. Now, so one thing we have understood. So let me just take one table. Okay, I'm going under this analytics bootcamp only, and this is my branch layer. Now I can just let me show it to you to take a clone of any table. Let's say this employee table. So what I'm gonna do is create a replace table, employee table clone, and then I'm just going to use clone as keyword and going to now, if I'm going to write show tables, this is an employee table clone. So I mentioned this one thing to you that if you are going to clone the tables or the database, Snowflake will not be charging any storage cost from your side. But this is not the right place to look at the storage or associated bytes. Because if you will look at it, both are showing 9943 records and even the bytes. The actual place, if you want to find out whether it is going to take any charges from your side or not, you need to go into select star from information schema dot table storage metrics, and then you can basically go and mention your like database name. So I can here table catalog equal to analytics bootcamp, and you will find this employee table clone. So this is employee table and this is employee table clone. This is we have created. Now if I scroll to the right, you will find the active byte is 0. So that means Snowflake is aware of the fact that this is something created by the this is a clone table created by the user, and how we will be knowing it that this is referring to any parent table or not. Now focus on these ID and the clone group ID. If this ID and the clone group ID is same, that means it's not a cloned one. But if you will look at it, this ID is a unique ID number created by the Snowflake or assigned by the Snowflake to every table. However, this clone group ID is going to refer the parent table. If it is cloned, then this clone group ID will be the ID of the parent table. Now, if I see this employee table clone is 26626, but the clone group ID is not same. That means it is referring to 5604. So if I look at it, 25604 is nothing but an employee table. I can directly like see it because I have created. However, if someone else in from your team has executed this task, then you can simply get to know with the help of this ID and the clone group ID. You can even write a query like where ID equal to clone group ID, and you can find out the table name. And with the help of inner join, you can write your own query statement. Okay, so as I can clearly see it, there is an active bytes 0. That means this is not going to charge any storage cost. But until when? If I'm going to now make any changes in this employee table clone, if a user make any DML operations, then the Snowflake will charge. So what exactly happened? I'm coming to this point. There we have seen it that the snowflake is actually, let me take another color for you. This is a green color. Okay. So snowflake initially for this micro partitions for this metadata, and this metadata is referring the same in existing micro partitions. We know it that the micro partitions are immutable. Now, if you have created, this is a clone table and this is an original table ka metadata. Now, if I have added 10 records, then it is going to have an additional micro partitions, and this is just going to be referred by this metadata because this is a separate micro partitions and this is for cloned one. So if you think that the clone will never ever be getting charged, answer is no. The Snowflake will not be charging any storage cost until unless you make any changes in that. So as soon as you are going to make any DML operations, it is going to add a new micro partitions, and those bytes is going to be charged by Snowflake for that particular cloned object. And once you see that you're going to make any DML changes, and here you will be seeing some pipes. Now, the next point is, okay, so after this, we can see there is a charges and all. Now, next point is, if I am going to make any changes into my parent object, that means if I'm going to make any changes into my this employee table, will it be impacted in this employee table clone? Answer is no. So each of these objects is independent of each other now. So you can just imagine that this employee table clone was the snapshot of this employee table. So if I am going to add any new records or going to delete it or even going to drop it, it's not going to be impacted. Let's do one thing. So what I'm going to do is I am going to truncate the table, employee table. Now, if I'm going to write select star from employee table, it is having 0 record, but we have created a backup. This should have the data. And yes, it has a 9.9k record, so basically 9943 records. So if you are going to make any changes into the parent or into the child object, it is not going to impact each other. Sounds good? Now, if you guys remember, when I was explaining about the time travel, I say that how we can roll back our data. So we were discussing about the time travel, that how we can like query the previous or query the change record or updated record, whatever like you mistakenly you have updated it, and if you wanted to do a query or historical data. But the problem was how can we roll back or how can we like basically install that. The whole point is, just imagine this is an employee table. This is my final table used in reporting. Okay, but right now we do have a zero record. I do have a zero record. Now I wanted to reach in point of a time where this employee table was having 9,000 record so that I can share it with the Power BI or the Tableau people. In this scenario, what I'm going to do is I will be using time travel plus copy clone. So I need to use both time travel plus copy clone. So I'm going to write like this, create or replace. And let's say I'm going to take employee old, and this I have to use table. And here I'm going to write clone. This is going to be employee table. But here I will be writing at offset. You can use anything, minus 60 into 10. Now, what I have done, I have created a cloned copy of employee table, but 10 minutes ago. Sorry, 10 minute ago. Yes, 10 minute ago, because it's minus 60 and 60 into 10 by 600 seconds. Now, if you will look at it, then you will find select star from employee. Then this is going to have your correct data. It's 9.9k record. So we are one step closer that yes, we have that correct data, but the problem is this employee table is being used in Power BI. We cannot simply ask anyone that by please can you please update this table, right? Because there's some standard procedures that we cannot simply touch the data sources, be in Tableau, be in Power BI, be in Looker or anywhere. So what can we do now? The best way is that you are going to write alter table, employee table, and then we can write swap with employee old. Now once you execute this, and now you see, if you're going to run select star from employee table, you will be having your entire 9.9k record. So that means if anyone is asking you to install or to basically reinstall that data, then we can simply say I will be using a time travel plus copy clone, and then that's how I can restore my entire data. After that, we are using the swap with keyword. That means whatever data we do have in this employee old, that will be going to the employee table. And then we are just like swapping, just kind of a swapping the variables. We are swapping the tables here. So that's how you can leverage your time travel plus copy clone to restore your tables, restore your data, and that before getting things escalated and all. Now, one of the last thing, one important question I do have for this time travel, which I generally ask in interview, and 99.99% people fail to answer this, that if I have one customer table with 100 columns, and that is having a 1 million record. Now, by mistakenly, I created another customer table with 10 columns. Then how will I reach to my previous table? If you think that the time travel, we can simply go and use this offset and all, then this is not going to work. Wanted to check it out? Let's see that. So what I'm gonna do, I am going to create select star from customer. Yeah, let's say I do have this customer table. In this customer, I have around six columns. So consider these are the 6 column and 12 record. This is my correct data. Now by mistakenly, I have used a command create or replace table customers. And there I just use id int. Now, if I'm going to write select star from customers, what will happen? This is going to give me 0 record with just ID column. Now, most of you think that, okay, hey, Vishal, why can't we just simply go for the time travel? That means I can simply write at offset minus 60 into, let's say, 10. But what will happen? This is giving me time travel data is not available for table customer. The requested time is either beyond the allowed time travel period or before object creation. Because I'm trying to get the data of the customer 10 minutes ago, but if you remember, I just created this customer, recreated this customer table. So in this scenario, this Snowflake cloud service layer will try to go and find basically we are asking to Snowflake to go back into the time travel and find out that particular micro partitions. But cloud service layer is saying, "Bhai, wait, hold on. You just have recreated the table." So in this scenario, the next step, what you're going to do is you will be first going to create alter table customers, and then you are going to rename it. Rename to, like, let's say this is old customer, something like that. And now you are going to run a command undrop table customers. Now if you will going to run it, select star from customers, and then you will be finding your 12 columns, sorry, the 6 column and your 12 records. This is one of the important and one most asked interview questions. So I'm sure you have understood that how you are going to leverage the time travel and the zero copy clone. And in this video, we will be discussing about the views. What are the type of the views we have in Snowflake and when we are going to use which one. So, like if you're coming from a normal database background like SQL Server, Oracle, you might have already familiar with the terms of view. View is just like a virtual table, which is going to store or which is basically allow you to query a data just like you are querying a normal table. So if in simple word, if I have to create I have one requirement where I have one table with around 100 of columns and with 1 million of records. Now in this one, if I just wanted to hide some column level or row level, like I wanted to implement some column level or row level security, I will be going for the view. And also, if what if I'm combining the data from multiple tables, and that is something I need to present to my reporting team so that they can use it for their dashboard purpose and report purpose, then I will be creating a views for them. To create a view in Snowflake, it's going to be very simple. So let me just show you. I'm going to give into this particular database, YouTube Learning, and the raw layer. Right now, if I'll see, and if I'm going to run show views, this is how we can check it whether we do have any views or not. And right now I don't have any views. So what I'm going to do is I'm just going to create one select star from Snowflake sample data dot tpchsf1 and dot customer.
Suppose this is one table I have, and which is going to around have 150K records. I can see that in this view, I do have a multiple nations key, which is like the nation key. I can see it. Now, what if I just wanted only and only 15 and 30 nation key? And that data, the other data should also not be exposed to the other person or to the other customer. If I'm going to give it to this table only to the reporting guy or to anyone, then they will be writing select star from this customer, which may expose, or like they will be basically getting the complete control, or they will be able to see my entire data. In this case, what I'm going to do is I will just simply ask them that, okay, why don't you just query only this thing or Snowflake, and then the nation key in 13 comma 15. Now if I'm going to ask them that, okay, you just need to query this data, but still they will not do it, right? They might be like thinking, okay, what if I'm going to check it for 1 to 14 or something? So what I'm going to do is I will be creating a view on top of it. So in this I can write create or replace, if there is a view, vw, and that is going to be like, suppose like limited, or probably like it's a US customer. I'm just assuming that this nation key 13 and 15th are from the US. So now after that, I need to write as means I'm going to wrap this entire definition in this view WUS customer. So I'm going to create it, and my view is created. Now I will be giving only and only the access of this view customer to my particular reporting team, and they will be able to access the data. So this is how I can implement the some row level security. Why? Because I'm giving everything like select star. Now, what if there is a requirement that my team is saying that no, there should not be any need to expose this account balance? Just imagine that you are working you have one banking industry with you, and there your manager says that these person who is just going to handle the customer tickets, they should not be exposed our credit card number and the account details, CVV and others. This is very sensitive data, so they should only and only be able to like get the information like the customer name, customer address, and some last four digit. So basically, we just need to implement a column level security. In this case, what I'm going to do, I will be creating another view, create or replace view, and that is, let's say it's going to be VWC customer. Suppose it's a column level security. So it's just a naming convention which you can follow whatever you want as per your wish. Now, after that, I am going to write select. Now, in the Snowflake, we have one more cool features, that is a basically exclude keyword. So if you have hundreds of column and you want 90 of the column, then you do not need to explicitly mention select column 1, column 2, column 3 like column 19, and then you are going to miss those 10 column which you do not want in your definition. Rather than you're going to mention select star, and then you're going to use keyword exclude, which is going to help Snowflake engine to understand that this column I do not need to select in my output. Okay, so which column? I do not want the account balance, and then I would be writing the Snowflake sample data tpchsf1 dot custom. And before creating this view, let me show you how this query output will look like. And you can see after this nation key, we have phone market segment comment, but we do not have the account balance because this is something I do not want to expose them. And because this after this account balance, the phone number is also very sensitive information, suppose, and I'm asking if he can hide it. Now I'm going to run this, and this is how my another view will be created, which is VWC customer. Now, in case if any of the user is going to query that, they will not be able to, and they will not be able to see the account balance and the phone number for every single person. So here I was getting around 12,000 record because I implemented a row level security. Here I'm getting 150k record, but I'm not getting a phone number and the account balance. This is how you can implement a column level security. Similarly, if you need to join, let's say you wanted to get a nation key and all, then you will be joining this with a nation keywords. And that you wanted to hide. So means in case if there is a requirement to hide the complexity, what if you are getting a data from multiple tables and then doing some aggregation and all, that also you can hide with the help of views you can share with your reporting team. Now, understand few things. This view itself does not store any data. So whenever I'm going to query it, it's going to query this underlying table first. So it's going to compile it. And if I'm going to make any changes in this table, then it will fail. Okay. So it does not store the data. That is why it is going to be some like performance issue would be there. So we can just see that if a query expression that return a valid digit can be used to create a non-metallized view. So either I'm going to create it as a normal view or a non-metallized view. It's going to be the same purpose. Now this one, the normal view. Okay, let me just jump to it. So it is not going to store the data. So no storage cost associated with it. Every time there is a change in the data, it will only and only going to refresh the data at the runtime. Okay, so if I'm going to query this VWC customer and underlying table has a customer, which if there is any change, then only at the runtime execution time it will get refreshed. Next we have is a metallized view. Forget about my spelling. Okay, so this metallized view, the one of the good advantage of having a metallized view in Snowflake is that it stores the data as if like it is storing for a table. So it most of the time it behave like a table only. Okay, suppose I do have this customer data and I'm trying to create a metallized view for the same, and here I'm writing MVW. And here, for creating a metallized view, I will be using the one keyword which is metallized. So the definition is going to be almost similar, except one extra keyword which is metallized, so that Snowflake engine will understand that the user want me to create one metallized view. Now, if I'm going to create this, and then I can simply will be querying it like as if it is going to be a. But this is going to store the data within memory, means you have to pay for the storage cost, and because it is storing the data, so that's why the performance will be much better than the normal view. Here we have 150k record, so you may not be able to understand, like you may not be able to observe a good performance. Like if you're going to compare it, there won't be a good difference. However, if you have millions of record and there is a requirement, the table is not getting changed very frequently, and also you wanted to perform some aggregations like a min max and all, then metallized view will be a best choice. Okay, so understand, if the requirement is that you need to perform some aggregations, the table is also not very frequently updated, like it's not updating, and you are willing to pay some storage cost because you will be getting some compute benefits, means performance benefits, then you will be going for metallized view. However, there is one limitation, one big limitation of Materialized View in the Snowflake, that is, let me show you. Suppose I am going to write one definition for you. There, I'm writing C, and okay, and that I'm joining inner join, and on. Now, If I'm going to execute this query, this is going to give me an output. You can see it is taking 1.1 seconds. Now, if I'm going to create a Materialized view, so basically my entire requirement is to find out to perform some aggregation, or I can simply say I wanted to know the the nation wise, let's say n dot nation, which is n dot name. Okay, dot count, and that I can write C cust key. So I wanted to find out the total number of people in every nation, and then I will be doing a group by all. Now, if I'm just running this select statement, this is going to give me an output, which is completely fine. And count of C customer, I can say the total people. Okay. But if I'm going to create this definition under this Materialized view, it is going to throw an error, and the error means, which is a limitation of the Snowflake, that invalid Materialized view definition, more than one table cannot be referenced in this in the Snowflake Materialized view. Okay, so understand, if you need a better performance, if you want to perform an aggregations, then Materialized view can be a good choice. But if there is a requirement to get the data from more than one table, then Materialized View will not be an option anymore. All right. Now, if you will run and show views, how will I know that whether this is a normal view or a Materialized view? I mean, I'm not getting anything over here, but if you'll scroll to the right, there is a one flag. It's is secure and is Materialized, and is Materialized is true. That means it is a Materialized view, and these two are the normal view. Now, you may be asking that Vishal, you may be doing some mistake in the definition. That's why it is throwing an error. Can you please show us to create a normal view with this join or with the aggregation? Okay, let's see that. And if I can do this, vw1 underscore customer, whether it can work or not, let me run it. And you see, this is going to be work. Okay, so understand few more things that Materialized view are particularly useful when you wanted to query a result which is going to contain a small number of rows or column related to the base table. Second, you have some data in your external table, and because directly Snowflake is going to pull the data from the external storage area, so it will be a like a slower performance, and you wanted to optimize the performance, then you're going to suggest that I will be going for Materialized view. The third thing, when your base table does not change frequently, then the Materialized view will be a good choice. However, there is a one big limitation that we cannot reference more than one table. All right, now, but Materialized view comes with a cost. It's not only just comes with the compute cost, but it comes with the storage cost also, because it is going to store the data in memory, and that is the reason Materialized view is a bit faster than the normal view. Second, this Materialized view is basically kind of a serverless, not kind of, it's completely serverless. So whenever we are going to update the data in the backend only, it is going to refresh it. So you see the Snowflake perform automatic background maintenance of Materialized view. Whenever a base table changes, all Materialized view defined on the table are updated by a background service that use compute resources provided by Snowflake. That means serverless. Okay, so now consider the main differences between these two by like this table. So in Materialized view, can we query from multiple table? Answer is no, but in normal view, yes. Support for self-join, Materialized view does not provide it, but normal view provided. Pre-computed data set, yes, because pre-computed data set means if my table get updated, then Snowflake serverless feature will be updating that query, updating the data in the backend and going to store in the memory. So you will be having a good query performance. Now the storage cost in Materialized view, yes, you have to give it because it's a pre-computed data set, but in normal view, you do not need to pay for the storage cost. And the compute cost charged only when you are querying it. The normal view, only when you are querying, then only you will be paying a compute cost. However, the Materialized view, it charges on based how many times your table is getting updated. So if any one of you think that if I'm updating any of the table, which is going to impact the definition or is it going to refresh the data, then if it is a Materialized view, then automatically it can. But if it's a normal view, it will refresh only when you are going to query that. Now, there is one more thing which I wanted to show you guys. When I run the show views command, you might have observed one thing which is secure. This is false. What does it mean? And when I'm going to use this is secure view? That's a very important question. And most of the time, interviewer will be try to understand whether your fundamental is clear or not. Okay, so let me show you one thing first. If I'm going to write select start from, let's say, yeah, VWUS customer, when I'm going to execute this, it took 1.6 seconds. I'm going to share this view with reporting guy or with, let's say, different people. Now, if they will go into the query ID to find out or to basically understand the query profile, then in this, they can get to know about it that this is one of my view which is created on this particular table and I am taking all 8 out of 8 columns. That means the view definitions, along with how what are the columns they have and what are the tables we have, it's basically getting exposed to the users, is getting exposed to the other person. Okay, so non-secure view, some of the view definition is visible to the other user. They can even like check it. If I'm going to write show views, right now it is going to visible because I am the account admin and I am the owner. But even if I'm going to give an access to the Power BI developer role, and then when he is going to do it, this text will be visible. But if I'm making it a secure view, then he will not be able to access this definition. Now the question comes how I'm going to create it and when should we create it. So first, let me try to show you to create the same secure view. For that, you just need to use the keyword secure and I'm going to write SVW1 and going to create with the same definition because my main motive is just to show you how it works. Now I'm going to write a select start from SVW1 and if you sorry, and if you will open this query ID, then you see there is nothing, no other object information that from which table you are trying to get it, how many column you are accessing it. There is nothing information related to it. Okay, so if you have like basically secure view, if you wanted to particularly designate it for data privacy and you wanted to limit access to the sensitive data that should not be exposed to all user of the underlying tables, then you will be going for secure view. But do not just go for the query convenience and you are even like blindly creating a secure view, then this is not going to benefit because secure views can execute more slowly than the non-secure views. Okay, so you may see a performance impact if you are going to create every view as a secure view. Second, if you wanted to share perform data sharing in Snowflake, then you can only and only perform with the secure view. So if there is a non-secure view, that you cannot share in your data sharing part. All right, so that's it for today. I hope you have a good understanding of the views and when you are going to use which views, what is the cost associated with them. And if I wanted to hide everything like a base table information and other definition, they should not even able to get the definition even when they are going to run a get detail command or show views command, then I will be going for secure view. So if you really like it, like this video, then give a thumbs up and share with your friends. Thank you. In this video, we will be discussing about the Snowflake streams, means how the Snowflake stream is going to help you to implement the change data capture. Now, before that, let me just give you one very simple example that why this CDC is required and where exactly you will be implementing it. Just imagine you have one table. Well, let me just come to the Snowflake. We have, let's say, this employee data. And now, if any one of your team member is making some operations like insert, delete, or update, and you wanted to capture or you wanted to basically know that who made the changes or like whether the insert happened, delete happened, or update happened. And just to figure it out, you probably would be like comparing with the row versioning, or like you may be requiring like you may take help of time travel, or otherwise you are just going to take a snapshot of like the tables, or you're going to compare with the backup of the table and then going to figure out, which is going to be very time consuming. But the Snowflake help us, like Snowflake has the stream concept, which is going to help you to capture all the DML changes whatever we are going to make on it. Okay, so in this one, let's say what are streams in Snowflake? It's basically a CDC mechanism used to track changes in the data at the row level in Snowflake. So if I'm going to insert anything, delete it, or like update, it is going to capture all the operations performed by any user on that table and going to store into the streams. Now that stream does not actually store any data, but it's a store only and only the offset. So how it works, we will be understanding in the next slide. But the streams record DML operations that are made to table or views. We can create it on the tables, views, dynamic table, external table, event table, or iceberg tables. But most of the time, most of you will be either creating the streams on the normal tables or views or external tables. Okay, how exactly stream works? So before going technically, let me give you a very simple example. Suppose this is your room or this is your house, and you are going to like you are staying alone. You leave office every day at 9 a.m. in the morning and then come back around 6 or 7 p.m. Now, in your room, you have this table, you have here the television, you have couch here. Okay, if anyone jumped in, or basically one thief tried to like entered in your room or entered in your flat, and he took away few things like a remote from here and your shoes and let's say the small things. Now, when you will come back like from the office, it is going to be very complicated for you, or like not very difficult for you to identify whether any thief get into your room and just stole some items, because he took away like very small things. So in simple word, if you have a 10 million of records in a table and someone is performing some 500 or 1000 insertion or updation like DML activities, then for you it is going to be very difficult to track that. Now, suppose if it is happening multiple times, then you would be quite dubious that what is actually happening, because I am living alone. Where is my remote? Where is my shoes? Where is my clothes and all? That you won't be able to figure out. So your friend is going to suggest one idea that why don't you install a CCTV camera? So he's going to help you to like one contact number and you install two CCTV cameras. Now, how this is going to help you? So, if let's suppose there is any thief, any new guy is trying to jump in your room and jump in your flat, and if he's going to take anything or he's going to put anything in your room, you will get to know by just simply on your mobile or however you have configured. Otherwise, this CCTV camera is going to capture the records and then you're going to watch on your television. So that exactly the streams work into the Snowflake. So it is going to take this snapshot. But yeah, one more thing. So this Snowflake, how you will be identifying, because the camera is going to take photos of every minute or going to like record it. Understand that camera is going to take capture of photos in like a previous movies and all, and then you are comparing photos by photos, and then you will find the differences, or you will find what exactly happened. So the stream actually taken snapshot of the table. So if I do have 500 records, 500 rows, then stream is going to take the snapshot of every rows. Then Once this is created, then Steam begins recording the changes. So if I'm making any changes on that, then it's gonna compare that previous snapshot with this existing operations, and then it is going to capture those whatever happened, like it's whether it's an insertion, update, or delete. So this each change event contains state of the row before and after the changes and the metadata about like the action, whether it is insert, delete, and update. Okay, so in this, just a second, the stream metadata column, you will be having three columns. One is metadata action, second is metadata update, and the third is the metadata row ID. Okay, so I'm just going to quickly recap that. Stream object is basically record the DML changes, whatever made on any tables, include insert, update, and deletes. Stream does not record any data, does not hold any information. It just like going to store the metadata information of these three columns, the metadata action and update. So it consumes only like small amount of storage. Okay, now understand that stream is going to be as a bookmark, which is going to indicate a point in time in the page of a book. So which bookmark can be thrown away and other bookmark can be inserted at the different time. Like if you are reading one book, suppose if you could not understand this example, you are reading one book and you started reading a book from page number 1 to 10. You are going to put the bookmark on page number 10. Now when you are going to start it again or the next day, you will be like throwing away that bookmark, or you will be putting it at a different location. Okay, so now let's just understand how it's gonna work. So to create a stream, or to understand that I right now I do have in my employee data, I do have 15 records. Okay, I'm taking an example of this employee data, and if I'm deleting anything, suppose I wanted to write delete from employee data, but yeah, okay, before that let me just insert this one. Rather than deleting, I'm inserting this. Now if I'm going to run select star from employee data, I cannot find out which record had been inserted, probably because this is a very small records, like we just have 15 or 16, so we can get some idea that yeah, this one is the last record got inserted if we do have any load date time at all. But what if there is any deletion or any updation in the columns, then it will be very difficult to track it. So for that, what I'm gonna do, I will be creating a stream. That's how you can create a replace stream, stremp, and on the table. There are few other parameters which we will be talking about later, but if you can see, this is how I'm going to create the stream. And then if you are going to write source streams, it will going to show you a few things. Okay, so this one is stale after. Let's understand one by one. So when it got created, it's 11:41, but it's basically 12th Feb. That means it is going to be yeah, it's a US time, but in India it's going to be 1 a.m. in the morning. This is the name, the database name, account admin, and then we can see the table name, the base table on which it got created. Then the type is delta mode default. This you will be understanding when I'm going to create another stream, that what it is going to do. Now, this is very important, the stale after. That means if I have created the changes, and now if I'm going to make any operation on this, if I'm going to XYZ, like going to delete it, going to insert anything which I'm going to do is, that is going to be there in the stream for next 14 days. So this 12 to 4, like it's going to be till 14 days only, and after that if you are not going to consume the changes, it will get stale, means it will get lost. So in simple word, if you have that CCTV footage in your camera, in your like the camera is actually storing it in your hard disk, but if and it's basically having a small memory card of 1 GB, but if you're not going to utilize that footage within 14 days, then that footage will automatically get deleted and you won't be able to recover it. I hope that clears the point. Now,
How would I query the streams? So it's very simple. Just like querying a normal table, you can query the stream. So if you will look at it, there we have all the columns like ETL load date. But if you'll scroll to the right, you will be finding these three metadata columns: metadata action, update, and row ID. So this action is going to tell you whether it is insert or delete. Update, it's going to show you whether it is the operation was part on of update or not. And this is going to be update represented delete plus insert pair. So by theory, you may not be able to get it, but when I'm going to showcase you, you will definitely understand. Then which is having a metadata row ID, which is like a unique identifier for each row. And that is useful for tracking changing over period of time. Now, this is how streams visuals basically like how it is going to be utilized, how you are going to see that in your Snowflake. So suppose this is your first table, table 1 at V1, like means a version 1, where this record got inserted. Okay, so as we can see, the black one is insert, the red is delete, and blue is update. Now, when it got inserted, it got one record with this insert, update, and row ID. But when we have updated, is basically going to show you two records. And this metadata update is coming through. So if I'm going to update any record, then first it is going to delete it and then going to insert. But how? Let's just understand one thing. Okay, so what I'm going to do is the very basic thing. I'm just going to write delete from employee data where AMP ID equal to 999. Let's see how it works. I have deleted it. Now one record got deleted, but if I'm going to query the stream, then it will be having the one record. So this is how you can get to know that yes, this is one record got deleted from employee data. Now, if you will scroll to the right and you will find this metadata action is delete. That means someone has removed this rows from the table. Now, what I'm going to do is I'm going to perform one more thing, which is basically here. I'm inserting like 4 times 9. It's not just Rena, it's just going to be Samay. And let me just put it as Pune. And then I'm going to insert. Now I have inserted one records, and if you will look at the select star from str employee, you get two records. One is basically deleted, but this one is inserted. But both the records having metadata is update equal to false. That means these records or these results was not part of the metadata update. Means like not part of the update query. Now, if I go and write select star from employee data and I'm gonna update set name equal to any random name we do have. Yeah, this one we have A. So what I'm gonna do is set name equal to Avinash where name equal to A. Now, this one record got updated. We see number of rows updated. And earlier, we were having already two record in this stream. So how many record it should have now? What do you think? Is it going to have three? Answer is no. It will be having four records. As you can see, this is having a four record now. And if you will look at it, there is one is A and that we have deleted, which is metadata update is true, and this one is insert and metadata is equal to true. But how we are going to identify whether this A was there and Avinash we made it based on this metadata row ID. So if I'm going to sort by row ID, you will be checking these two operations are going to have a same row ID, and it's a combination of insert and delete, and metadata is update equal to true, and you can see that this A got deleted first and then Avinash got inserted. In simple word, if you wanted to understand how it works, so consider that there is a monitor class monitor who is actually writing the name of those students who are making a noise on the whiteboard, on the blackboard, or on the blue board. So suppose I am the monitor and I write a A. Now, the other guy who told me that, oh, it's not the A actually, it's the Avinash. So, first I'm going to erase it. That means I'm going to delete it. And then next, I'm going to write A to Avinash. So that's how it is going to be captured in by the Snowflake. Okay. I hope that's clear that how it is going to capture. Now, the problem is I wanted to actually utilize this data, but right now this is only and only for the 14 days. What if I wanted to keep this data for minimum 20 days? Okay, suppose there is a requirement that I want the user should be able to keep these changes for at least 20 days. In this case, I do have one property. I'm sure that you have already gone through with this, the retention period. Now, in this case, I'm going to do alter table employee data, and then I'm going to write set max data extension in days equal to 20. Now, when I'm going to, oh, it's invalid properties at max data extension. Oh, my bad, my bad. It's going to be extension time in days. Okay, now this is the property we do have. I set it up. Now, if you are going to run command like, okay, why this caps is on, show streams, and if you'll scroll to the right, you will find that this has become now 4/3/2025. Earlier, it was 27th Feb, and that means like 14 days, but now it's 20 days, and it is going to be stale after 4/3/2025. And this is the max you can set up to 90 days. And that's how, if you think that, okay, no, I wanted to keep this track for next 90 days. So you can, this is how you can like update the stale period. Now, coming to the type of the streams, so we do have three types of stream. One is standard, append only, and insert only. So this standard, okay, it's basically, this is the type delta we can see over here, which is a standard type. That means it means like, sorry, the mode is default. That means it is going to capture, delete, insert, update, everything. However, if there is a requirement for you that it should only and only capture the inserted, means the only records is being added by some users. For that, I am gonna create a new stream, that is create or replace stream, and this is going to be str2 emp, and then I'm gonna write on table employee data. Again, I'm going to create, oh sorry, my bad, and then, but here I'm going to write append only equal to true. Now, when I'm going to write append only equal to true and going to check show streams, if I scroll to the right, I can see the stale after period is fine, but look at the mode. So if it is default, that means it's standard, which is going to capture, insert, update, and delete changes. But if it is append only, you made it as true, that means it is going to capture only and only the inserted records. Now you make like have a doubt, then why do we have this insert only streams when we have this append only? The reason, because insert only streams are only and only for Apache Iceberg or external table. It is append only cannot be used on these external tables. So for that, it is going to be you like created insert only. However, this is going to deliver the same purpose. That means it is going to have going to capture only the inserted records. Okay, now let me just show it to you. So if I am gonna create, let's say we do have created. Now what I'm gonna do is I am going to write, the data is already there. So let me try to delete something. So select star from employee data, and let's say I'm just going to delete this record. Okay, so what I'm gonna do is delete from employee data where name equal to Anshi, and let's see that. Now when I'm going to do it, select star from str to emp, I will not be having any record. The reason, because I deleted it and the stream was capturing only the append only records. Now if I'm going to insert one more records, like one record in this, and that I am going to change it. I'm going to make it to Anshi here, and this record is going to be 1001 like that, and rest everything is same. And if I inserted it, now I will be having a record in the streams. Okay, so if the requirement is to capture only the inserted record, then you will go for append only. Okay, so that's how you can create it. I do not have, sorry, yeah, I do have an extendable. So if I wanted to create insert only, let's suppose that on the same table, if I try to create insert only, because it's a normal table, and what if I'm going to write insert only equal to true, then what will happen? And I'm going to create a third stream because I do not want it to get an error that the stream already exists. And you can see it can only and only be created in action table or iceberg table. Okay, let me see if I do have an external table in my schema, this raw layer. If yes, then I'll definitely gonna create these tables. Yeah, this is my ext table. So if I'm gonna use this my case, what I have to mention, like external table, and then I'm going to write it. And that's how this the stream on external table can be created. Now, if I wanted to consume it or I wanted to change the offset, so how offset is going to be created? That once you have understood or once you have consumed the data, so this is going to be change the offset. For that, you are going to write create or replace table that is like consumed stream, something like that. Consumed stream as select star, and I'm going to use this exclude keyword because I do not want these metadata columns. So I'm gonna write in such a way that select star from str to employee, and here I am gonna write this one, exclude metadata action, metadata row id. I do not want these two columns from str employee. And now if you will run this command, then if you will look at the data into the consumed stream, you will be having few records. Okay, and only the row id is coming so that you can identify that which record belongs to which operation. Okay, but the surprising fact is if you're going to query this stremp now, it won't be having any records because you have consumed it. That means the memory, the data from this the camera memory you have transferred into the hard disk, so that's why there is no data. Okay, so that's how you can change the offset, or that's how you can basically consume the streams. Okay, now where exactly you will be using it, it's basically to implement a scd or to implement an incremental load. In this is the like two major use case which you will be implementing it. And in the next video we will be discussing about the task, and that's where I will try to show you the use case of the streams and the task together to implement scd type m1 and type 2.
In this video, we are going to discuss about the task. The simple things, if you have to automate your data pipelines within the Snowflake, if you just have to basically make a or orchestration of your workflow, you wanted to schedule some code, then we will be using a task. Just imagine that we in previous videos we have seen how we are going to manually run the copy into commands. If the data is coming from the AWS S3 or ADLS or GCS, you can probably check my part 15th or part 14 15th. There we were running a copy into command manually.
But what if we have to create a multiple like steps? So once the data come into the AWS S3, it should be loaded at let's say 3 p.m. every day. And after that, we need to perform some data cleansing task. Let's say some like null check or some distinct certain duplicates values removal and like these kind of a transformation you're doing. And at the third step, it should check whether the stream has data or not, and if it has, then it should trigger a fourth task or something. So in the Snowflake, task enables the automation, scheduling, and optimization business process within your data pipeline. You can basically you can work with this Snowflake task and the stream to design a continuous ETL workflow. There, we do have two types of task. One is the user managed, and second is the serverless. Now, let's look at this kind of a syntax which we will be using. Okay, there are certain parameters which you will be using depending on your requirement. These are like optional parameters, so I'm not going to use all these parameters in this video. However, I'll just like you can go through with the documentation to understand that, but I'll try to give you the important parameters details. We can run below commands like a create task, alter task, drop task, show task, or describe task. So if you have to check how many tasks you do have in your particular database, you're going to run a show task just like we executed for show views and all, and then we will be like creating it. These are few parameters like create task. Then you need to give a warehouse name, a user task in manage initial warehouse size when you are going to schedule it. So let's look at it. So okay, now let's see that. So I am going to select this analytics, this one, YouTube learning database, and here I do have the raw layer. Now if I see that whether do I have any task or not, so I'm just going to run the show task. Okay, yeah, I can see that there is a first task for me, which is in this, and it is actually being used with the help of the Chrome tab. I don't know, like when I created it, okay, but let me just drop the star. Okay, so now I don't have any task. There are two ways to create it. Now, Snowflake recently made a good addition, or I'll say like it help you to create your task from the Snowsite UI itself. So if I come over here and then I'll come into the data to like particular database. So first I'm showing you with the help of the UI that how much control you do have right now. Earlier this option was not available. You'll come into that particular database where you wanted to create it. Then in this particular raw layer schema, and here you can click on the task. When you are going to click on create task, it will allow you to create this kind of a simple thing. Okay, now if I'm just going to write create task, my first task, and the warehouse, I'm going to give compute warehouse, and after that I'm just scheduling it. So this one I'm going to schedule after like 2 minutes. Either you write m or min, that's it. And after that you just need to write a SQL statement, and that you can use anything. So in task you cannot just run the SQL statement, but you can also run your stored procedures. Okay, or you have any scripting logic that you can just execute over here. So make sure that if whatever, let's say just copy into command or insert, or let's say some like getting a data, copying the data from here, that you can run. Okay, so in Snowflake we can execute a stored procedure. We can write some kind of a complicated procedures like generating reports or performing periodic table maintenance, or you can like even insert or copy into command. Now I'm just writing select one, let's say, that's it, and I created it. Oh, invalid schedule was specified. That's probably had been changed or what? Okay, it should be M, sorry. Now, if you will come into it, here you will be looking at all these things in the UI. There you have a task details. You can easily check basically whatever the details you have. You will be seeing using a show task. The state is suspended. The auto suspend failure, which is basically default, we did not set this parameters. The timeout parameter we did not set, and this is the task ID, and this is a task definitions. So based on that, you can just see that these suspend and timeout parameter, these are the defaults, and there are a few other defaults parameter we also have. Now, the account admin is the owner, and if you will come into the graph, you will find that this is just in suspended mode. However, if you want to edit that or control it, you will just simply click on three dots and click on edit. Now, in this, the task name is going to be the this first task. You cannot edit. You can only and only drop or replace the task to change the name. But there are the two ways. One is the user manage and serverless, as I mentioned earlier. So the serverless means here the Snowflake will be taking a control to assign the compute machine. But in the user manage, because I have mentioned the compute warehouse, and I can even change to like any of this, let's say the higher size, like if you wanted to scale. Suppose there is a complex stored procedure which may require larger sources, then I can just simply come over here and run it. So in the background, it is going to run a alter task commands because we are editing it. However, if you say that I'm not sure whether this large, medium, or extra large I should give, so you're just going to simply choose to the server list. That means the Snowflake will be managing all this compute machine depending on the kind of a complex load which he's going to handle. Now you see, as soon as I clicked on it, the option which I was getting earlier has been disabled. The reason, because Snowflake will be assigning the task. One more thing, in the user managed warehouse, I have already discussed that we can go from extra small to 6XL. However, in the in this compute serverless, we can only and only have the maximum size of 2XL. Now, the next, whether do you want to schedule it? Yes, I'm going to schedule it. And this is where you can use even a cron expression. So we have two options to schedule a task. One, after some minute interval, let's say like 2 minutes, 60 minutes, 180 minutes, or 100 minutes. But suppose if I wanted to schedule at a particular time or a particular day, then this thing cannot be achievable with the help of time interval. So I will be using a cron tab or cron expression. Now, if you are not familiar with the cron, then you can simply write cron tab guru, and there you can check how you are going to set the expression. So like this, it is at 4 or 5, but let's suppose I wanted to run at every day at 9:30 a.m. So here, this is going to be minutes. So you're going to write, and this is going to be 9. So at 9:30. Now, if you say no, it should be only and only run on the Monday. So at 9:30 on Monday. So like this, you're going to schedule it and the same thing, but here it is going to give you much flexibility that you can just simply say when you want it to run hourly, daily, weekly, monthly, or custom. If I go and click on custom, there you can choose and you can copy the expression which you're going to copy from here. Okay, but you say no, not custom. Let me just go to schedule it weekly on Monday at what time zone, and then if you're going to click on show SQL, you will see this is going to alter the task. So first, it is going to unset the warehouse to make it serverless. Second, it is going to schedule it using the cron. But this is how you can do it within the Snow site only. If you do not have much idea about this kind of a coding or you do not want the coding, then you can basically go from it. Now, if you want to trigger it manually, then for that, you can just simply check this option here and this, you can click on that. And this first task is scheduled to run immediately. Now, if you will come into the run history, then you can see this got triggered at 9:15 a.m. This 961 milliseconds. It took. The status we can see it's a succeeded. There you will be finding the other color like the red color also for like failures and all.
And this is just for one task. However, in your real-time project, you may have hundreds of tasks, and that way you can just simply go in the run history. But for that, you can use the information schema run history. Okay, so this was all like coming to the graph. If you have a parent child, let's suppose after this first task, you wanted to create another task to be executed, that flow will also be there. Means it's a completely going to create a DAG for you. There you can check, there you can find your task graph. Okay, suppose I wanted to run but like in simple word, in a one simple example, that I am planning that if my if I'm getting a good appraisal, then I'll go for a trip. So my trip ticket booking is actually dependent on that, on the previous task. That is basically I need to get a good appraisal. Okay, so in this we will be under like we call it as a task graph. So we have to understand the task dependencies. Okay, so a few things, let me just go and for before discussing the task graph, let me show you how we are going to create with the task and all over here. Okay, so in this I can simply then create task. I guess we have already created, or yeah, this create task, and the task name is going to be, I'm just going to use create or replace task, first task. And then I can use a warehouse keyword. I will be using a schedule keyword, this parameter, sorry. And then we have the other option, other parameter also, like allow overlapping execution uses. So this allow overlapping execution means if I have scheduled one task, let's suppose like after every 5 minutes, by default it's false. So that means if my that previous execution is taking more than 5 minutes, the next consecutive task will not run. But if you want to run it, then you have to set it as true. Then we have your user task timeout. So if you wanted to set a timeout, then you can particularly say 10 minute. If you remember that there on the UI, we were getting like a 10-minute. Okay. Suspend task after number of failures. Let's suppose that if it get failed 5 times, then there you do not wanted to run again and again and wanted to optimize your cost, then you can simply set this parameter. The next we have this error indication and success indication. In case of failure, you want to get notified over your email, because I or anyone is not going to regularly check the task history. For that, we will be setting up an error indication. And this, I hope you like have seen my part 17 where I have configured a snowpipe error indication that we can utilize here. The next we have that this user task minimum trigger interval in seconds, after, when, and these three like target completion interval, serverless task min state size, and serverless task max statement size. These are the parameters only for the serverless task. So this after is to create a dependency, to create a task graph. When is to create a kind of a trigger task. Let's suppose that if I am checking whether this stream has data. So I have created a stream on customer table. Now, if there is any DML changes captured to that stream, then only this task needs to be triggered. Then I'll be using when. But after is that first task will create, after second, after third, after fourth, like kind of a creating a task graph. And this target completion interval means if I am saying that my task should be only and only executed under 5 minutes, then the Snowflake serverless is going to assign that kind of a compute machine to that particular task to get it done the things within 5 minutes. The next is serverless task minimum statement size and serverless task max statement size. That means if I wanted to say that for this, even serverless is going to run, then the minimum it should have a medium or the maximum it should have large, then you can set the task size over here. So that's how you can do that. Now let's look at just to show you the complete flow. First, I'm going to create one table which is task test.
Okay, it's a very simple table I'm creating just to show you whether it is working or not. So for that, I'm going to run create or replace task test, and here I'm going to add ID and details. And second, I'm also creating a sequence. Okay, this sequence is like auto increment number, and that I'm creating sequence with one increment by one. Now, if I look at the data into the task set, there should not be any data because I just created. Now, I wanted to dynamically insert or basically insert the data at a regular interval period of time. It's just an insert statement I'm using. However, you can run a multiple copy into command. And in fact, when I will be showing you to implement the SCD, then you will be having a complete workflow understanding. Now the next is I'm going over here, insert into task test, and I'm inserting these value. So I'm using a sequence for next value, task inserted the record, and then if you will look at it, I can see this one task inserted. Now, so same thing, I'm gonna do it again, and then it will be having another value. Okay, now why this is 1 or 101 is coming, if you will look at the sequence documentation, you will understand it. But anyways, that's not the point to discuss over here. Now, I cannot do it manually again and again, so let me help you with that. So what I'm going to do is, I'm going to recreate these objects again and again. And now I will be creating a task. This task I'm going to create to schedule at 1 minute. So this is user minute server, like user minute task. I created a first task, schedule it, and in this as I'm giving this SQL statement. So this most of the time you will be using this one. Now, what is the maximum time you can set it for this schedule here? Okay, that is one question. So first thing, I created this task, first task. I do have this one. And here, if you will look at it, if you will scroll to the right, you will find that this task is still in suspended mode. That means it will not trigger. So for the very first time, when you create a task, you have to manually enable that or manually resume that. For that, you're gonna run a below command alter task first task resume. And now if you will look at the show task, if you will scroll to the right, your task is started. Let's understand these parameters also. When it got created, the task name, the ID, this is going to be a root or like a unique identifier, the database name, the schema name, the owner, and this compute warehouse, which machine is associated with it. This when it is got scheduled, that like it's scheduled at every 1 minute. The producers means whether it has any parent task associated with or not. So yes, this is only a parent task, so there is no other parent of its state is started. This is the definition, and this is basically a condition. If I wanted to write any condition or no error indication you wanted to give, you can set it over here. Allow overlapping execution is false. As I mentioned, that by default it is going to be false. Then the last suspended and task relations. So this we have a success indication. Target completion interval we have not given because it's not the serverless one. Okay, now if you will look at it, look at the data, whether this data got inserted or not, I can simply run select star from task test, and there I should see some records. And here you see this is one task inserted this record. How would you be like sure that whether this got executed or not? By just looking at the information schema task history. So this table is going to give you an idea about all the tasks getting executed in that particular Snowflake. Okay, now this task history is going to give you whether this task got completed or not. If but there is one problem here. The problem is here I can when I executed it, it is showing for most of the tasks. Although I can see this is first task, this select one, this is insert into task test value, this is succeeded, and this is scheduled. But what if you have hundreds of tasks and you wanted to check a particular task? So this will show entire history. However, to check particular task history, what we'll do, we're going to write, just going to take the same query, and in this we will be giving some parameters, not only just like particular task but at a particular interval, like the schedule, it should be suppose like from last one day only, then only, then also you can do this. So in this task I'm going to write first task, and let me run this. Now when I have given it, you can see that this is only and only going to show you the task history of it. This query ID is null, but these we have the query ID. Why? Because this first line is still showing in the scheduled phase. So that's why we don't have it. Now you can see the error code, error message, schedule time, start time, next schedule time, the completion time, root task ID, and everything you are going to run it. And you can even check it whether it was executed after scheduling or you manually executed it. Okay, so that's how you can get a complete information about your task history. And if in case you wanted to check it only for particular time duration, then you can give a scheduled time range start. That's it. And then excuse me, and then you can even run a time range end, the same. And that's how you can give it over here. Okay, now let's jump to the another thing. I was just checking that what is the maximum time interval we can set it over here. That let's look at it. I'm sure I would be having another task. No, no. Okay. So if I'm going to create another task, or I'm just going to going to take it. So first thing, I'm just going to do a suspend it because I do not want it to run multiple times and all. So second one. So let's say, can I do it like 500 minutes? It worked. Can I make it 1000 minutes? It worked. Can I make it 10,000 minutes? It worked. That means what? That what is the maximum minutes we can schedule? Like I can put it over here. That is 11,541. If I'm going to pick it, it will throw an error. Why? Because maximum we can do it 11,520 minutes, which is exactly going to be 8 days. So the maximum interval we can set in terms of minute is 11,520 minutes, but it is going to be a 8 days interval. So if I have to create any kind of a monthly or weekly or yearly, which we have seen into the Snow site UI, for that you will be using a cron expression. Okay, so let's just create another task with the help of cron, and in this you can simply use, and this is a serverless cron task. Okay, so what I'm going to do is I am going to create a replace task cron task. Then I am not passing any warehouse. The reason, because it will be a serverless and the cron. So I'm going to use this expression only, that I wanted to run at 9:30 on Monday. I'm going to use it, and here, wait a minute, sorry, I will be using this. And then this is the time zone, and after that I'm just using this cron task inserted, so then we can identify, yes, it was working fine. Now if you will look at it, that when it got scheduled, because there should not be any history, right? So if I'm going to write, gonna copy the task history from the only, And in place of first task, I'm using this cron task and going to trigger it. There is no task history for it. Why? Because it's not even scheduled. It's in a suspended mode. Okay. So for that, right now we should be having a three task. Now I'm going to run show task command. And then in this particular database, I have these three. The warehouse is null. That means it's a serverless. Schedule is using cron, but everything is a suspended mode. So if I wanted to make it with wanted to check it the history of it, then first I have to enable it. That you can use with the help of resume. Okay, now let's create a parent child task hierarchy. So what I'm gonna do is I have this task test table. Now I'm going to create a child task table. So I am creating another table called child. And in this one, if you will look at the syntax, if you will look at the syntax, then what I'm gonna do, this one, let me call it as a parent. Okay, and this is child. So this parent task, I'm running at every 1 minute and inserting into the same thing like a parent task inserted this record into the task test value. However, in the child, I'm inserting the child, but look at it. Okay, it should not be there. It should be like, it should be triggered after parent. I'm not setting any schedule. So if I run it and then look at this child task, after that, if you're gonna if you will be checking show task, then look at one thing. I'm just created on based on that. You will be seeing these are the child and the parent. If you'll scroll to the right, this schedule is 1 minute. For this, there is no schedule because it has a dependency, right? Next, if you'll scroll to the right in the predictions, you find this raw layer parent. That means this task is having this as a parent task. So it has a dependency on this parent task. Now, both are suspended. So just to check the complete workflow, what I'm going to do is I'm coming into this database. Let's see how this task graph look like or whether this task graph is there or not. Okay, I just need to check it. So I come into the task and here I'm going to refresh it. So let's look at the parent child. And if I come to the graph, you see this parent and the child. You can even create a multiple childs and one child can have two parents, like it should have a dependency on two tasks. That also you can do it. Okay, so that is how you like your workflow. So let me actually show you this task graph here. I guess it's a Okay, so task, it's a nothing, it's a kind of a DAG. It's going to be a series of tasks composed of root, child, and all. And the diagram it's going to be look like. So it's like going to be a parent task. So which is going to trigger three child task, and then this every sales tables is basically will be inserted only once these three are going to be executed. So it's going to be like a root task, child task, and this is how after that you are creating the sales table and sending the data. So in this, it would be clearly mentioned here somewhere. This example showing it, no. Yeah, you can see this task B and C to run simultaneously and task D run when both task B and C have completed their run. So D is going to be dependent on both B and C. Okay, and once B and C, like if it is going to take 2 minutes and it's going to take 10 minutes, then D will trigger after 10 minutes. And one more thing, a task graph can have maximum of 1000 tasks and single task can have maximum of 100 parents and 100 child tasks. Okay, so that's you can go through with it, but I just wanted to highlight these points. Okay, and you can have an n number of series, like you can have like 5 10s depending on the kind of a ETL workflow which you are designing here. Okay, let's go back to home now. I'll check this here. And let's see that one more thing, one important point. When we create a child and a parent task, the first thing which you need to mention is, this is a parent. If I am going to run this parent resume before the child task, it will work. But there is a problem. If you are going to now resume the child task, it will throw an error. So make sure before changing the state, oh, wait a minute, it's a child only. Yeah. Before changing the state of child task, your parent task should be in the suspended mode. I'm repeating it. Either you want to resume your child task or suspend your child task. It should be basically your parent task should be in this suspended mode. So to make it enable, first you have to suspend your parent task, then it is going to resume your child task. After that, you're going to resume your parent task. And now if you will look at the show task here, and if you will look at it, both are scrolled to the right. This is started and started. So we'll look at some data into the task test. So there should be like parent task inserted this record. That means it's still not get executed. So we'll wait for 1 minute and it should be triggered, and immediately we should see some data into the child task also. Okay, I guess it should have now something. Select star from task test. Yes, look at this parent task inserted this record. And if you will look at select star from child, there is a data over here. Okay, so that's how you can just check it and you can test it. You can work on your parent task, parent or child task hierarchy. All right. So I hope you have understood how you're going to do it. And now if you will come to the Snow site, your YouTube, in this your particular role here, and the task here, you can even check the task graph. So let's say it's going to be parent, and the graph, if you look at it, and sorry, the run history command also, it should be there. We can check it that yes, it is going to be executed over here. And if you will look at the task graph, so that's how it's going to be shown over here. You can change it from last 7 days to last 28 days for what you wanted to check it. You can refresh it if it is there or not. So that's how you can check it.
Hey, hi everyone. Welcome back to my YouTube channel. This is going to be part 35th of our Snowflake Zero to Hero series. In this video, we will be understanding one of the key concepts of data warehousing, slowly changing dimensions. And more specifically, how we are going to implement SCD Type 1 and Type 2 in Snowflake. We will be performing this exercise using task and the streams, which we have already covered in our previous videos. So before we jump directly onto the hands-on exercise, let's quickly understand what SCDs are and why they are so important into the data world. I'm sure you must be aware of the dimensions, facts, and all these data warehousing key topics. And some of you would be aware of the SCD Type 1, Type 2, Type 0, and Type 3 also. But just for a quick demo for this particular video, so that you will be having a clear understanding that why we are doing it and what are we going to do in this next couple of minutes. So in a data warehouse, dimensions are basically represent the descriptive attributes, which can be customer, product, employee, date, and etc. So these does not change like a transactional data. These are basically but they can be some dimensions which can change over the period of time, or which they can evolve slowly over the time. And that's where SCD comes into the picture. So these SCD help us to track the changes so analysts or business users can perform some historical analysis and understand the data trends over the period of time. So the big question is, how do you want to handle these changes in your data warehouse? You must be knowing about your data domain. You must be aware of your data. So do you want to keep the full historical record? Or you say, no, I do not want it to keep any change. This should be my fixed attribute or fixed time. This is not going to be changed over the period of time. Or you wanted to keep a historical, or like you just wanted to override the old value and no historical information. So we will be understanding what are the kind of attributes we do have and how does it matter in our data warehouse. So we will be declaring whether it is going to be type 0, type 1 and type 2 or so. We do have type 0, type 1, type 2, type 3, type 4, type 6 of the SCDs, but in this video, we will be majorly focusing on type 1 and type 2. This type 2 is most commonly used SCD types. So the first one is SCD type 0, which is fixed. That means no change. So the dimension attributes which never change, or if it is even going to change, we are not going to worry about that. Just kind of like, let's say this customer date of birth. Okay. Second is SCD type 1, which is override. That means we are not going to worry about what is my previous value, what is my historical data. All I care about the current record or the current value. That is the type 1. That means I'm going to simply override the previous value without any historical information. Then, what it can be, let's say the phone number or the email address, the customer email address. I do not want their previous one. I'm going to take care of this, recent phone number or recent email address for the better communication. And now what can be the type 2? The address. I want a complete historical information. So along with the current record, I also need to know what is the previous or what is the historical data associated with that particular customer. So in type 2, we're going to have one extra record, or we can say like whatever the new records are coming or the updated data is coming, if for every that particular information, we're going to have a separate records. And in SCD type 2, we also keep some extra column like start date, end date, or some can say effective date. Okay. And then the last will be the is active flag, or you can say the change flag. This is again totally depend on how you wanted to name those columns. So the start date or effective date is like from the which date that the record is inserted, and the end date by when this record will be valid, and is active will be true or false or 0 or 1, which is going to tell you whether it is a current record or a historical record. So let's see that in our Snowflake. So I'm coming here and understand I do have this employee sample data table. In this employee sample data table, I do have 97 records. So I do have this EMP ID, name, email, phone number, address, company name, and experience. And I will be updating this address. So here I'm going to only going to take care about the SCD type 2, which is address. Okay. So the first thing first, I have this CSV, or maybe I do have this table in my Snowflake. So how, like not Snowflake, basically in some RDBMS. So how will I ingest this data into the Snowflake? So we're going to break it into the multiple step. The first step will be that just assume that client is going to share the file in the S3 or in ADLS. So I have to load this raw file every day into my first layer, into the raw layer. The second, I will be creating a SCD type 1, which is going to have all the data, means that is going to append it and also going to overwrite if there is any change. It's kind of absurd. And in the next, we will be creating one table which is going to track all the changes made on the type 1 table and then will be updating into the type 2. We'll be inserting and will be adding another record. Also, it will be updating the is active and like all the end date and start date records. So for that, I have already written this entire script. So you will be creating a file format. This is what it's mandatory for it. Then we're going to have it a storage integration, and why this storage integration is required to make a handshake. So I have my this YouTube bucket, YouTube learning. Inside that YouTube learning bucket, I have created one source data, and there I have kept one CSV file. I'm sure you all must be aware of these steps and that what I'm doing in this step 1, step 2, and then you need to describe it. You will be taking this ARN and the external ID and we're going to update into the IAM trust relationship. Now, once you do that, then the next we're going to create an external stage. Okay, so by this is going to be, I guess we have already done it. So if you will look at into the show stages, I must be like a couple of stages. Okay, one I do have on Azure, one is on S3. So I'm going to utilize or I'm going to refer my second stage, EXTS3 stage. After that, if you want to know whether you were able to successfully make a connection or not, try to run this list command, which is going to showcase how many files you do have in this stage. If you're coming till this point, that means your proper handshake has been established. You made a connection with the AWS or Azure or GCS, whatever the cloud platform you're using. And now I will be creating a 3 tables. Thus, the first table will be the stage table, or I can say will be a raw data where the whatever data is coming from this the CSV directly from the Cloud Lake, I will be ingesting in it. I'm taking column like employee ID, name, email, phone number, address, company name, and experience. Then the next, I'm creating an employee, which is going to be type 1. Okay, to be if you wanted to make it more meaningful, maybe you can write employee type 1, something like that. And then the next, I do have this dim employee, which is going to hold my type 2 data and look at it. Along with these columns, I have 3 extra columns, which is start date, end date, and is active. So the start date, I mean, again, it depends. Like if your data is like something changed very frequently and you wanted to capture the time information also, then you can change the data type to date time. I'm going to utilize only the date part, not the date time. So if you will look at the start date and end date here, that this means the default I'm storing is 2/9/9/12/31. And then I'm taking this is active, which is a Boolean flag. So let me just create these tables. Okay. Now all three tables got created. After that, I wanted to make it automated. So my part, I'm not going to do with all these merges manually because I cannot assign one resource from my team to just load the data from S3 manually and then going to run these merge commands, going to take care, going to track the changes, and then going to maintain a type 2. No, this cannot be done. So I will be utilizing the task to do all this stuff. Right from loading the data from AWS S3 to stage. But one more thing. What if I'm going to get the same file name and I'm going to use one task, then I have to use either force equal to true command or I need to truncate my stage table. Otherwise, if there is a new data or like some updated data in the same file name, the Snowflake will skip those records. That is the property of copy into command. I'm sure you must be aware of it. If not, you can watch part number 13 or 14th, I guess, where I've explained copy into table. So after that, I'm going to create multiple tasks and that will be the task series. So it will be a complete task graph where the first task is just going to truncate the stage table. Then I'm going to schedule at 1 minute so that we can showcase in this video. However, you will be probably scheduling after 1 hour, 5 hours, 6 hours, or in just a one day. That totally depends how you wanted to utilize that. So I'm going to create my first task, which is clean stage table, that is going to be scheduled after every 1 minute. Going to use a compute warehouse, and this is just truncating the stage table. And why it is doing it? Because if I'm going to upload the same file name with the changes, then there won't be any error. Then there won't be any record will be skipped. Now, I will be creating a child task, and that should load it immediately after this. So when I said after this, that means I am going to create one child task, and which will be dependent on this clean stage table task dependency. So if it is successfully executed, then the next task where I will be copying my data into the stage table from this exts3 stage. And I have added, rather than schedule, I use this after clean stage table. That means if this task will only and only be loaded after this task. Okay, so the second task is also created. In the next task, what I'm gonna do is, so my data come into my stage table, but after the stage table, I want to insert the same data into my type 1 table, or we can say probably this is going to be my the final layer, a silver layer. Probably you can say that, okay, this is my employee table, which anyone who wanted to refer the type 1 data can use it. So in that case, what I'm going to do is, because that will be absurd. So for absurd, I will be using a merge command. And in that merge, I will be merging the data into my target table, which is going to be my type 1 table, employee type 1, and look at it. So this one is fine. What we are doing, this is load stage data. That means this is child task 2, which is depend on load stage data. So this is the father, this is son, this is the grandson. Okay, now we are doing a merge into employee. I'm sure you must be familiar of this merge command, where I'm writing into the target table, and there I'm using the stage table, select star from stage table. In fact, you can do like using stage employee only. You can remove that select part. I'm doing this aliasing so that you can join it and make sure you do have a key columns to combine it. There I'm combining it based on the name and the employee ID. Okay, but again, this cannot be true in all the cases. Here I'm assuming that this name and the employee ID will make a unique combination. Now, some of you may comment it or may ask that, hey, this in this slowly changing dimensions, this employee ID cannot work because we will be having multiple records. Yes, so we will be generating a surrogate key. Here I'm just like assuming that this employee ID and employee name combination is going to make my my record as a unique. So that's why I'm keeping it. Otherwise, you can generate some SHA key or using MDF5. Like you can generate a surrogate key. So now I'm saying if both the name and the employee ID is matching, and then if any of this information is not matching, email, phone number, or address, and that again is my assumption that I am gonna check all of these columns. However, you can take any of this. Either you can take address, or you can take email or phone number. Okay, but this is my type 1, so any of this phone number, email, or address is going to be changed. Then I am going to do update employee email, means target ka email will be source ka email, and phone number will be updated with the source table. That means it will be updated with the newer data, and no historical information will be there. And now, if these are not matching, that means the record is the new, so it is going to be insert into that employee table. Okay, so this is also my task 2, which is like SCD1 load has been created. Now, till this part, let's just take a look that if I'm going to load my file, okay, so before that, okay, all right, so let's look into the select star from stays employee. That do we have any record? Zero record, obviously. Select star from employee, that again had zero record. So why does it happen? We have created a task with 1 minute and then again this still not loaded. Why? You look into the show task, because whenever you create task by yourself at the first time, it is gonna be into the suspended mode. So you have to run a resume one. So first thing, you will be doing a child most resume. Otherwise, your task graph won't be updated. That also we have discussed into the task and the task tree videos. So you will be doing a child, then parent, and then grandparent. Okay. Now, if you will look at the show task, then except this one, because this I have created during the practice, during the dry run. So only this is suspended, but that is fine because this will be required for type 2. Just focus on the 1, 3, 4 line. Those had been started. Now, as a next step, whether these task has been successfully executed or not, how can we check it? We will be looking into the task history. And you cannot simply go into this query and task history because that may take some time as it refer the account uses. So you will be simply running this query select star from table information schema dot task history. When you're going to run it, you will be looking at it and this is going to show you the time, whether it got successfully executed or not. So these query ID into the null, that means this is still into the scheduled phase. And how can we check it? You just need to scroll to the right and look at the state as scheduled. So if you have this in the schedules, then this will be scheduled. Otherwise, it will be succeeded or the failed. So you will be getting a couple of status like state as failed, scheduled, or succeeded. Let's look at one more time because I believe 1 minute is over. And if I come here, this clean stage table, look at this one. Okay. So if you're going to look into this clean stage table, this is succeeded. Now, everything has been succeeded. So let me look into the data into the select star from stage employee. I can see there are 97 record, and into the select star from employee, which is type 1, there also I do have 97 record. That means it's successfully fine. So I do have all the data. But now let me create another task, okay? And that task, what it is going to do, but before that, actually, let me show you one more thing. What if I'm going to upload any information from here, or I'm going to like add new record, then how it is going to be affected? Okay, so we will be seeing it. Let me do one thing. Rather than this Noida, India, in front of this Vishal, I'm going to do Hyderabad. Okay, and this Megan Fox in place of Noida, let me do it. That's a Bangalore. All right, so I'm going to save it, and I'll come here. I'll upload it. I'm going to upload a new data. So that has been an employee sample data. And upload. Now we will wait. So we have seen it into my table that this Vishal should be Hyderabad and this Megan should be Bangalore. I haven't inserted one record, but that we will be looking into the type 2 maybe. Okay, I should have shown you that, okay, if I'm going to insert a new record, that should behave like upset also. But let's just wait for it. Select star from employee. I should have 97 record, but this Vishal in place of New Delhi, it should be Hyderabad, and Megan Fox in place of Noida, it should be Bangalore. However, you could have changed any of this like phone number or email. Why? Because if you will look into the merge query here, there we have checked it, set employee, phone number and address. So if any of these values is not matching, then you have run this update command. So that is going to be replaced the new value with the older, sorry, the older value will be updated by this new or the source value here. So let's wait for, I guess this 1 minute is over. Let me run this select star from employee, and you see here, this Vishal is now Hyderabad and Megan Fox is now Bangalore, which is completely fine. So till this point, it is fine. Now let me just suspend the main task. Why? Because I wanted to create a type 2. Till this point, I am fine that this is going to take my type 1. Now in the type 2, I have created 3 extra column, start date, end date, and ejected. So how this will be populated? For that, you will be creating a stream on top of your type 1 table. So what gonna happen? Just like the Vishal's address replaced from Noida or from Delhi to Hyderabad, the stream is going to have the record, stream is going to capture the changes, and based on that changes, it is gonna consume, and we gonna make some condition. If the stream has data and the condition is matched, or the condition is deleted, metadata action or update, then these action needs to be performed. Now this is my final task, which is dim employee load. But before that, you will be creating a stream on employee table. Okay, right now there should not be any record because we just created. After the creation of the stream, there is no change on this table, but in the background, when we will be updating this file one more time, then yes, there will be some changes. So focus on this part. We have created a final task, which is create or replace task, dim task load. It's going to be the warehouse. However, you can comment it. If you're going to comment it, this will be a serverless task. Okay. And then we have after this data, and in the task, you must be aware that we can add condition, like it's kind of a trigger based task, that if your stream has data, in which stream, the stream which you have created in the above step stremp. If this has data, then it is going to merge into your dim employee based on this str employee, means it is going to check the data from this address. It's going to check from this stremp, and it is going to check emp eid, check eid, and employee address. When matched, then this action delete, and when updated, this current date and is active equal to false. So look at it. If this is matching and the metadata action is delete, then this end date will be the current date, is active equal to false. And if it is not matching and action is insert, then it will be also inserting all the values. So let's look at this thing. What I'm going to do is I am going to showcase, I'm actually going to create all these tables one more time. So this stays table, we are fine because it will be automatically loaded. I'm going to create this employee table one time and this dim employee one time. Okay. Now I have this final task also ready. And here, what I'm going to do is I will be creating resume. So all my 4 tasks I am resuming. First from the child ka parent, parent ka parent, and final the grandparent. If you will look at select star from dim employee, there is no data. Right now, look at it. These are the three flags or 3 extra column which we do have in my SCD type 2, which I'm calling at dim employee. So look at into the select star from information task history. Earlier there was 3 task, but now we should have 4 tasks into my schedule status. Okay, we can see that this is the MPSCD1 load. Whether it is succeeded, yes, so they must be coming. Okay, we can wait it. We can check probably the show task. And all the tasks should be into the schedule phase. Yes, these are in the started phase. This is the condition, this is the definition. This predictions means that these are the parent tasks. The schedules, if you are seeing a schedule not showing any null, that means that is the most parent task. Here, this is how you can look into the data. Okay, now look into the select star, look into the select star from information schema task history. Let's look at it. This dim employee, this got null. However, all these three have been loaded. So that means it got filled. Look at it. This one, last SCD type 2 got filled because this base tip YouTube learning employee dropped and cannot read from stream str employee. That was expected. Okay, why? Because I have created a stream after it got created. So here I am gonna create this stream one more time and let's look at now. I have created a stream now. So actually after the stream, I have deleted that that table, or sorry, truncated that, recreated that table. That's why it got dropped. So let's look into this. So we should have the data. So that's how you can check it, what kind of error you are getting. Right now there is no record. Select start from information schema task history. This time we can see this dim employee that got failed, yes, and this one got succeeded. So merge into dim employee got succeeded. And now if I'm going to look into select start from dim employee, there is no data. Why? Because once it got loaded in this stream, there was no data. In this stream, there was no data. So what I can do, let me just to showcase it to you, what I'm gonna do is truncate table employee. I'm truncating this. Yes, it got truncated. Let me show you now. Okay, we can wait. Let's just wait for another couple of minutes till the time it's gonna insert. And in the meantime, I am going to add few more records to insert and to showcase some records. So what I'm gonna do is I'm going to insert one record here itself, and that we can probably call 1001 or 1011. The name I can keep it as like S400, or maybe like, let's say, anything, Modi at the rate mail.com. Phone number, we can say anything. Address is Gujarat, India. Company name is India. And experience is 22 years something. So this is one new record I have inserted. And this Vishal, this is not in Hyderabad now. He should be in, let's say, where? Maldives. Let's okay, but let's look at the data into my dim employee now. So if you will look into the dim employee, I do have the data right now, 97. All the, like, I'm not concerned about this data anymore. I just wanted to look into these three columns. So start date, end date, and is active. Because there is not, we did not make any changes in the record. That's why this is active is coming as true. Now, London, UK, this record has been updated, and this one should be Seattle, US. I'm updating the address also. So these two record, address got updated, which I have declared as a SCD type 2. That means I should have two more records. Right now, there is 99 record, or 98 record, or 99. Yeah.
Okay, yeah, 99 means 98 active records we do have here. So here, if I have updated this Megan and Vishal, so 2 entries should be for Megan, 2 should be Vishal, and 1 should be for Modi. So can we have it? Now, to do it, I'm going to upload this one more time, and we'll be checking it once my pipeline will successfully get executed. So I'm going to do the same thing again, add files, and I am going to upload it. Okay, so this is done. Sorry, there is some background noise. I'm sorry for that. Now I'll go over here. All the task is already into my active mode. So it's 1621. So let me just check the data into this stage employee. It is having 98 records. That means this Modi's entry is also there. Now, in my final table, in my dimension dim employee means SC type 2 table, I should have extra record. I can see these are 100 records. Just focus on these two things. Okay, this Modi got inserted. This one last is active, but if you will look at this Vishal Kaushal, this London UK was the latest address, and if you will look at on here, this one is true. However, this Vishal earlier it was in Hyderabad and is active equal to false. For us, the start date and end date is same because we just did everything today. However, you can make it maybe something like you can be specific about the time also. Probably this is very rarely case where you will be seeing the start date and end date is going to be same. So data wise, you may like again challenge me that okay, Vishal, this cannot be happen. I also agree that this cannot be happen. But all I was trying to show you that how you're gonna implement the type 2 using the stream and the task. So this got new record got inserted. These two record were updated, and you can see that it is having the updated information. So here this is London and Seattle should be the active record, and yes, these are the true means these are the active records, and these are the false, that means it is not is active record, these are the historical information. So that's how you can implement SCD type 2.
Snowflake is like a library, but this is not just a normal library. It's kind of a high tech or digital one. And you have rows of books, and inside that library, there are different sections. Like one is for your technical book, one is for your finance book, one is for your anything like a novel and other things. Each of these section has a valuable information, but librarian wants that not everyone can access every single of section. So in order to make sure that the right people get access to the right section, we need a system. And we do not want just anyone walking and grabbing any book they want. So we will be defining a rules so that the person who we want can only and only access that particular section. This is where access controls comes in. So in simple words, we are simply controlling the user, controlling the people, what they can see in our system. All right. Now, in a simple word, in order you wanted to protect your information, you have your mobile and you are going to lock your phone. But if your partner or if your parents want to, are going to unlock the phone and going to hand it over them. But a random person comes to you and asks you, so can you please unlock this? Obviously, you're not going to do that. Okay. So the Snowflake comes with a comprehensive collection of SQL command for user and security management. In this Snowflake, there are two approaches to establish the access control. One is the DAC, second is RBAC. This DAC means every object
the Snowflake will be having one owner, and that will be responsible for granting access to that object. The second, we have RBAC. That means the privileges to the access object is defined based on the Snowflake role, and then it assigned to the user by that particular system defined role or by that hierarchy. That means if I wanted to assign some permissions, some set of rule to a person A, or let's say to Megan Fox and Katrina Kaif, and then I cannot directly assign to the user. First, I have to create a role for them, and then those user needs to be associated with that role, and after that, I will be giving them a permission. That's how this RBAC works. What we are going to what we are going to basically hide it, like kind of the key elements to the access control. So the very first thing is secureable object. That means this is something which I wanted to hide, or a secure object which one to which permission can be granted or access will be refused unless a grant by the admin allow it. Second is the role. That means what kind of a role you have so that you can access that, or what kind of a privileges we are going to provide you to have the access or to see the data or not. Third is the privileges. The roles is basically a kind of an entity on which we are going to give the rules. But then we have a privileges. What kind of a privileges? Is it going to be a select? Is it going to manage that? Is it going to write that? Or what a different level of permissions, privileges we are going to give him. And the last comes to the user. That means Snowflake is going to we're going to basically, in simple word, a user is going to access that data, but that will comes through a role. So Snowflake recognize a user identity, whether it is affiliated with a person or a program. Okay, now we have some system defined roles. So everyone, if you gonna check it in your Snowflake, I'm not going on too much of theory section. So if let's suppose you come over here, and then you're gonna see you just need to come to the left hand side, and you will be seeing your different roles. Now you can see the account admin, org admin, public security admin, sys admin, and user admin. So except this DBT role, these all are the system defined roles. Now, probably when you will be working on after in a real-time project after a couple of months, you may see that this org admin is no longer available. They are working on a global org admin. That is some like a high level. I know I'm not sure whether how long this Snowflake is going to implement that. So we have this account admin. So the first thing, this org admin, which is basically it's kind of an organization administrator whose responsibility is more like creating the accounts. Okay, then we have an account admin. Let me come back to this one. Okay, so the org admin is basically an operation authorization at a much higher level. It's just going to create and review the accounts. Now, the major one which we have in an account, that is an account admin. So it basically, you can consider this is the kind of a VP or a president of an account who is going to have all the roles, all the power of the different roles which we have in the hierarchy of in the lower hierarchy of the account admin. Actually, let me show you. This is the diagram. So account admin is sit on the top, where it encapsulate all the permissions or all the privileges what we have as a sysadmin or security admin. So it is the top level role in the system and should be granted only and only to a particular people, like a very limited number of people in your account. Then we have a security admin and sysadmin. So the security admin, which is basically known as security administrator, that role can manage any object grant globally, as well as create, monitor, and manage user and role. This security admin encapsulate all the privileges from this user admin. So if you understand, the user admin is going to be responsible to create a user and role, and then
the security admin, because it sit on top of the user admin. That means security admin can also create the user and roles. And then we have account admin, which sit on top of security admin. So whatever user admin and security admin can do, this account admin would be able to do that. All right. Now, on top of this user admin, the security admin is there. So it can provide the grants, or it can basically manage the grant security privileges to be able to modify or grant it or revoke it. Just one second. Yeah. Okay. So in this, we have account admin that encapsulate all the system defined roles. Sysadmin and security admin is the highest level of object. Then we have a security admin, which is going to create, monitor, and manage user and role, as well as manage any object grant. Now, the manage grant security privileges given to this role allow to change or revoke any grant. All. Then we have this user admin. Let me actually show you. This user admin will be able to will be responsible for creating new user and role. However, there is a difference. This sysadmin is more like creating a database level object. It's going to have a privilege to create warehouse and database level objects. So if you create a role hierarchy that ultimately assign all custom roles, or we will be creating a custom role that is going to be going to report to the sysadmin. In a simple word, this role has an ability to grant privileges on warehouse, database, and other objects, but ultimately all your custom role will be having a hierarchy which is going to report to the sysadmin. I mean, this is recommended. It's not something that it's forcefully, but generally they say like this is how you should go and you should basically plan it. Then last one, we have a public, which is basically a pseudo role that automatically granted to every user and every role in your account. So if I'm going to create a new account, new user, so let me just come to here. Now we can see this. I'll come into this account section, and this is my account. And here we have a user and roles. How I'm going to create the users, how I'm going to create the roles, and how we will be giving them permissions. That everything we're going to look in this video. So right now we have a Megan Fox and Snowflake and Snow user. So this is by default, you're going to get it. Like how this is going to be when you are going to log into your Snowflake, you will be seeing it. Megan Fox is there, but let me just delete it. Actually, I don't want it to go with this. And I'm dropping it because I created using an account admin. This is what we can see as an owner. Now, I mentioned that the security admin will only and only be responsible for creating a warehouse and the database level object. Let me just see that. So I'm going to change my role to the sysadmin. Now, if I come to user and roles, you see I am not getting any option of the creating or plus any option I'm getting. Answer is no. But if I change it from sysadmin to, let's say I go to the user admin, and you see in the right top, I'm getting an option plus user, or I'm getting an option plus role. Okay. Now, the second thing, if I go to the sysadmin, would I be able to create any database or any warehouse? So let's try from the bigger one, plus warehouse, and I can see that yes, I do have an option to create this warehouse. Okay, so this warehouse XYZ is created. This owner is sysadmin. Now we say that account admin encapsulate all the it basically whatever the sysadmin and security admin is going to do. So that is going to be encapsulated to the account admin. So if I'm going to change this, and the role I'm going to use this account admin. As you can see this, I'm able to see this XYZ, and I can I just control it like suspend or edit it? Let's just drop it. Let me just see that whether I'm gonna drop it or not. Yes. But if account admin you're gonna do with the help of account admin, then we will be giving some permissions. So let's suppose that this is this analytics training we have, or like dev warehouse I do have for this. Now, if you will click on that, we are basically first checking on a UI basis only. If you will scroll down, you see this privileges. And here, only the account admin can access it. It's the ownership only, the account admin. If I change this to any other role, let's say if I come to the sysadmin role, would I be able to see it? No, warehouse not find. Let me just try. If I'm gonna change it to this security admin, then yes. But can I control it? Let me just try it. Select role. Let's say I'm gonna give it to DBT role, and I'm gonna give it to like just the users, and then it's a grant privileges. So the security admin, just I mentioned that security admin is that role which can manage any object grant globally as well as create, monitor, and manage users and roles. Okay, so we have seen that whatever I meant explained theoretically, we have seen on a high level overview. Now let me just create any user. So I'm gonna use security admin only. I'm gonna come to the user and roles, and then I'm gonna create a plus user, and let's say I'm gonna write with the Katrina, and this is Katrina at the rate gmail.com. Okay, now the password, I'm going to say cat at the rate 12345. Okay, it should be 14 character long. So let me just say Katrina Caf at the rate 12345. Now, I am getting one option which is force user to change password on the first time login. You might have seen multiple times that whenever you very first time login into any of the system, like if you join any new company and all, they give you a password and immediately they ask you to change that. So it's that one, force user to change password on first time login. I'm disabling it. I'm not like asking that they should do it or not. Now, next thing is, what are the kind of advanced option you wanted to give it to a user? That means, are you going to give any role at the time of creation only? Like what should be the default role? So let's say I'm going to give it a DBT role to this person, and the default warehouse should be what this DBT role should have an access or not. And that is going to be a dev warehouse. The login name, display name, I'm not going to touch it. However, it's totally up to you. The default namespace means that as soon as it login into this account, he should be able to see the database and schema. But again, I'm not going to touch it. I'm going to going to create this create user. Okay. And then what I'm going to do, I'm just going to log in into on this incognito window with the help of the same newly user created, and let me see whether I would be able to create it or like login or not. So what was the username? It's a Katrina, and you see the cloud service layer came into the picture. It validated the credentials and all, and then you can see this Katrina is DBT role. And if you're gonna check it, then this public and the DBT, only two roles she has. So this user has only two roles. One is the DBT role, which I give it a default, and second is a public, which is basically a pseudo role and which is automatically granted to every single user. Okay, now if I come to this data section and let me see, I can only and only see the shared databases. I cannot see the other users, like I cannot see anything other databases which we do have right now over here. In this data pane, I have around 10 plus databases which I cannot see it over here. Create a like pseudo role which is going to be kind of a click role, or probably like Power BI. So that person is going to create a report in Power BI or a click or in Tableau or any micro strategy in any reporting tool. So I'm going to create one new role, and all the person who will be joining that team, we will be simply assigning that role to those users, so that if I have to give a permission to the 5 different users, I can simply achieve it by just providing those permission to that one particular role. So let's just do that and see that how we're going to do it, how we're going to achieve it. So in this case, first I'm going to create a new role, and that role a plus role. So here it's going to be, let's say, this BI role.
Okay, and which is inherit any privileges granted to the new role. I'm going to give it to sysadmin, and then I'm going to create a role. Okay, now so we can see this granted role, granted to role user. This is something new, which basically you can clearly see that how many users has this particular role access. So I'm going to click on this BI role, and if you will scroll to the down, security admin is the owner, and the privileges the sysadmin has uses over here, and a BI role has been granted. So if you wanted to give an access of role A to role B, that's how you can do it. But here I'm more focused on providing it to a user. So in this, I'm going to give it to a Katrina. That is just a grant. Now you are doing it on this basically on a UI side, but in the background the Snowflake is actually running one grant command, and for that you can clearly see into the query history, and this is something you can clearly check it. This is grant role to user Katrina and all. Okay, so I'll come back to user and role. Here I have provided this. So if I come to this role, you can see that this user has one access. Now, if I go back to this one and I'm going to refresh it, I should see three roles for this Katrina user. One is DBT role, BI role, and this public. So if I select this BI role, but still nothing worked out. So what I'm going to do is I'll come into this data bin, and then here I need the access of this YouTube learning. Let's suppose that okay, this person she was trying to create a report on one table, and this table was nothing but this customer. So what I'm going to do is I'm just going to click on this customer, and I am going to give a privileges. What kind of a to which role I will be giving it to BI role, and what kind of a privileges I need to provide. Select, truncate, update, delete, or something. What? So I'm just going to give it a select privileges right now and click on this grant privileges. Now, when I do that, and if I'm going to refresh, I'm still not able to see that. Why? The reason because I just have given the permission of the table, not that particular schema and the database. So first that I'll come to the YouTube learning database. Inside that, I have a plus privileges, and that I'm going to give it to a BI role, and I do have a different level of permission. We are not going to talk about it. It's some in a simple word. Whether I wanted to give a future permission, I wanted to give this a create database role, create alert role, create file format on future schema, create a future schema, create new schema, anything, whatever the kind of a permission we wanted to give it, we can select it. I'm simply going to give a user's permission, which is in which whatever the object we have inside the database should be able to use it only. So if I'm going to refresh it, you see this, I can see this YouTube learning, but inside that, except the information schema, I'm not able to see any other object or any other tables or something. And then I'll come to the raw layer, which again it's going to be, but this time I'm not going to do with the help of this UI. So let me just do it with some kind of let me write some command. So what I'm going to do is I'm going to write grant select, not sorry, this grant uses on schema, and on which schema I wanted to give it, on YouTube learning dot raw layer, and to which role I wanted to give, to role, and then I need to mention the role name. So if I'm going to run this, it's basically we can see this BI role. Then if I come here, if I'm going to refresh, I can see this role here. But the problem is I'm not able to see other table except this customer and this customer. Why? Because we have given a access. So what if there are 100 plus objects? Would I be giving them a single like access? No. For that, what I'm gonna do is grant select on all tables. And you see the stand object affected. Now if I come here, and if you like gonna write, and you can see that
every single table is available. If you're going to click on the three dots, you want to try a drop. Let's just try that. Can we drop it or not? You see this, the role does not have the privileges to do this action. Okay, so that's how you can control. Now come to this admin side and let's see how many warehouses we have available. You can see this is a dev warehouse and all. And on this dev warehouse also, what kind of a permission we do have, that also we can decide by going under the warehouse section. So this is the dev warehouse. I'm going to click on that. And here we have given a DBT role, but only the user's permission. If you wanted to modify, then you can probably click on this modify permission that, okay, he would be able to change the size or something. So if I'm going to update the privileges, and if I come here and click on this edit, let's just make it to the small. Can we do it? Okay, wait a minute. Let me just refresh this. Probably it's gonna take some time, and then you can see this, we can have it like from small, from extra small to small, and I can even save the warehouse. So it's totally it completely in account admin or security admin hands. So in case you guys are already working with the Snowflake and you see that I cannot like select I can only see few objects, I cannot access this, I cannot access that, I cannot do this, then it's completely in hand because you are working as a custom role and you cannot even check in this cost management. You look at it. So here I'm coming over here and they're saying insufficient privileges, because this is completely controlled by like it's completely to this account admin role. So here I can see this cost management, but if I come here and if I'm going to click on this cost management, nothing will come in. No access to account overview. Switch to account admin or a role with access to users data. So you won't be able to say anything like a consumption, budget, resource. It's completely because this insufficient access and all. And you won't be able to create any user and role. You can, although you can see that how many users and roles are there, but you don't have a permission to do that. Okay, so that's how you can create it. Now we can see that, okay, we have just select like perform some grant command and all, grant users and all. What if I just wanted to check on a particular database who all can access that? So let's suppose that I wanted to see this YouTube learning, who all can access that. So for that, I will be running a show grants on database. Then you're going to mention this database name. And once you're going to do that, it is going to give you a list that which kind of a privileges we have, and then who all this county name is, account admin and BI role. It can just have a users and all. So if you wanted to give a particular, just one more time, and I'm just going to give it to a DBT role, and yeah, this one. And also I wanted to give a grant users on database YouTube learning to role, DBT role. This one. Now if you will run it, we will be seeing 3 entries. So that's how you can do. Now one more thing, you probably would be having one like question in your mind that, Vishal, what if I just wanted to give him a select, insert, and like even an update or a truncate access? Then should be able to write it like this? Answer is yes. Okay, so this is how you can perform. Now going back to this data pane, you will be having few other things which you need to focus in your mind. That what if I have this YouTube learning, and probably at this stage there are 10 tables only, but what if you're going to create 100 plus tables, and at every single time do I need to do this activity grant and all? Answer is no. For that, you can simply click on this privileges and you will be having a future permission. So BI role, and then you can see this one here. Like you can just give any permission like a create and all, monitor, and then here we can have a read read select future table and all. So this is something you're going to give a select future table. That means if I'm going to create any new table, that person should have then access. Let's just try that. So if I'm going to give it to BI role future table, then click on the grant privileges, and if I come here right now, how many object I see inside this? It should be 10. Okay, I have 10 tables. So what I'm going to do is very quickly, I'm going to create one table, and that I'm going to create in this YouTube learning raw layer. Okay, so create table ABC, and which is going to be IT8. I'm just creating a table. That's it. Okay, now let me just refresh it. I should see this 11 table, and then you can see this is an ABC. It's coming. Okay, so that's how you basically need to check it, what kind of a permission you wanted to give, and you can control through it.
In today's world, like it's a completely which is data generated, we know the security is the key, and protecting our sensitive data is something which is non-negotiable. In this video, we will be focusing on one of the most powerful security feature which Snowflake offer, that is a dynamic masking. It's a dynamic data masking. In this, you will be completely getting a clarity that how we're going to use the roles and create a masking policy to ensure your sensitive data is going to be remain protected or hidden from unauthorized user while providing the right level of access to the right people. So whether you are working with financial data, with PI personal information data, or anything else that needs protection, this feature is crucial for maintaining data privacy without interrupting your workflows. So let's get started and understand what dynamic data masking is and how we are going to implement in the Snowflake. So this Snowflake DDM is basically a data security feature which is going to allow you to alter a section of data, and that you can keep hide it, that you can keep undisclosed, like going to keep it like uh, anonymity using a predefined masking strategy. So in this, suppose I am a data owner and I am going to say this particular customer needs to have only and only certain level of access of my data. If I do have a customer table which is going to have phone number, address, and name, gender, everything, but I do not want that the phone number should be displayed to everyone. In a real world example, if you know that whenever you order from anything from Zomato, Amazon, or Flipkart, these days you got the call from 011 or 0124 or something, you directly do not get the call from the delivery boy. Why? Because they are going to hide your data, and whenever the delivery boy called up, you basically got a different number just to hide your just to provide additional level of security. Or in a second example, whenever you reach out to any credit card customer, like any credit card provider like HDFC, Amex, Standard Chartered, suppose you wanted to report a case or you wanted to inquire something. So when you are going to dial the customer care number, the CCP is going to answer something like, "Hey sir, thank you for calling Amex. Can you please help me with the last four digit of your credit card?" So why he asked only for last four digit? Because the admins and the person who is higher in the system, they have not exposed the entire credit card of the customer to these CCPs so that they cannot misuse it. So data owners can decide how much sensitive data to reveal to different data consumers or data requester using Snowflake dynamic masking functions. We are going to create this dynamic masking and going to apply to the any tables, any particular columns. You can create a number of masking policy. You can apply to like one column, two column, three columns. You can even do a tag based masking policies. In this video, I'm not going to cover tag-based masking policy. We will be creating the policies, maybe one or two masking policies we're going to create, and I'm going to show you that how you can use these masking policies to protect your data using a different rules. So just look at this image. I took it from the internet. So here, if you will look at the on the left hand side, this is a customer table. This is the unmasked data which admin can see it. So we have first name, last name, date of birth, SSN, country, city, and zip code. Now SSN, or we can consider a PAN card or Aadhaar card, which is going to be kind of a PII data, and we do not want that anyone should have an access of SSN number of my customer. So then we will be mask it.
So they should have the access of this table, but once they are querying it, they should see only the last two digit, last four digit of it. Just like you can see into the call center member, the role 4356 and rest is coming as mask. The first name is completely mask. So either you can do a partially mask or a complete mask. So let's implement that into the Snowflake. So come to the Snowflake. So what I'm going to do is I'm going to create one masking policy. But before that, let's understand on which data we are going to do it. So understand that this is I have one table which is customer, and in this I have some information like first name, last name, date of birth, the credit card number, the PAN card, and the city we have and the country. Now I know that the credit card and the PAN card is something a PIL information which CCP means customer care professional or the supplier, like probably I mean supplier by here by the shipping company who is going to ship your credit card from bank to your address. They should not know about these information. What if there is another third person and you wanted to say that if there is a guy A who is an admin, he would be able to see this entire data. But there is a guy B who is a CCP and he should see some mask data, mask something like that. He should see this. Or if there is another guy, see, when he is trying to get the data, then it can be something like it's a sensitive data. So there should you get some kind of a text, and this could be completely hide it. So we can say this is going to be unmasked data for A, for B it's partially masked, and for C is completely masked, which he cannot even imagine that what kind of a values will be there. Okay, so come to the Snowflake now. I'm going to create this masking policies. The masking policy name is going to be PI masking. I have to give one parameter here, like I'm going to pass one card. It's you can keep it any name, but make sure that you are using a correct data type. So if I'm writing a string, then it may make sure it is returning the string also, otherwise data conversion error you will be getting. So the syntax is pretty simple. Create a replace masking policy, PI masking as, and then you are going to do it. Now you are writing some based on some case conditions. We know these are the some system functions, the current role. So when you are going to run any query and all, the Snowflake current role function is going to identify that from which role you are trying to execute that statement. So it's going to check if it is an account admin, then it should see the complete information. But if this is a CCP, then you can use it. This should be the regex replace, and it can be replaced from first to 7 character with this hash. You can even use anything else. Okay. And the next is if the role is the supplier, then he should see only the dollar, dollar, dollar. But along with like apart from this account admin CCP and supplier, if there is any third or fourth person who is having a different role, then the data should like you can see me. So I'm gonna create it. This is for my PM asking cannot be reports. All right, so this I have already done it. So let's do a quickly unset this one. So what I'm gonna do is I'm just going to unset that. Okay. And okay, because I have already done that, so I'm going to repeat this step from very first starting. I'm going to create this PI masking policies which have been created. Second, I'm going to create another which is a PII, or we can say this is a PII2. Any name you can keep it, PII2, and I'm going to create it. In this also I'm doing the same thing. Although it's totally up to you, you can change it. You can use your SQL knowledge, you can use your string function knowledge, and then you can apply that. Now I do have these two policies, and then what I'm going to do is I'm going to create this table, which is my credit card customer, which is having ID, name, last name, credit card or something. Now you have two options. If your policy is already there and you wanted to apply any masking policy at the time of table creation, then you can use this syntax. So just after declaring the data type, you're going to mention masking policies and that policy name. So one policy I'm going to create at the runtime, Then, if you're going to describe your table, you will be seeing that there is a masking policy mentioned in front of the credit card column. So it is showing the complete database name, schema name, and the policy name. Now, what if the table is already there and then you have created a masking policy? So how would I apply if the table is already there? Then for that, I need to run this alter statement, alter table, if acted credit card, customer, modify column, credit card set masking policy, and that the policy name. So this for the credit card, it's already there. Now what I'm going to do is I'm going to set it for the PAN card number. Okay. Now, if you're going to describe this table one more time, you should see these two entries having a credit card and PAN card. So, okay. Now, for the account admin, because right now it's account admin. So if I'm going to select star from credit card customer, I should see the complete information. I should see the complete data. Oh, my bad. I have to insert some record. So what I can do, I can write this insert into command, and then we can run this. So after that, if you are going to use an account admin with this where condition, you can see this complete data. And even if you are not using this where condition and you are writing it, you will be seeing that it's is complete data. It's not masked, not even a partially masked data. But this is something which what we wanted. At least admin should have a complete access of this data, which is fine. Now, in a last video, if you remember, I told you how we can create a roles. Okay. So I was showing you if the role is CCP or supplier. For that, I have already created these roles. If you are new, how we're going to create the roles and all, then you can watch my part 26, means just the previous video. There I have explained it how to create user and roles. Okay, so the quickly you're going to click on plus role, you're going to give a role name, and then you will be giving granted to roles or granted to users something. So I have the CCP, I have one user, I have a supplier, I have assigned to one user. Now, once I have created these two roles, then the next thing is I will make sure that those two roles not only should have the access of this particular table, but they should also have the access of this database and the schema. Otherwise, if I'm going to switch to that role, they won't be able to they won't be able to see or use these objects. Okay, so these grant command and all, you can run it, but I am going to show you. So what I'm going to do is I'm going to give a users on this my particular database and schema, and then these some commands like select and set update on that particular table on all tables in this schema, and even a grant users on warehouse so that they can utilize it. I'm going to run these commands. Okay, so the CCP part is done. And then the next what I'm going to do is I'm even going to give it to the supplier. Okay, so if you need this script, please feel free to share, ping me. Otherwise, I'm just going to add it into the description box. So this is something what we're going to execute now. If you are going to change the role, if I'm coming and choosing the CCP, I should be able to see my database, which is fine. I am able to also see the warehouse, which is again fine. But now let's look at it. If I'm going to write select star from credit card customer, what I see. If you will look at it, this is a partially masked data, which is completely fine. This is what we have expected. If you will scroll up, there we have mentioned that this is going to replace first 7 character with the hash. Next, we have a PAN card, and this in the PAN also we have mentioned that this is going to replace with this 4 times A, which is fine. So it must be having only the 4 character. Otherwise, if you look at it, then it's like 5 character, and the first 4 character is replaced by the A. Now, if I check with the supplier role, then I should see the dollar in both the column. Let's see that whether it is going to be true or not. I'm going to switch to the supplier role. Now scroll down and we'll be writing the same command select star from credit card customer. And if you will look at it, then see it over here.
So if this there is a guy who is a supplier or kind of a, like it's a delivery boy who is trying to find out the credit card number of any customer, he won't be able to get it. Now there is a one question which is my favorite whenever I take interview I usually ask it. Suppose I'm coming to this account admin. Suppose I already know that there is a one credit card. Okay. Now, what if I have figured out or I got to know that there is a one credit card number is this. So if I search it based on the account admin, I'm getting one record, which is perfectly fine because I do have it. But what if I'm going to change it to the CCP role? Will I be getting any of this information? So even if you have a complete information like a complete value which you're going to add into the filter, then this dynamic masking policy is not going to allow you to look that data, which is something of very good in the Snowflake, and that even your data is going to be protected. Even if somehow they got to know any column information, but they wanted to know the entire information against that column, they cannot derive it. All right. So far we have seen how we're going to create it, how we're going to use the roles, how we're going to see this partially mask and the full mask data. Now, what if I'm going to use another role like on top of these CCPs other than these CCP and all? So let's say I'm going to use this sysadmin. And then if I just execute select star from credit card customer, look at it. What I'm getting, you cannot see me. And this is what I have defined in my masking policies. Okay, I hope so far it's clear. Okay, now the last thing is if there is a requirement to unset the masking policies, okay, because you are going to try to recreate it, then before recreating this masking policy you have to unset it. And to unset this masking policies you are going to write this command. Wait a minute. I guess I have reached to this multiple masking policies. So I have copied this script from somewhere. So what we can do to unset the masking policies, you are going to run this command. I'm going to copy it. Alter table. If I just modify column on first, you wanted to remove from this column, but why it is throwing an error? The reason, because we do not have the sufficient privilege by using the sysadmin role. So I will be switching to my account admin role and then gonna do it. Similarly, I will be removing from the credit card and then going to unset the masking policies. Now, there is a one here in this the dashboards. If I come here and come into the governance part, there, if you're gonna create any tag, then it will be shown up here. With most used policies for the column, you can see there is a one PIM masking policy that is being used. Most used tags for column. So there is another, like you will be implementing a tag based masking policy, which I will be covering into the next section, next sections and all. Then most used policies for a table. It's going to take time. It's going to take time to reflect it. Data was refreshed 5 years ago, and then we have recreated the tables and all. So you will be seeing that all those tables which is going to be used tags and the policies and which is the most used policies. So kind of a governance overview you will be getting over here. Tables with the row axing policies, table with like how many tags column we have, column with the masking policies, you're going to get it over here. All right. So we have seen either you can create one masking policies or you can create a multiple masking policies. You can assign it, then you can query it, you can set it, you can unset it. And similarly, you can do with the other roles also and for the other tables or other columns.
And in this video, we are diving into a super important topic, which is going to be micro-partitions and clustering in Snowflake. Whether you are troubleshooting performance issues or working with massive dataset, understanding how Snowflake organize data and retrieve data is something which is going to really level up your skills and confidence. So before understanding the micro partitions, we need to have a good understanding of data partitions. And I'm sure that you all are coming from an on-premises background and you might have worked with the Spark or maybe like SQL Server. So you would be quite familiar with the partitions. But let's just do a quick overview. Partitioning means breaking a large table into a smaller pieces, smaller and more manageable pieces based on some certain criteria, which we can do on the basis of like hash based partitioning on the date or maybe like a region or any some kind of a category. So those partitions can be queried independently, and which is going to help you to lead a faster and efficient data retrieval. But traditional databases use static partitions like hash based, range based, which comes with some limitations, or we can say some issues like manual maintenance, data skew, or uneven partition size. But in this Snowflake, it solves these problems using its automatic micro partitions, which give you the performance benefit of partitions without the headache of manual setups. So, what are these micro partitions in Snowflake? So far, you might have heard so many times, like a lot of people are talking about, that data gets stored into the storage layer, and then where we have this micro partitions. But how the data is actually getting stored or organized by the Snowflake, what is the size of it, what will be the file format of it, and how Snowflake does this query pruning, how the Snowflake is going to retrieve the data very fast, which we are going to understand by the end of this video. So micro partitions are basically between the 50 MB to 500 MB of uncompressed data, and all tables are automatically divided into this micro partition, which is contiguous unit of storage. Here, the data will be uncompressed. 50 to 500 MB is the data size, and these are immutable. That means once the data is once you have written the data over there, and when you try to update this data, it will create another partitions for you. This micropartitions file is basically stored as a FDN file, which known as the flocon de Nize. So if anyone is going to ask you that what would be the file format of this into the Snowflake, when we store this data into the Snowflake and it goes to the AWS S3, but in those AWS S3 is stored the .fdn file. These micropartitions are automatically created and help Snowflake scale efficiently. Either you have a big table, small table, ultimately data will get stored in these small chunks. So the group of rows are going to be mapped into individual micropartitions and organized into a columnar fashion. So Snowflake don't just store this data, it also keep the details metadata for each micropartitions. So if I'm going to store, let's suppose, a customer data, and this customer can have like a hundreds of partitions or millions of partitions depending on the size of the data. If you're having a terabyte of data, you will be seeing like, okay, 40,000, 50,000, 6 lakhs, 1 lakh, so those micro partitions. But how come the Snowflake get to know that which micro partition needs to be scanned and which is going to be pruned? Because the Snowflake cloud service layer, and in fact, don't just go to the cloud service layer, the Snowflake micro partitions have some metadata, and Snowflake keep this with himself. So whenever a user query it, it just goes and take the help of the metadata and then scan it to the required partitions, and after that it prune the unrequired, or it just do not look into it if the data is not there. So Snowflake store those micropartitions, those metadata of micropartitions that include the minimum and the maximum numbers, and it store like row counts, number of distinct values, and some optimization details. Okay, so why, like if you will come to this next slide, this is how you will see that how the data gets stored. So this on my left hand side, you see this type, name, country and date. This is a date table. If I'm going to store any data or going to execute copy into or insert into command, and when you write this in the query into UI, then this is how the data and the result will look like. Type, name, country and date. And we can see it, right? But how Snowflake is going to organize under the hood is going to be on the right hand side. It is going to create the micro partitions, as you can see here. I mean, because this is a very small data, just for the reference, and here it created 3 micro partitions. And these are the column based or columnar based. So you can see this is the type, name, country and date here. And this has stored from row 1 to 6, 7 to 12, 13 to 18. So if anyone wants to know how the data is going to be look like in the backend, although we cannot visualize, this is the reference image from the Snowflake documentation. Okay. Now, why micropartition is powerful? Now, for this smaller data, you may feel like that, okay, I don't need this to create any kind of impact, or I'm just querying it. I do have only 5 micro partitions, so I do not need any kind of a performance optimization. I don't need for clustering and all. But why exactly it matters? Suppose you're working on a terabytes of data and then you are querying something. Okay, just consider you have a big library. Out of that library, if the data is not organized in such a way where you want to retrieve your data, or you want it like the books are not organized in such a way how you wanted to pick those books, then you may get around, you may find your book maybe in 1 hour or 2 hours or up to 3 hours. But if the librarian has sorted the data based on the genre and the year and by the author, then you can easily go and then just will be going into one section. So rest of the section will be untouched, and you can get that book very easily and very quickly. So those micro partitions is powerful. Why? Because they allow faster query performance through this precise pruning. It's an efficient data management. There's no manual partitions required. It gives you horizontal scalability. It improves compressions. It improve compressions. So all those things, it's going to be provide you the benefits. And then this is how we basically understand, basically can say that this is why this micro partition is powerful. Okay, so first thing, the data is going to be look like that. You can see this, the type 2433232 something. This is going to be look like that, then the name and all those things. Now, when you are going to query this data and you are going to write type equal to 2, select star from this table, type equal to 2, then it is going to read the data from this and this micro partitions. Or even you go for a date where you see this 11 2, 11 2, 11 3, 11 4. And if I'm going to write select star from table where date equal to 11 2, then also it needs to read the all 3 micro partitions. Okay, but we will be understanding that how we are going to optimize it. And even when you are querying the data, suppose a customer is saying that till yesterday this query was working fine, but now I don't know why it is taking so much time. Even the Snowflake claims that we are super fast, and how, most of the time we say that the lot of optimization is done by the Snowflake itself, but do the user has something in their hand? Answer is yes. Okay, so first thing, like you understand, this data is going to be look like that. And the second side, which is going to have a metadata. So it is reorganize the data in each micro partitions to make it columnar, like column values and partition are stored together. You can see this type, name, country and date, and it's going to be compressed. And after that, they add header for each micro partition, which contain offset and length of each column stored within partitions. So this micro partition, we have header, which is going to have min, max, column offset. So all those micro partitions, if we have thousands, so those 1,000 micro partition will be their header, which we can call it as a metadata.
So these are, and after once this is done, then these micropartitions stored on S3 in the form of immutable file, while other statics and information about these micropartitions are stored at the cloud service layer. What does it mean? That those micropartitions are going to be stored into the storage layer, but the metadata, it's going to be into the cloud service layer. So when we fire a query, this cloud service layer going to know that, okay, based on this metadata, that which micro partition needs to be scanned so that we can get a better performance. Okay. This we have already understood, so I'm just going to skip that. Now, during the query processing, what will happen? It's going to be this node will first download the table file header from all those table files. Then, based on the metadata information in the header file, micro partition is scanned, and this allow the first level of partition pruning. If I do have 1000 record, and then based on the metadata we do have in the header file, those Snowflake is going to give the direction to the the cloud service layer is going to give the direction to the Snowflake engine that these micro partition needs to be scanned. Next, in the second step, if we are trying to get only the selected columns, so if I'm not writing select star, I'm just writing select column 1, column 3, column and all, then those into the next step, it read the micro partition header and read the desired column. This is basically the second level of column pruning. So if you write select name country, but we do have the type also. So first thing when you write mention the where date equal to 11/2, so it is going to be pruned this data because there is no date like 11/2. Second, it also pruned the type. So because the data is into the column format, and then you will be seeing that the type also had been pruned. So this is like a two ways of pruning, or you can say two level of pruning. But consider, because at the time of inserting the data, the Snowflake is automatically going to insert. Okay, Snowflake is automatically going to organize this data. And then after a certain period of time, you feel like that this data is getting the data retrieval is taking some time. So to understand that or to resolve it, we have a concept of clustering. So clustering is a technique which organize related data together within the micro partition based on one or more column which we provide in this at the time of setting up the clustering, and that improves the performance when your query filter doesn't match. So this improves the performance when your query filter doesn't match the way data was originally loaded. Now, again, I'm just going to get it. Snowflake, it support the idea of cluster key. Why? Because if you come back in this image and we see here, this data is 11.2 in this 3 micro partitions. So can we do that this 11.2 data comes into a 1 micro partition, or can be come into together maybe into 2 micro partitions, so that this micro partitions will not be required to scan at the time of query retrieval. Okay. So clustering is basically used to help to keep all frequently accessed data into the same micro partition for the fast data retrieval. Okay, now the more frequently a table is queried, the more benefit clustering provides. But if your table is frequently getting changed, then you will be finding clustering very expensive. Okay. And now, just in case, if you're having any doubt that when I need to consider that I should go for clustering or not, the very first thing I'll say that if your data size is very huge, if you have a terabyte of data, then yes, consider clustering on a table. Second, if your data is sorted into a different way, like if your query is basically, because when I mentioned this improved performance when your query filter doesn't match the way data was originally loaded, that means if the Snowflake is loading the data based on order ID or order key, but you are putting a filter select star from order where order date equal to this, in that scenario you should go for clustering, or you should consider clustering.
because here data would get it loaded through the order key. They sorted this data at the time of ingestion, but at the time of retrieval you are considering a filter which is order date. All right. Then Snowflake provide basically powerful tools like to evaluate how well your clustering is working. Not, I won't be saying it's a powerful tool. Basically, it going to like when you are just going to get some system clustering information, there is a function which is going to give you an idea whether this column is going to give you the best benefit or not at the time of clustering. So let's just see that into the action now. I'll come over here in this. And so you might be having a couple of queries that, okay, can I check it? How many micro partitions we do have? So what I'm going to do is I'm just going to do it some queries. So first thing, I'm going to create one transient table, which is customer non-cluster. And this is I'm creating from the Snowflake sample data, TPCHS SF1, SF10 custom, SF1000 customer, which you can see that this data is already there in your sample data. And you can take this idea and then you can just create a clustering table over here. So now we can see that this I have created this table of this customer. This is having around 910 GB of size. Okay. Now, if I'm going to write anything, so let's say I'm just going to write select star from customer non-cluster, and I'm going to write limit 100. And I'm just looking for anything, let's say any kind of a customer, or maybe you would type it when select star from this thing. Okay, so I'm gonna write select start from next customer where c4 equal to, and look at it. When I executed this query, it took around 960 milliseconds. And if you will open this query ID, this is going to take you to the query profile where you will be seeing the total number of partitions, the total number of like bytes scanned and all. You can see there are total 419 records, and it is coming from the cache. Why? Because you have just taken this select star from limit 10 and then you took it only from there itself. So that's why it came a bit early and like a bit faster. And maybe we can just go for any other things, or you can just restart your warehouse and then you will be finding it that it's just going to take some time. But the point is, like, if you wanted to know it, like how many total partitions we do have for that particular table, you can just simply get this idea from there. Now to read this data for it, you can see this the partition scanned also is 419. Its stable scan is 96.4%. That means if you would be dealing with a terabyte of data, which would be having kind of millions of micro partitions, and you were basically creating one reports, then you will definitely going to see that some kind of a performance degradation options like performance issues, and then you will come up with that should we create a clustering now, maybe that clustering can help us. Okay, so this clustering here, it's required when you have a terabyte of data and you are thinking that, okay, this I'm gonna create some tables, or you're gonna consider those columns which you are using in a frequently filtering that data, and you are more frequently querying this table. Because when we apply this clustering, it's going to reshuffle the micro, like not going to reshuffle the partitions. Basically it's going to reshuffle the data, but we'll be creating a new micro partitions. Why? Because we say, like, because the Snowflake mentioned clearly these micro partitions are immutable. So in general, if a column has a higher cardinality, then maintaining the cluster on that column is going to be very, very expensive. And again, if it is having a high cardinality, then this is also not going to add a very good performance impact. So one thing you have to keep in your mind when you are going to create a clustering on that table, then it should impact a very good performance, like by just changing, by creating a clustering and you are only getting like 1-2 seconds or up to 5 seconds depending on the data size, then you should not go for it, because you should consider that clustering cost also. So all table will be having a natural clustering based on an ingestion order. Until this point, when I'm going to create it, and if you are going to look at this show tables,
Right now I would be having only one customer on cluster. There, this cluster by is 0, like it means nothing. So we do have a natural clustering based on the ingestion order, and that is defined by the Snowflake already. So but the natural clustering can be overridden by designating a clustering key. That means if I wanted to override and I'm not liking it, that this can be my clustering, or I'm just trying to get the data based on some other column, you can use that to declare this as a clustering key. Now, next clustering keys can be columns or expression, which you can use like probably like 1, 2, 3 column, which again Snowflake recommended. However, try to use only and only those columns which you are using for your filtrations, and maybe like in your reports you are using that. But how we are going to create this clustering? It's just going to be very simple. When you are going to write a create table, there you can just simply add this options as cluster by. You can even use a functions like toDate or substring. And if you do not want it to add a cluster at the time of creation, then you can even alter a table like alter table T1 and the cluster by, something like that. You can do that. So let's just do that here. Now there is one more thing. What if I just wanted to understand that if I'm going to apply a clustering on this column, whether it is going to create any difference or not? And also, when we have this system clustering information, it gives you a kind of a clustering information, like it help you to monitor clustering effectiveness. It will give you the clustering depth. So for this, what I'm going to do is I'm just going to check it that on this table, if I apply a market segment, then what will be the impact on this? When you do that, it is going to give you a JSON string, or basically a JSON type of data. And here you will look at it. This cluster by is this key. So the very first column in this system clustering information, you will be having a cluster by key. That means this is the column being used for clustering. Okay. Then we do have a total micro partition count. It's gonna tell you that, okay, how many number of partitions you will be having it. This column, it's gonna tell you, sorry, this total number of micro partitions you will be getting from this line of this information. The next is the total constant micropartition count. This is basically number of micropartitions where value has been stabilized, and this is basically great for pruning. Next, we have this average overlaps, and that means average number of overlapping partitions, high value, which if you will be having a high value for this average overlapping, that means the table is not well clustered. It is poor clustered. I can see that the average overlap is 418, which means yes, there is a scope of changing. There is a scope of making it a well cluster. Next we have is average depth. So it indicates how deep the overlapping goes. The lower the depth, the better the performance. Next we have a partition depth histogram. It's going to give a visual distribution of overlapping depth across the micro partitions based on that, or which is going to help you to assess clustering health. So these are the metrics we get it. Based on it, you are going to decide whether you should go for this particular column or not. So if you'll scroll down a little bit more, then you can see that these many are the clustering, basically the depth, the partition depth we do have over here. Now, if you go for this market segment and all these, like the another column, then let's see. Now look at it. When we use this customer key, because this is having a high cardinality, the high cardinality means this most unique numbers, and it give you a notes. This is a warning. This is a suggestion by the Snowflake that clustering key column contain a high cardinality, which might result in inexpensive reclustering. So you should not consider this customer key. It's not going to give you a good benefit. And rest, you do have everything like that. Okay. So if I'm going to query this table and all, this is going to take some time. So let's just create one cluster table. For that, you are going to write create table and all. And then here, this cluster by the market segment. it by the market segment. And next, if you will look at it, wait a minute. There you see this cluster by its linear C market segment. That means we are using this column for making it like for this clustering and all. Okay, I'm inserting this data, the same data, into this public customer cluster, but this can take some time. Oh, wait a minute, sorry, this should be Snowflake. Okay, the Snowflake sample DB. Okay. The data has been inserted. Okay, so now I have used this market segment. So again, if I have to repeat one point, that strategy for selecting clustering key, so we need to consider that column are most actively used in selective filters, means the where clause. Okay, that this is going to be one, and we need to keep one point in mind, that if it is having a high cardinality, then we should not include that for clustering. And one thing, if your primarily goal is to reduce the cost, then each cluster table should have a high ratio of queries to DML operations. This means that the table is queried frequently and updated infrequently. That is where we have already made this point clear, that if here this more frequently a table is queried, the more benefit clustering provides. Okay, so after clustering the data, now the data will be located into the same micro partition. So I did a market segment, but if we take the example of our previous example, like previous micro partitions, that earlier this data was into this 11 to 11 to 11 3. Now you can see this is in the third three micro partitions. 11 to 11 2, and this is over here. So ideal scenario is 11 2 should be in the second micro partition, hence reading the third partition would be eliminated or it can be pruned. So if I am going to keep this data, if I'm going to write alter table, this is table name and then cluster by date, then this 11 2 of data will be grouped together and will be stored into the same micro partitions. This can be result in this way. So this is going to be first partition, this is going to be second partition, and this will be the third partitions. This is the third partitions, and when you are going to write a query, select star from table where date equal to 11 2, then this will be pruned and this won't be like scanned by the Snowflake. Okay, so let's just see that now. If I'm going to look into this data, now this will be having system clustering information. Now, if I wanted to check it, this may take some time. So do not just assume that if I'm going to, like if I have executed this clustering and it's gonna immediately gonna help me with that, basically with this, what should I say? Like with the performance benefit, you have to wait depending on the number of the micro partitions you have. The number of the column you have, the number of the data is higher, then I think you should wait for it to get this complete information or to get it done into the background, because clustering does not affect immediately. It runs in the background and then you can take some time to understand that. Okay, so this is one thing. Now, if you're going to query it, this may take some time and all. Okay, based on it, we can just take some idea on this one. And my table is customer clustered. So right now it's nothing over here, but it may take some time to come over here, and then it is going to tell you how much credit used, how much number of byte reclustered, and the number of rows reclustered. Okay, now we do have one table which is customer non-cluster. So if I'm going to write customer non-cluster, because even this clustering doesn't happen or it's again still going, so we may need to wait for some time to get this best result, but let's just do that here.
We are trying to get this data from customer node cluster where market segment equal to machinery, and I'm using next a small warehouse. This may take a lot of time. So we can see this is the byte scanned is 2.6 GB, which is 38%. So it's almost going to be scanned 7 GB data. Okay, we can wait. Okay, so it took 30 million data into 32 seconds. And here, if I scroll down, then there were 490 micropartitions, and those 490 got scanned. Although the data is coming from some cache, 98.5%, so that may take this data a little bit faster. It's coming from the remote warehouse cache, but anyways, like look at the 6.71 GB. Now, if I try to do it, if I try with this cluster one, whether there is some information or not, okay, it may take some time, but let me check this data onto this customer cluster where market segment equal to machinery. This is a different table. Okay, it take 31 seconds, but because this is not happen, or I'll say like it's not first thing, we did not even query it. So there will be like okay, there are total 420 micro partitions. It's gonna be done in the background. We can just wait for some more time. So now if I run it, because this, as I mentioned, this is going to take some time. And if you will look at it, it got started at this and get end time here. This much, this much of the credit used by the Snowflake to perform this clustering. These are the number of bytes which got reclustered and the number of the rows clustered. Now, if I do it, because this is going to customer, let's say I'm going to take it from a different market segment. Maybe what I can do is, okay, just 1 second to find out. Maybe if I take it for any other market segment. In place of machinery, I'm going to use furniture. Why? Because otherwise, if I'm going to run it, this is going to get the data from the query result cache, and which you may feel like, which is not going to give us any kind of a query profiling. It will be just the query result reuse. So when I execute this select star from customer with market segment equal to furniture, let's see that how much time it's going to take it to retrieve that entire data. Okay, so earlier it was taking 31 seconds to give me this complete information, and we do have this over here that total byte scanned is 6.71 GB, but now let's see that how much it's gonna take it. So it took 27 seconds, and if I open this query ID, here, this byte scanned is 1.54 GB, which earlier it was 6.71 GB. Byte return to result is 1.70 GB, but which is almost same because this is the data we got it. And here, percentage scan from the cache is 1%, and earlier it was 100%. So even if I'm going to do it without using that cache, then this won't be taking 30 seconds. This may take 35 seconds also. And look at this partition scan. Now we have only 98 micro partitions got scanned, and rest all got pruned, which earlier it was 421. So when we have when this clustering actually happened in the background, then it created 482 micro partitions. Earlier, it was coming 419, 421, but once this clustering happened completed, clustering got completed, then it's gonna be, it created that. So now if you will look at for any others and you find it that yes, the performance has been impacted, well, that changed it. Although this was not having a terabyte of data. So again, I won't be seeing it that, okay, you may be thinking like, okay, 3 to 5 seconds is not something that we wanted, but there will be other performance factor, which I will be keeping, which I will be discussing in the next video. But yes, if this would have been a terabyte of data, then you would be observing this difference. Okay. Now, I was talking about one thing, which is a clustering depth. So you just need to understand what is the clustering depth. I mean, if I just go here and when I write the system clustering information, right now it's coming 400 and 418, 19. But if I go and use this clustering information for this table, customer clustered, okay, and or I can just simply do it this only. I guess I don't need the system clustering information, customer clustered. So if I go over here and now look at it, total micro partitions count 482, total constant is 470, but look at the average overlap 0.0747 and average depth is 10539. So this is where you will be checking it, that this is the average depth and the average clustering depth. So, okay, clustering depth is basically a table metadata which keep track of how similar data are stored in multiple single micro partitions. If data is stored into multiple partitions, then I mean, okay, so forget. So basically, like lesser the clustering depth, better the table is clustered. And a table which is having a zero, which is having no micro partitions, that will be having a cluster depth of 0. Okay, so it is, if it is close to 1, that means it is best. So but if it is like 400, 300, 500 something, that means your table is not well clustered. Let's go for this reclustering. This is basically HTML operations like insert, update, and these are performed on a cluster table. Then the data in this table might become less clustered, and then you need to do a periodic or regular reclustering of the table is needed on that to perform the optimal clustering. So during reclustering, Snowflake reorganized that column data so that all the related records are related into the same micro partitions. And in this, Snowflake reclustering is automatic. No maintenance is needed. So if you are going to look at this data, now this is how your logical structure is how you will be looking at into the Snowflake UI. When you inserted this data and when you write a query, select star from table, this blue is going to be look like into UI. Then this is the original micro partitions where we have put this data into it, the based like automatically got started with. So to start, table T1 is naturally clustered by date across micro partition 1 to 4. And when you write it, date and type are defined as a clustering key. So we executed alter table T1 cluster by date and type. So then this new micro partition 5 to 8 are created because these are going to be immutable. So it's going to be created another one. And then this is how this data is going to be clustered. After reclustering, the same query will only and only scan the required partitions, means 1 or 2. It's the same example which we have already discussed here. Here it is going to take 3 out of 3, but after clustering, it's going to take 2. And same here, it is going to take 4 if you're going to read 11. 2, or maybe like it's going to take 1, 2, and 3 for 11, 2. But if you're going to read 11 to here, it's going to take only those 2 micro partitions. All right. So the last before I close this video, because I know this is gonna be like a little bit long, but it's very important. So I'm just keeping this point again. So Snowflake clustering is doesn't make any sense that you apply a clustering on every single table without checking it whether it's a terabyte of data or it's just a gigabyte of data, because you just read it that clustering provide a better benefit, so you applied it. That doesn't make any sense. Clustering happens in the background and it charge for the sorting. So balance the cost of clustering against the benefit of partition elimination. So which is again, you have to keep this thing in your mind. If you don't have a query performance issue or the clustering is not helping, then don't use it. There is no point of clustering a small table. So ideally go for not even 100 gigs. Snowflake recommend terabytes of data, but yes, you can consider more than 200, 300 gigs of data. And then again, it's going to be your decision, and you are actually finding it that yes, it is improving the performance, then only go for it. But which is very important is that you need to choose your key wisely. So clustering, when you are going to provide a clustering key, that should be your best key, that is something which going to be appear frequently in your where clause, and this will have the greatest impact on the partition elimination and the query performance improvement. Okay, you can even use a composite key, means if I wanted to go for a order id and order date, if I wanted go for a order date or reason, so that we can create a composite key also here. So that's it for today. I mean, I hope you got a good idea about it, that what is micropartition and clustering, how the data gets stored, what is the size of the micropartitions, whether it is a compressed or uncompressed, what would be the extension, means the file format that gets stored into the cloud data lake, what will be, whether it is a mutable or immutable, what exactly happened when we create any kind of a new microparty, any kind of a new cluster, when we create a reclustering, when we override the clustering, this natural clustering, what will happen. And yep, and what is the biggest advantage of this? I hope you remember, because when we were discussing about the architecture, the time travel and the zero copy clone is one of the main advantages of having this micropartition immutable. Let's suppose that you are extracting data from API and loading into the Snowflake row layer, or suppose client is sharing some files in Parquet, JSON or XML format, and you have copied into the Snowflake raw schema or probably in some staging tables. Now, if you need to share that data, or the BI team like Click Guy or the Power BI guys, they need to use that data to showcase in a reporting, or like they want to use it for their dashboards, they will be definitely going to struggle to convert the data or derive the KPIs from this JSON string, from the JSON key values pair, or from the semi-structured data. So how we are going to convert this data, convert this data into a more readable format, like we read as a CSV data or a text data. So in today's video, we are going to see how we can flatten this JSON XML data and make it use in reporting, or basically anyone can derive any information just like we can derive it from the structured data. So let's get started. I'm going into my Snowflake, and here I'm going to load this. I'm going to create my semi-structure schema. In that, first I'm going to create this table, which is JSON table, and we have already seen it that if you need to load any semi-structured data, we're going to take a data type as a variant. Now in the next, I'm going to load this data by the help of the UI only. So I do have the JSON table, and you're going to click on three dots, load data. I'm sure you have already completed these exercises. If you scroll down, I do have this JSON data file, and I'm going to open this. Now I'm loading this. Okay, so I'm just going to select the file format, which is JSON. And here I'm going to load it. I haven't created explicitly any file format. I'm going to use a default file format, and I'm going to click on load. So once this is completed, we can query it. Now I can query this select star from JSON table, and I can see there is some data. This data has some duplicates. I just created a random data. I downloaded from the internet, so you guys can see it. Okay, you guys can basically take your refer any of the sample JSON data. Now, if I have to use this, probably let's suppose I need this email address, first name, last name, and all. And if the Power BI is saying that, hey, I need to know the information where name equal to grid. So can we apply this filter or something? Answer is no.
So in that case, first we have to flatten this data. So if you are dealing with semi-structured data, we need to know one table function provided by the Snowflake, which is flatten. Okay, so flatten is a table function that takes as a variant object or array column and produce a literal view, which is more likely a relational representations or more likely a structural representations. It's gonna take one main parameter, which is input. You're gonna pass it that this is my input path, and then it is going to produce 6 columns. Let's see that. So in this, I'm going to take select start from JSON tables, and then we're going to flatten this data, which is input. This is parameter. And why we are giving this data? Because this is the column and the users, which is holding this information, which is basically a path. Now, if I'm going to run it, and you might have seen this is a literal. So literal also, it's kind of a literal join. So it's keyword, which is going to allow an inline view to reference column from a table expressions. So it's more behave like a correlated subqueries and going to produce the output in as if the server executed a loop similar, like kind of a similar loop or something. Okay, so let's just see that if I'm going to execute it. Select star from JSON tables. You can see this star I have used. So this is coming from this table itself, the data. This is the column. It's coming from JSON table. Then it gives me 6 columns. The sequence, key, path, index, value, and the last one would be this. So the sequence is going to be the kind of a unique sequence number which is associated with the input record. It's going to be 111, then 222, and 333, like based on the records we do have. The key for like this column contain the key to this exploded values. If there are any key that the values, because the JSON or XML they store into the key value pair, so you can see that over here, but it's coming null, so we don't have anything. Now it provided next is the path to the element within a data structure that needs to be flattened. So it is going to be 0 1 2 3 4 for every single record. There we see the 3 records, so this is why it is coming 0 1 2 3 4 0 1 2 3 4 like that. Then the next we have is the this index. So it's going to tell you the index of the element. Then we have the value, what all values we are going to get in that first index or that particular path. And after that, that means the element being flattened. Okay, this is the value of the element of the flattened array, and this the element being flattened. Okay, now we need to focus on this part, this value part. And whenever you are going to extract any data from a JSON or from any semi-structured informations, you just need to focus on this part. You can see this email address is going to be my column, and this is going to be value, the first name, last name, phone number, and user ID. So from this, I can get some idea that I do have around 4-5 columns. So I should rewrite my query in such a way to extract the data for simple column. I have already written this query, so I'm going to use that one only. I'm not going to use this. Okay, let's just remove this index only. I'm first going to take this value because this is coming from value. Now, this is first name. This is last name. This is phone number. This is user ID and the email address. Okay, so let me just take that user ID in the first. Okay, and then I'll just go one by one. Actually, let me just go one by one so that you will be able to understand what I'm doing in every single step. If I'm going to run this, you will be seeing that there are 5 columns. 1 2 3 4 5, which is fine. The first name is coming, last name is coming, phone number is coming, email address is coming. So first thing I can see that the user ID is coming null. But in my last query, when I executed in the value, I was seeing some values into the user ID. That means I'm doing something wrong, or this query is not able to locate this user ID in this value. So if you will like focus on one thing, I purposefully did that. User ID here, it start with the U small and only I is capital. However, I made a change in this and I took this. I was using a capital U. So first thing, whenever you are extracting the values from these, then make sure you are using the same column name. It's a case sensitive. Next thing we have seen it that the case, leaves and every values are being like it's wrapped into the double quotes. The reason because these are still into the variant columns. If you will hover on any of these columns and going into this profile section, basically in this section, and here you will be finding this variant. So first, we need to focus on changing the data type. Second, you can see it's coming value first name, value last name, which is not a meaningful name. So if you're going to create a view on top of it, make sure you are going to re-aliasing that. So to typecast that, I can use this double quotes. I'm sure most of you have already used it. I can simply write string of or this one, and then I'm going to alias that as user ID. This one I'm going to alias as first name. Now if I'm going to run it, you will see that for first two columns, it is giving me perfectly fine. For last three columns, we still needs to run this process. So I can quickly do that. And we can see now I'm getting every single information in it. So we were having this data, this users, user ID and all, and then we convert it into a structured format. Now you can create a table into a silver layer or into a semantic layer if everything looks good. Otherwise, you can apply some transformation. You can join it with whatever you wanted to join. If you have multiple JSONs coming from the client, you can combine this data, you can join this data, you can perform analytics, and then you can use it for your reporting and all. Okay. Now, second, what if we are going to get some XML files? So let's do that also. So in this one, I'm going to take some XML file. Actually, I'm supposed to use some Parquet file also, but I did not get any Parquet file something. So I'm skipping that. However, I'm going to create a separate video on loading and unloading the Parquet file. So I'm going to I'm going to repeat the same process for the XML table, but here I'm going to take two types of XML file. One is the normal file and second is the nested, means the hierarchical data it has. So for that, I can create a file format. In last XML format, I haven't created because I was using the default format, which is provided by the Snowflake only. Now, as the next thing, I'm just going to refresh and I do have this XML table. Right, I'm going to load this data. I'm going to repeat the same process, loading the data from the UI, selecting this XML file, going to open, then next, and we'll be choosing my XML file format. Either I can use XML or I can use this whichever I have created. When I click on load, my file is loaded. Now in this XML, you have to understand two more functions, which is XML get and get functions. Okay. So let's go into it. This is basically for those steps. If you are going to get this data from external stages or you have the data from internal name stages. So I have created this the internal stages. I have created XML stages and then we have performed this copy into command. However, there is an alternative way to load the data directly from the UI. Now, if I'm going to write this select star from XML table, so I do have this XML file. And from here, I may need to, I would be requiring to get the information, let's say maturity date, issue date, or type of auctions, something this is we are looking for. So in this one, if you are going to write, this is going to be a column name. So And if you're using dollar and at the rate, so when we are going to use dollar, this is it is used to extract the content. But if you're using at the rate, this is used to extract the tag name. So let's look at this. The element name or to argument is going to give you the element's name, and this is going to give you the element's value. Let's find out. If I'm going to write in column name dollar, this is going to give me all the values, means whatever we do have in the in our file. This is the security term week here, term day month, security type. But if I'm going to run this the second query, column at the rate, it is going to give me the element name. This is the BPD auction data. In this also, I will be doing this lateral flatten. So let me just go with that. And for here, again, in this, you can use this two array column because we are going to, I'm going to use this two array functions and then passing it to column name. This also, because we are using a flatten, it's going to produce the same output, sequence, key, path, index value, and this. From here, I need to get the data. So I'm going to do the same thing which I did into the XML file. Okay, so I am going to use this one, but here there will be few things which is going to be different. That is now. Okay, so let's go one by one. First, we're going to use this XML get. This XML get function is going to help you to extract the extract an XML element objects. Okay, so if any argument of XML get is none, then the result will be null. If the tag instance is not found, then also result will be null. So, but one thing why we are giving it to array and all, because this expression must evaluate to an object or a variant containing an object, then only it is going to give you the output. Then only it is going to produce these values and all. So here I'm going to use this XML table dot column name. So here you can even replace it. You can simply write column name only, but this is kind of a aliasing. This is referring that this column name is coming from this table, and the dollar because we wanted to, because we have already seen it, we wanted to give the elements value. From these elements value, we need to extract this data. Now, if you will focus on it, we have given this XML get, we are passing this value, and then from this value, whatever this column name, whatever the attributes name we have it, those attributes, it is going to give me the values. It is going to extract those informations. So in this one, this is the value from where we need to extract. Then this is the column name or attribute name, what we need to extract. And this dollar is going to take or going to extract the values against that. So do not focus on this part. This is same as like we are typecasting it and we are renaming it. We are putting aliasing. Focus on this part, that first we have this value. So if I run this command only one more time, in this we got the value. In this value, so it is what I'm doing. From this value, I'm taking the security term week here. This is one of the column name. So I need this attribute. So I mentioned over here. Then this is not something I need. I mean, I need this value. So to get this value, I will be required to use the dollar symbol. And this is how we get the value. Now, there are like around 20-40 columns. Let's suppose I'm using one this offering amount is also there. I'm taking maturity date, issue date. So let me take this issue date also to show it to you. So for that, I will be writing my query XML get value, and then I have this is the issue date. So I'm going to copy this and I can typecast as a date and issue date.
Let's run this. So when I'm going to run it, now you can see because I have already processed, already typecasted the data and already aliased this. So it is going to give me the values against these columns. So this is value, maturity date, offering amount I'm getting, security amount I'm getting, CUSIP, every single value is getting over here. This USIP, I have given a string, so you can see this is a string and all. Now, let's suppose if I'm going to give you one thing, what if in place of dollar I put at the rate, then what would I get? And I am not aliasing, not converting in any format. Now, if you will look at this file last, then this is going to give you the issue date. Why? Because this extract the data elements name and dollar extract the elements value. So from here, if you need the column name and all, then you will be using this at the rate, but we need the values, and you can even look at this one. And this is coming because I told you that this is basically this column has the element being flattened, and it is useful when we are going to perform a recursive flattening and all. And you can see this is $4 week at the rate, $28 date at the rate. So this dollar means it's an attribute name at the rate, sorry, dollar means attribute value, column value, but at the rate is column name. So that's how you can flatten if you have an XML data. But now suppose you have a semi-structured flattened data where you need to deal with hierarchy data. Let's say they have customer, and inside the customer they have product, and then product they have a customer address and the product level of data that we need to process. So to do it, again, I'm going to take this example. I'm going to create one nested XML. And the same thing, what I'm going to do is I'm going to upload a nested XML file. And I'm going to load it. Now this has loaded, and in this one, what I'm going to do now, I'm going to take this data from, like, I can see this nested XML. So you will be like, let's just visualize this data and you will get more clarity. First, I have a department. In the department, I have the department ID, department name, and inside that we have employee, and then we have another root tag which is address. So the outer tag or outer element, we can say it's a department, then we have employee, and then we have this address. Okay, so how we are going to get this all information? This department ID and department name, we can easily get it using this XML data without even flattening it. But if we have to get this other data like employee and address, and you will be reaching out to it, then it is not going to give you anything. So for this, again, I'm using XML get. This XML data is my column name. And here I can do the same thing which I have used for the value column by passing this department ID, department name, and then I'm using a dollar just to get my dollar like the value against it. So if I'm going to rewrite this query in such a way, then you can see department ID I'm getting 1, 2, 3, 4, department name I'm getting, but the address and employee is null. The reason because this XML data does not have this address and employee ID. If I'm going to run this XML data and all, then it is going to give me department only. So this is department is the outer tag or outer element, we can say. In that, we can only have this department ID and department name information. That information can be extracted without even flattening this file. But to get this data, to get this employee and addressed level of data, we'll go one by one level. It's the same thing you have to do in the JSON format also. So first you see this is my first level. Then you will be going into the second level, which is address.
So I'm going to take this XML data, department ID, department name is directly from this XML data. But to get this, we have to use a little flatten. You can see over here, I'm writing, and there I'm flattening this one at the rate, because this is the XML data style value over here. Now this is going to give you the value, and from that value we need to write employee ID, employee first name, employee last name, like that you can see over here. So just see one difference. I'm referring this department ID and department name from XML data. However, this values I'm taking because this flattening is going to give me the value over here. And that value we are taking and we are extracting it. Now, one more thing. I am not including this where clause when I execute this. Well, this is, you can see, like I'm just typecasting and all, so it's nothing new. So if I'm writing this here, there are a few records. For that, I'm getting this employee name, employee last name, and all these I'm getting null. The reason, because it is taking a kind of a subquery. So as I, this literal is kind of a like correlated subquery. So it is finding one is there, but this respective employee ID is dead there, but it returned. So then it has a 1 2 against that employee ID based on this value. So it is flattening that data and then get the value. So in this case, it is going to give me some unwanted data. I'm getting 19 record, which is like those two records are not making any sense. For that, I will be applying one condition where I'm going to check this value at the rate, well, like this is going to give me the element name. That element name should be employee only. So in this, what I'm actually trying to do, I do not need the data for this entire file. Rather, I'm taking this data only when this element is employee. So for this, I will be applying this filter, and this, if I'm gonna run, I will be getting the output into the desired format. So earlier I was getting 19 records, but here I'm getting 11 records. So all those null records are being removed. Now, coming to the next thing, but still I do not have a addressed data. So if I'm going to write in the same query, XML get value, and here, let's go to the previous query here. This previous query we have is in this, and if I go to the address and I wanted to find out, let's say city. So this is my requirement. I wanted to find out the city here. Let's try it. Will I get this data? You can see the city is null. So I am going to get the null record. The reason, because this value, this query could not collocate this city in this value column. For that, I will be doing another flattening, but this time I will be referring this employee ka value to the next path. So this query, now it is going to like you focus in it, that first I'm going to make it like employee, doing this aliasing, and from this employee aliasing I'm going to pass it and then going to write it as address. So first thing, I took this from select star from nested XML, lateral flatten XML data, then using this value, aliasing at employee, but then I did another time flatten, and this time I'm taking the value from this employee and then taking the values against that employee and then aliasing as address. So here, if you will focus on it, I took the directly data, and then I took a direct department ID and department name from the outer. Then the level 1 is going to give me an employee information, and level 2 is going to give me an address information. I'm renaming it because if I do not specify this EMP and address in front of this value, I will be getting ambiguous column error. It won't be able to identify that which value we need to use to extract the employee name and all. So now if I'm going to do this and run it, The reason why I'm using this employee value and all, so that it is going to find out only and only those value where we have this employee and the address. And now why it is giving me error? The reason, because we have the second, this column is actually, wait a minute, here the column name is, I guess, this XML data. Yes, so I need to use this column name here, XML data. It's fine, I guess, right? Okay, this e dot value. Okay, my bad. This is giving me AMP. This is giving me an error because I have renamed it. Now if I'm going to run it, I'll get my complete information, what I was looking for. So you can see it. This is, I do have name, employee address, city, state, and everything. Now you can use this data for your reporting. You can share with your Power BI guy, and then they can derive some KPIs from it. So if a quick recap about this video, you have to understand about the literal, about the flatten function, what this flatten function is going to give you, how many columns is going to give you, what is this key index value, and this, how you will be extracting the data from that value column. Make sure this is going to be case sensitive, how you are going to typecast, and you need to rename it. What if you have a semi like nested layer level of data, then you will be requiring to flatten it 2 times, 3 times, depending on the levels you have in your data.
By the end of this video, you will be having a solid understanding of what dynamic tables are, how to create them step by step, and every parameter which we are going to give at defining the dynamic tables, how to monitor them. So let's get started. The very first thing is, what are dynamic tables? Before dynamic tables, if you wanted data that stays up to date in Snowflake, you were having two main options. One is the Materialized View, and second, by using a stream and task. But these were having some limitations. We are not going to compare dynamic table with Materialized View and stream task in this video. I'll definitely gonna create a separate video for that. So consider dynamic tables are like a middle ground, and you just tell Snowflake, hey, this is my query, this is my warehouse you need to use, and in this time frame, I need my data to be up to date. So Snowflake going to be take care of this rest by refreshing the data for you automatically. So dynamic tables in Snowflake are specialized tables that automatically refresh themselves based on a query you define and a freshness target. I will be showing you how exactly we're going to create, and we will be understanding all these points. Okay, so you simply write a select query to define what do you want, set a maximum lag, for example 1 minute, 2 minute, 5 minute, and specify a compute warehouse. Snowflake then take care of running your query regularly, updating the data automatically, so your table is never more than the target leg behind the sources. So under the hood, basically Snowflake create a DAG which is going to define the dependencies to efficiently refresh only what is necessary. And that will support both full and incremental refresh depending on your data and workload. For example, imagine you have a table with raw orders data, and you could create a dynamic table that summarizes daily sales or monthly sales. Okay, and this is the same example I will be taking into this exercise. So in simple words, dynamic tables are game changers that gonna be materialize the result of your SQL queries. These are automatic refresh, so these are declarative and self-refreshing pipelines. The dynamic table remove the limitation of using the single table as we have Materialized View. So you can use like multiple tables, you can join them, and you can do the union and all. What are the common benefits of dynamic tables? You can have a simplified data pipelines. You can eliminate the need of ETL process. You can reduce the development time, improve data quality and consistency. So let's say your leadership team wants to see sales number almost live. A dynamic table can power that dashboard without you setting up stream task or manual refresh jobs. We can optimize the cost also, because we can only pay for the data you store and use as dynamic tables are like kind of a Materialized view. You can chain up your dynamic table together. For example, one dynamic table cleans the raw data, another one aggregate, and third one prepare it for your reporting. So we can perform all these things, and I will be showing you all these in the exercise. But before that, let's understand the syntax. In the syntax, we can see that here, this is create or replace dynamic table, the name. We need to give the target lag. So we will be understanding target lag, what downstream means, the warehouse, the refresh mode, initialize, and the query. I will be explaining everything like what this on create on schedule means, what is this warehouse, downstream, and all that. So the very first parameter we give is the target lag. That means how up to date your dynamic table is. If I'm going to set up a 5 minute, then your data is going to be 5 minute old. And as soon as you are going to make any changes in your source table, just after 5 minutes, it's gonna be refreshed. The next is the downstream. The downstream is basically shows the dependency on the other tables. That means it is going to refresh the table whenever any upstream source table changes. I'll also show you this thing in my exercise. Then next we have a warehouse, and I'm sure everyone knows about it, that this is you need to specify this virtual warehouse like we used to do in the task. Then the next we have the refresh mode. This auto, that is by default, Snowflake automatically decide between full and incremental refresh. If you are going to mention the full, it's going to be like the dynamic table will be regenerated on each refresh. And if we do have the incremental, that means only the change portion of the data will be repressed. And the last we have the initialize. So if you want to populate this dynamic table like immediately when you create it or when you are going to schedule that. So means if I do have a target level of 1 minute or 5 minutes and I'm choosing on schedule, initialize on schedule, then this table won't be populated immediately and it will be having a data after 5 minutes. So let's utilize now whatever we have understood and let's implement some exercises. For this, come to my Snowflake. So what I'm going to do is I'm going to create one separate schema called dynamic table. And then we will be creating all these things. I have already the scripts. I'm going to share with you, create script, create schema dynamic. Now, I'm taking one very simple example of orders table, and here I do have order ID, customer name, order date, product, and amount. This is just having a simple rough data set which you can utilize for your exercise, or otherwise you can take Snowflake sample data set. Now, in this order table, I'm inserting few records like Vishal, laptop, Rohan, mobiles, and this you can understand. So to create a dynamic table on this, so I'm going to create two dynamic table on that. One is the daily sales and second is the monthly sales customer. And why I'm creating these two? Because I want to show you few other parameters. So the very first thing is in our script, we have is create or replace table name. Then we give a target lag. I'm setting is a 1 minute, but you can set depending on your data refresh. If you expect that this order table is you are fetching it from any APIs or getting this from any database or S3 and client is just populating once in a day, so you can mention like target is like or downstream or something like let's say probably you can schedule the task, or otherwise you can set after 5 hours, 10 hours or something like that, or 1 day. Okay, now in this warehouse, I'm mentioning the compute warehouse. This is totally up to you which warehouse you can utilize, you can give over there. Then the next is the refresh mode, which is auto. Otherwise, you can say full or incremental. Okay, by default, it is going to be a full, and this is going to be like otherwise you can mention this full or incremental. So let's just keep it like auto here, and then initialize on create. So in these two dynamic table, I'm making only one difference. One is the on create and then on schedule. I'll show you the difference between these two. Now, when I'm going to write select start from order, do I have some data? Yes, I see the 8 records. Okay, and then I am going to create these daily sales customer, but initialize on create, which is having just an aggregation of the total sales, and that is grouped by the date wise. So I am finding a daily sales customer. When I execute this dynamic table, this will be created on top of this order table, and I have mentioned this initialize on create, so immediately this will be having the aggregated data. You see the customer name and the order date total sales. Now, if you're going to insert any new record in that, this will refresh after 1 minute. Let's go for the monthly sales customer. Here, what I'm doing, I'm taking the target level of 1 minute only, but initialize on schedule. So when I run this, and now if you try to query from this month sales customer, you will get one error that this dynamic table is not initialized. Please run a manual refresh or wait for a scheduled time before querying. What does it mean? That either I can just simply manually refresh it, or we can just simply wait for 1 minute. Now, what are the commands you can run from manually? If you wanted to manage your dynamic table refresh, then first you can suspend it, like alter table dynamic table suspend. Resume, alter dynamic table resume, just like we do the resume or suspend of any task. If I wanted to do a manual refresh, you can write alter dynamic table, table name, and refresh. So although the 1 minute might be over, let me just check it. If not, then we can just simply set it by. Okay, now this is done. Otherwise, you could have simply done a command alter dynamic table month sales customer and refresh. This is how you can manually refresh your pipelines. Then statics is giving no new data, refresh DT count. Now let me just do it, recreate it, so that when we will be manually refreshing it, what we are going to get the statics for the very first time, or let's suppose we have any new data inserted. Okay, so what I'm going to do is I'm just going to insert another record, and I'm going to insert for this one. But before that, before inserting this data, let's understand the data, so that we will be understanding that we will be like observing the data differences. Here we do have for Vishal, its total sales is 3400. I'm inserting one record for Vishal, 34 11 11 0, so it should be 4500, something like that. Okay, now secondly, if we go for the daily sales customer, which we do have here, so let's start from daily sales customer. Here we do have this Vishal, and this is for 3 dates. Now for which date I'm inserting? This third. So here in this third, right now this total sale is 700, but it should be refreshed. It should be added, means 1100 plus 7, that should be 1800. So let's just do that. I'm inserting this record, but I am directly altering this manual refresh for this month sales customer. Now you will look at it, refresh TT count is 1, and in the statics, there is inserted record 1, copied row 3, deleted record 1. So let's see what is the data now in the month sales customer. Right now, earlier this is 8, it is 4500. Earlier it was 3400. You can check it. Select star for monthly sales. This was 3400, but now you can see it's 4500. Why? Because we inserted a quantity of 1100, and that is taking a sum of it. Similarly, if we do a daily sales customer, then in the third of this, like in of third, it should say 1800, and previously it was showing 700. So now you see that this is how it goes added, and whatever the transformation you have applied, it automatically reflected that. and you do not need to manually refresh. So whatever the target like we are defining it, it always going to be executed. Now, one more point. If I do not see any new data into my, so what exactly happened? That first, the cloud service layer is going to check whether there is new data into the base table or not. If yes, then only this warehouse will get started. Okay. So we need to understand the cost associated with dynamic table. The storage is going to be as normal like a permanent or transient table. Then this is the second thing is the cloud service compute, which will be utilizing to trigger refreshes when an underlying base object changes. If there is any change into my base data, or there is any change onto my source table. The last is the virtual warehouse compute is necessary for dynamic table to execute query against the base object during the initial population and continuous refresh. That means when we do on the refresh equal to on create, so then that time the virtual warehouse will be required. Second, going forward, if there is any change into my source data, then it will refresh it. Now, dynamic table leverages cloud service compute to assess changes in base object since the last change. If no changes are detected, no virtual warehouse credit are consumed, but cloud service compute is still utilized for maintenance and periodic checks. Got it? So if anyone wants to understand about the cost, I think these 3 points are good enough to tell them. Now, what if I wanted to check the flow of it? So for this, let's come into my dynamic table graph. What you can do, because the UI has been changed, you come under the transformation, go to the dynamic table and open into a new tab. I'm just opening it so that you should not get confused. Here you will be having all the dynamic tables. Now this can be into my different schema also. You see here, this is raw layer and this is dynamic. So because we just created under my dynamic schema, let's come to over here, this month sales customer. This is one of my dynamic table. Look at the graph here. This is connecting from the orders, this is succeeded, and this is the definition. You can check it over here, the details, and you want to suspend from here, refresh manually, add it just like we do in the task. If I want to suspend it, that's it. Okay, and this is resume or refresh manually. Now, similar thing you will be seeing for daily sales customer also. If you look at the graph, and if you want to check the refresh history, lag metric 100%, 1 minute, current like 13 second maximum it is. You can see this is like refresh duration 1.7, 5.103 milliseconds and all that. This is row changed and how many rows added, how many record got deleted. You will be seeing entire history over here. But what if I wanted to create one dynamic table to be used by another dynamic tables? Means the chain of the dynamic table. This is just going to be a very basic exercise. However, in next video, I will be creating one end-to-end real-time scenarios using these dynamic tables. So for that, let's do one more thing. Consider the same order tables. Here we do have these order, but what if I wanted to know that this Vishal is from which city, Rohan is from which city? So I am going to create one city table. There I am going to define, or I'm going to mention that Vishal is from Mumbai, Rohan is from London, Mark is from New York, Jack is from Sydney. So one customer city table I have created. I'm inserting few data over there. And then in this, I'm creating a dynamic table called region sales. And this time I'm giving a downstream. That means if I'm going to use this dynamic table as a source in any other dynamic table, so let me just show it to you this first. I'm going to create this region sales here, target like downstream. This is another new thing which we are going to observe over here. Initialize, we are fine with that. Warehouse, we are fine with that. And this is just a basic aggregated query. Now, if anyone asks what is the difference between Materialized View and the dynamic table, you know it. In the Materialized View, you cannot simply join it, right? Those are dependent on only on one table. So when you create a region sales dynamic table, this is on schedule, and downstream, there won't be any data. Why? Because it's not had been started. Please run a manual refresh or wait for a schedule refresh before querying it. But we did not mention anything like 1 minute, 5 minute, and what. Why? Because I want to utilize this table as a source to my another dynamic table. So here I'm going to create one more dynamic table, but this time the target leg I'm giving a 1 minute. This time the target leg I'm going to give a 1 minute or 2 minute I can mention, and the warehouse is compute warehouse here, and this is the product contribution, and again the basic of aggregations. But this time it's not just I'm going to take a normal table. So this order is a normal table. Customer city is normal table, means default table, but the region sales I'm using a dynamic table. So we can also use dynamic table to create another dynamic table. And here, when I execute this query, now, if you look at the select star from product contribution, why the data is there? Because we did not mention about the initialize, and by default, the initialize will be on create. Now look at it. So the data we have over here, if I look into the select star from region sales, the data is also there. So every time we are going to have this 1 minute, so this 1 minute is going to be impact on it. So if you will look at the downstream that refresh the tables whenever any upstream source table changes. Okay. Now that's it for today. If just before wrapping up this video, I wanted to show you the one more time the graph of it. So we created a product contribution dynamic tables with the help of a couple of other dynamic table you see here. And if you will expand it, so this order is going under the region sales. The region sales is created based on order and customer city. But this dynamic table product contribution is getting data from region sales as well as order and the customer city. So that's how you can chain up, or you can create a complete pipeline by utilizing your source table and dynamic tables. Means you can have your data, you can bring your source data from AWS S3, you can build that raw layer, then you perform some data cleansing into the silver layer. You can create a dynamic table in that, and the last dynamic table you can create an aggregations or create a final table using joins and some other some other checks. What if I told you that you can now build a complete data applications directly inside Snowflake without deploying a server, without setting up infrastructure, and without leaving your browser? So today I'm going to show you how Streamlit in Snowflake work, the fastest way to turn your Snowflake data and Snowpark code into a real interactive apps. In this video, we will be taking a look at what Streamlit in Snowflake is and how we are going to build our first interactive apps. I will try to create some more videos on Streamlit where we will be doing some advanced part, but in this video I have completely focused on what Streamlit is and how you are going to build your first applications. Streamlit in Snowflake is basically an integration that is going to allow you to build and deploy web applications within their Snowflake account. And for that, you're going to use Snowflake data and Snowflake compute resources. It simplifies the development of data apps by letting you or developer use pure Python code and SQL code to create interactive dashboard and applications that securely access data in Snowflake without moving out of it. So for that, you are not
going to have any headache of infrastructure setup, of any deployment pipeline, and everything runs securely inside Snowflake using Snowpark and your Snowflake warehouse. So inside Snowflake, we're going to have like the Streamlit app is just a secureable object like a view or a procedure. Your Python code execute with Snowpark. Your visual are going to be present into the Snow site, and your app uses a Snowflake warehouse for compute. You get the same Streamlit experience, but fully integrated with Snowflake compute, access control, and governance. If you know how to write a strong Python, or you have a very good expertise in Python, then with Streamlit, you can build FinOps dashboard, ML monitoring tools, and even LLM powered applications using Cortex AI. So let's just understand very few things. So the Streamlit is a Python framework which is going to turn your script into the web apps. For that, again, as I mentioned earlier, so you don't need any server deployment or any external hosting required. So we will be just creating our app within the Snowflake UI or Snowflake browser. For you can control using the RBAC, using the Snowflake roles and security, because this is my private account, and we are going to create Streamlit dashboard using the account admin. Otherwise, you have to give the permission of that database uses schema, and on that schema create Streamlit applications to that particular role. But I'm assuming that you have all these permissions, so I'm not going to cover that part. What the important command you need to know, or basically I'll say, just like we create some applications or create any object into the Snowflake, like create table name or create view name. So some of the commands or some of the syntax which you need to know is that first we will be importing the libraries, then we are going to bring the active sessions, which is basically entry point to your Snowflake account, and then what is the title or subheader you wanted to run, and after that you will be writing your data frames, or you will be writing your code to render all your visuals into the Snow site. Okay, so first thing, you will be going into the project, you will be navigating to the Streamlit new app, and then you're going to add it. So let's go to the Snowflake window. Once I come over here, there we see the option project, or we can click on the plus here. There we do have an option of Streamlit app. I have created a first Streamlit app. So side by side, I'm just going to open it. Why? Because I do not want this video to be long. So what I'm going to do is I am just going to open that. And also I'm going to create a new Streamlit app into a new tab. 1 second, I'm just going to copy this, and we will be doing that. Okay, so this is where I'm going to create my new Streamlit app. Here, the very first thing, what is the title you wanted to give it? And this app will run with the right of account admin. So make sure that whatever roles you are going to use, they should have the access to create Streamlit app on that particular database and schema. So what I'm going to do is, here, I'm going to write that first Streamlit applications. That is the name I'm going to write, and in which database I wanted to create it. I'm going to create under the YouTube Learning and the data, and I'm creating this auto schema. For that, this is the compute machine it is going to be used, compute warehouse, but you can choose any other, whatever you wanted, and I'm going to click on create. Now, when I'm going to click on this create it is going to open the new window for me, and it will be having 3 panes. Look at it. This is basically where you can see if you wanted to connect with the Git repository, then you can do that. Means this is the Streamlit files, this is the database, and this is where your code window or editor where you are going to write the code, and this is where you will be looking at a real time, like, okay, whatever the charts or whatever the changes you are going to see, you can just simply run and visualize that directly. If you guys remember, in part of 15 or 16, I have created one dashboard using the Snow site. There, I have created some normal KPIs to monitor the account health. So I'm going to do the same thing, but with the Streamlit app.
if you will look at it, the very first thing that I mentioned over here, that first you will be importing this importing the libraries, the Streamlit and Snowflake in the Snowpark. Now, if you are comfortable or you wanted more colorful visuals, then you can use other Plotly or Matplotlib, the Pandas, whatever the libraries you can import over here. So this is going to be the first import streamlet, and then I have imported the Snowpark, and there I'm going to use the get active session. If I talk about it, now the very first thing you can see, this is the title of your Streamlit app. This is example Streamlit app with some balloon icon, and this is the version of it. So this is going to be your main title. If you want to use that, you have to use st.title. So if I just make simply change just to show you that, hey, if it is going to be my first, this is my first Streamlit app. Okay, now if you just run it, it is going to change it. So that's how you can visualize that how immediately it's going to make the changes, and under that it is going to use that compute warehouse to run all these statements. Now same thing, this is subheader, which is basically I have already mentioned that the first you're going to use this title, or you can use the caption on the right. So I can just write another thing is st.caption, and here I'm going to mention I am trying with Streamlit to build my first application. And let me just run it again. So this is header, this is subheader, and then whatever the add and whatever the text you want to add, for that you have used st.write. So till this part, we are good that this is my first part, or this is the main part over here. So this is basically, we can see that kind of a header, some text informations, what is this app about, and any captions in that, anything you wanted to add, we can just simply do that. For that, I'm sure there would be not be any kind of a concern to all of you. This is title, the caption, these are something which you will be remembering, and obviously you need to know. But if you're going to do it, or if you're going to create application by yourself one or two times, I'm sure that you will be in a comfortable positions to know that which command you need to use and which function you're going to use for that. Now, next part is, after that, they have this slider. You can change this, you can change it. How they are going to create the slider is, they have given over it, this is the value. So number of high five in means you can just put the slider name. They have used st.slider. After that, they have given a minimum value, maximum value, and they have helped use this to enter the number of it. Okay, but we are not going to do that. I'm just going to show you that this is how it's going to look like. They have created this bar chart. For that, they have given this here. They are creating a data frame, and inside that data frame now, then they are creating this st.bar chart. And also they are using st.data frame with underlying querying data. And this querying underlying data is basically whatever the data frame they have created is they're going to show in the form of tables. But what we will be doing over here, we are going to create first normal kind of, I'll say, the basic account monitoring dashboard. So till this point, what I'm going to do is I am going to change it. Let's just start with the one by one. So if I just simply click on run, it is not going to show me anything except this. If you want to utilize any let's say any characters or any emojis, something, so you can just put it over here. You wanted to use maybe let's say the warehouse style or the cloud style or the Snowflake style, that you can build over here. So what I'm going to do is I am going to this is the practice I was creating before recording this video. So let me just use this title, which is nothing, Snowflake Streamlit Dashboard. And you see over here that I am going to use one Snowflake icon. So I am just going to run it. And now So we are, okay, this is going to give an error. Obviously, so just let me just close it. Why? Because there we do have an extra bracket. Now you look at it. Snowflake Streamlit Dashboard First App. So this title we are clear. The caption is basically I'm trying with Streamlit to build my first applications, but here I can write over that in this applications, I am focusing on showing KPI related to my account health. And what KPIs? Like how many warehouses I have, how many databases I have, something like that. I just need to focus on. Now, the next important thing is that you will be using get active session. This is something very important. Why it is important? Because you need to know whether your Snowflake or Streamlit, how the Streamlit will understand that we need to interact with this Snowflake account. Okay, so once you mention this session.get active session, it is going to validate. I mean, you remember when you try to interact with the Python to the Snowflake, you have to give a username, ID, password, and all the database details. But with that, it is just going to take the active sessions and you do not need to pass all these details. Now, after that, I'm going to take this helper function. This helper function is going to help me to write the SQL queries and convert them into the pandas data frames. Okay, so I will be writing the SQL query. Why? Because most of my audience is not comfortable with the Python. So I will be showing you that how you can write your same SQL logic, same SQL code, and we can build that some particular applications. I'm going to create some account health monitoring as we have already discussed. So here I'm going to take some scorecard KPIs like how many warehouses we have, how many databases we have, or average query execution. So something like that. Let's take it. So what I'm going to do is I can just simply take these queries from here, and I'm not not doing any complicated thing. You can just simply say that this is the plain SQL which we have already covered in our Snowside dashboard. We are referring the account users views, warehouse meeting history, databases, and all that. In this average query time execution, I'm taking the total elapsed time divided by 1000 to convert that into the seconds. Okay, if you have any doubt in these queries, then feel free to reach out to me. So first this, I am going to take first as a warehouse count, second as a database count, third as an average query execution, average query time. Okay, now we need to show them as a scorecard. So to show them as a scorecard, we need to use st.metric. Okay, for that, I just wanted to make it one warehouse emojis. I'm going to take some emoji just to look at good or something. So probably let's take this one. So I'm just going to copy it. And here in this app, I will be showing first st.metric, because we have already taken that as a streamlet here. So this we're going to take st.metric. After that, you are going to bring the copy that part, this warehouse one. And here you are going to write total warehouses and we can simply take here, I can simply copy it because it's going to take time. So for that, we are going to take this one. Let me just copy this part. Okay. And let me just see if everything goes good. Let me just run it. I'm trying to execute step by step so that you will be having a good clarity about it. So we do have a total warehouse is 12. Now, if you do the same thing for the total databases, average query execution. So let me do the same thing. One thing, second. Here, I am going to write total databases And in this, I will be referring this data frame, and which we have taken. This was the column name, total databases. So you will be replacing with that. Then next is the average query data frame. From that average query, we have given average execution time seconds. And this you can mention average query time. For that, I mean, you can just simply search some clock, the query time. We can just use it from the clock time. So we can just copy this one, come it over here to paste it. And the database, I'm using a simple one. Let me just run it now. So I should see 3 scorecard, one total warehouse, one a second total databases, and average query time. But there is one problem actually here. This is coming under, like it's coming basically the vertical. I just want it to be into the same order, into the same line. So to bring that into the same line, what I have to do is first I'm going to make it column 1, column 2, column 3, and then I will be using that st dot column. So I'm going to use this st dot column, which is going to create 3 side-by-side boxes. So that's why I'm going to use columns 3. If I would be having another KPI, then you can take column 4. So let me just copy that, the entire code again to save the time. Okay. And I am going to comment all this thing, do not want to repeat the KPIs. Okay, and this one too, yes, and this is going to be uncommented. And let me just run it now, and let's see how it's gonna work. So obviously now we won't be having these symbols, but you can just do that. I mean, this is totally up to you, whether you wanted to use any symbols or not. Now, if I just going to run it again, it will be having it. But if you will bring it now and you see it, these all KPIs are coming into the one line only. So we created a scorecard. The very first thing is achieved, that how you are going to run your SQL statement and going to present them into the scorecard. Now let's go with the second one. That is the warehouse wide expenditures. So I do have 12 warehouses, and suppose I wanted to know which warehouse is burning more credit. And obviously this is something which is going to be a main KPI. I just wanted to know from the warehouses wise. So there I'm going to write again the show warehouses wise spend. If you remember that we are using this warehouse meeting history, in that we have warehouse name, and along with that we have other column which is basically known as that credit used. So we do have the credit use, and that credit use we can run it over there. If I wanted to run the last warehouse credit consumption in 30 days, so I can put a where filter and all that. So in this one, again, you are going to write one data frame. This is data warehouse spend, and in that okay, and after that obviously you're going to write it equal to run underscore query. I just make mistake actually. Okay, and in that run query you can just simply write that complete statement. Select warehouse name comma sum of credit used, and that we can denote as total credit or total burn credit, whatever you want to run it. And after that you will be from, and this is the main table which from which we are going to use it. Because we are using sum, so obviously we will be using a group by clause, but I wanted to know warehouse spend in last 30 days, and to do that last 30 days we will be having a start time here, and that I can run simply where start time is greater than date at day. I will be adding minus 30 into the current date. If this one, and after that I will be writing group by all order by total credit descending. Okay, no, and then we will be closing it. Let me just, so this is the warehouse. Basically one data frame got created, but we need to represent that into the bar chart. To represent that into the bar chart, just like we use the st metric, here you will be writing st underscore bar chart. When you write the bar chart, from where we wanted to run or use these df where spent, what columns we do have available, total credit and the warehouse name. And because the bar chart, we need x and the y axis. On x axis, what we are going to put, warehouse name. So I will be using equal to warehouse name. Then on the y axis, I will be keeping total credit. Okay, this will be again into the double quotes. And let's see how it works. If I just run it now, is there going to be any change? There can be small silly mistake, I guess, with some spelling. If not, okay, now perfect. So we get one more visuals, which is going to be with the total credit and the warehouse name. This is one ABC warehouse. This was basically my interactive warehouse. This is compute warehouse and all that. If you wanted to limit only 3 or 4 what needs to be showed up here, then you can just change your query. Probably you can just make that having this total sum should be greater than 2 or greater than 5. Okay, so I can just simply alter that query is having total credit greater than 2. If I do that, then I should be only and only should be having a 4 values here. These 1, 2, 3, 4 should not be shown up, and that's a perfect. So it just basically you are or you're going to alter that everything by just writing the SQL logic. So I have 1 KPI, 2 KPI, 3 KPIs and 4 KPIs. Now let's look for the line chart also. And again, because of the time constraint, I'm just going to take the daily credited use by of this df daily. We can just simply use that. This is gonna give me last 7 days credit consumption. So I wanted today last 7 days credit consumption. And for that, because this is over the time period, so line chart will look good. And here I'm writing again from the metering daily history. And here I'm taking the credit used and this is date add. And here I am taking this in place equal to true because we are going to set uses that as an index, and from there we are taking this container width in this st.line chart. Now what this container width is going to be do, it is going to tell Streamlit engine to make the chart automatically stretch and use the full width of the page. Okay, let me run this one more time. So let's see if we will be having another chart or not. Okay, it can take time or it is running. You can see that this is where we get all these, so like, okay, this is in the time and all that. Now there is one thing which is missing. If you will stretch it over here, you can see that, okay, it is like warehouse is coming, warehouse expenditure, and this is, we are getting a line chart. We can see the time. This is November, December, and how many credit we have consumed. So on this Thursday 4th, I consumed almost 3.43 credits. Okay, now one thing I can just show you there. One problem over here is that we cannot see what is this chart is, what is like what we are trying to show over here in this chart. We are not getting a complete information, correct? So for that, I will be using again the same st.header, and here you need to write warehouse wise expenses or anything. I can just write warehouse wise credit consumption. Let me just run this. Let's see how it works. Okay, so as soon as you are going to make the changes, just try to run it so that you can validate that if everything is working fine or not. So this is warehouse wide credit consumption. I got it. Now same thing I will be making into the other also. Like means I am going to make, this is header which is coming as a big line, but you can write as a caption which is going to be in the small line. Okay, so I'm not going to change it, but I'll definitely will change this one, last 7-day credit consumption, and we'll try to do this expenditure, and there you can say last 7 days credit consumption. Again, I'm going to run it, and pretty sure that I will be having another line which is going to tell me that what this chart is going to show me, last 7-day credit consumption, and this is going to be loaded, and there you will be completely get that. Okay, now you can also denote that x-axis and y-axis. You guys can walk, you guys can just try and just do some your Googles and all. You can go into the Streamlit, and there you can do all these, like you can understand that how you can play with that. Now the last chart I'm going to create it as the storage database wise. For that, again, we are going to use a databases or storage account uses views. We do have it. And then for it, I'm going to use table storage matrix. This is actually this here. Why I'm using table storage matrix is because it give me time travel byte, fail safe byte, as well as the active byte. And these are into the bytes, but I need to convert this into the gigabyte. For that, I am dividing this. Okay, so again, I can just simply take that, copy it, and put it here. This is st header database storage uses, and there I'm running this query, and but here I'm mentioning it that this only those database should appear where we have greater than 10 GB. In the real time, you will be having your terabytes, you will be having multiple, because this is a trial account. So I can have only like certain or maybe like 1 or 2 databases which will be having some 10 like gigabytes or more than 10 gigabytes. Okay, let's see that. If you scroll down, this is database storage. I'm getting only these 3, evening, morning, YouTube learning, because I just clearly filtered it out only those database which have greater than 10. If I just make it 1, then I should see some other values. So obviously you know it that how these values got work, how this SQL work, and you can just first run these queries into the separate worksheet just to check it out if everything goes well or not. To get more confidence, you need to work on these small parts, or you need to just go slowly and all that. Now in the final one, if you just wanted to present that, hey, this dashboard is successfully loaded, and for that you are going to write st.success, and it is going to show the dashboard successfully loaded. And let me just try some success flag, if I can get something, and then we can use that. And here I can use this champion, and you have now become a Streamlit champion. Not obviously not champion, but yes, we have created a first Streamlit applications now. So it is going to show you the success that yes, this first dashboard is completed by you. Now we can just share it, okay, within your team and outside of the team. In the near future, I'll try to add some more things, because in this we don't have any slider, we don't have any filter. What if I just wanted to show the different colors to the different warehouses that we wanted to do? For that, we will be working on other libraries, but my main motive was just to make you confident to get started with the Streamlit. I hope you have liked it. If yes, then please give a thumbs up. And if you need anything from my side, or you want me to create any any other videos, please comment into the comment box. Thank you so much.